Hola, good morning. Welcome to the NLP parallel session. We will have 3 talks by Tamar Solorio, Viviana and Alvaro Soto. They are all from Latin America. Tamar is from Mexico, Viviana from Argentina, and Alvaro from Chile. And I am Ayala Rosa, and I am from Uruguay. After the 3 talks, we will have some announcement from Somos NLP, the community Somos NLP. Maria Grunduri will talk us something about the activities they are organizing this year. And if we have some minutes, I don't know if it will be possible. Maybe we can exchange some ideas, feelings about NLP for closing the session. Si pueden cambiar la pantalla. Gracias. Our first speaker is Tamar Solorio. She's a professor of natural language processing at Mohammed bin Zayed University of Artificial Intelligence in Buswai, and a professor of computer science at the University of Houston. Her main research lines are code switching, authorship analysis, and low resource language processing. Welcome, Tamar.
Gracias. Thank you, Ayala. Good morning, everyone. Thank you for waking up early. I know the social life last night might have been very exciting for you, so I appreciate that you're here bright and early for this presentation. I'm going to try to keep it short. I'm from KHIPU.AI, and today I will start with 2 disclaimers. What I'm going to talk about today is my own personal views on the field, and some images are generated by ChatGPT. I want you to caption that image. Maybe think about it towards the end of the talk, because right now I'm not giving you context on purpose, but just keep it in mind. So let's first start with a little bit of research, right? Because as Isabel put it the other day, we come all the way here, and it's important to talk about our research as well. Can you hear me well if I do that, or do I need to stay closer here? Here? Okay, I don't like to be hidden behind this thing, but okay, I will do it. And then in the second part, I want to share my thoughts on what I see is our current research environment. So, oh, wonderful. Then I feel like a rock star. Thank you, much better. I'm going to start by giving a brief overview of our recent work. CVQA, just because it's one of my favorite recent papers, and because we also have some of the co-authors in the audience, which is pretty cool. We started CVQA because we were wondering about the awareness of the multimodal language models with respect to the different cultures around the world. And so we have a question for example, here. If I show you that picture and I ask you, what is the professional status of the Indonesian people in the picture? Can you answer that question? Because we're mostly from Latin America, we're also not aware, right? So that picture shows newly admitted university students, right? But because we have also as humans gaps in our awareness of other parts of the world, we wonder if language models are also having the same gaps. And it turns out that yes, we're getting better, but for the most part, multimodal large language models are what we call weird oriented, WEIRD is a very funny acronym I learned from Radha Mihalsha. WEIRD, if you're not aware, stands for Western Educated, Industrialized, Rich, Developed Nations. AI is weird. So, well, before we started the work, we were wondering to what extent is this technology weird, and in particular, to what extent multimodal language models are weird. So we set out more than a year ago to build this benchmark with a larger representation of languages and cultures, and that will allow us to assess how much of that cultural gap is in these models, and to motivate research in linguistic diversity, cultural diversity, and to broaden the knowledge of these LLMs. So when we started this idea, we were like, well, how do we go about it? We know we need a lot of data. We need new data, because the current data is still pretty much weird, right? Images used for training these models are traditionally coming from Western countries. And so there are different options you can consider when you want to crowdsource a new data set. So one could be using Amazon Turk or similar approaches. It's cheaper, it's scalable, but we know that there are some data quality issues. I've been working on data resources for a long time, and I know that you have to spend a lot of time and effort into doing quality control. And even then, you cannot really guarantee that you're going to have a good data set. There's also the AYA model from Cohere, for example, is voluntary crowdsource, great, and no offense, but for me it looks like a Ponzi scheme, because you do some, you get a t-shirt or a cup, and you do some, you get something, and eventually you might be co-author. Our approach was more like, okay, thinking about what motivates people, what motivates us here to do something. So for once, I think we all would like this technology to reflect our cultural values and to be able to represent us, see ourselves represented in the models. But for another, we're also researchers. So we care about papers. We're evaluated based on papers. So we thought about, okay, so what if we invite people in our networks to contribute data, and we say, you have to submit a minimum of 200 data points, and then you become immediately co-author in our paper. So this is how we go about it. We send out a bunch of emails, and we said, can you help us? Would you be interested? If you help us collect data, then you become our co-author. And this is how CBQ.AI came about. There are similar efforts. NUSA Crowd and Universal NER are similar initiatives. And so yes, it kind of works. It turns out that it's still a lot of work that you still have to monitor. So the fact that you're outreaching and you're talking to other researchers doesn't necessarily mean that your guidelines are clear, or that the other people that they contact in turn are going to be reading carefully the instructions. We don't like to read. It turns out we like to write papers and send them out, but we don't really like to read a lot of instructions and guidelines. So we still, during developing this corpus, we ended up with 33 different country language pairs, 26 different languages, and 28 countries. A lot of the effort from the steering research group was spent on going to the different community groups and going back and say, your questions are not necessarily what we're looking for, we need you to be more careful. But after some effort, we did come up with a nice resource. After we put the data set together with a lot of effort and a lot of time from our contributors, we also evaluated at the time. I say it's outdated because it's already outdated, but this is a paper that was presented at NeurIPS last December. We evaluated the models available at the time: Lava, MClip, MBleep, Instruct-Bleep, Gemini, and GPT-4. And these are average accuracy results on a multiple choice question answering when you give the image and the question. And then you see two sets of results for each model, the one we call EN and the one that we call LOC. The EN means that the cultural question is posed to the model in English. And the LOC means that we give the question to the model in the local language. So now, surprisingly, most of the models are doing worse when you give them the questions in the local language, which reflects a lack of skills in low resource languages in particular. And then we also compare the best models against our CVQA corpus, again, English and localized, and then contrast with other standard benchmark data sets that are also doing multiple choice visual question answering. And it turns out that at least at the time of the paper, this corpus was reflecting a greater challenge for these existing models, meaning that our data set was representing more different languages and cultures, and therefore the current technology was having challenges. And this is what we set out to prove, right? Unfortunately, that's not the case anymore, because even though I tried to push the team very hard to not release the labels of our test data, they released the labels of the data set. And so if you ask now these current models questions from our data set, they now can answer, which maybe is good because you're increasing cultural awareness, but then at the same time, these are proprietary models that are ingesting the data that very carefully and with a lot of effort and time was curated by us, the research community. And then they take it for free, ingest it into their models, and go on and sell even better proprietary models. So this is one of the themes that I want to raise during the discussion today. I don't think this is the right way to go about it, but again, because we're a team of researchers and we run into a democracy, like I vote not to release gold standard, but I'm outnumbered by a group of researchers that also care about, making sure the data set is used and cited, and it's not necessarily that it's because of the wrong reasons, it's because maybe our environment is incentivizing a different way of going about what we do in academia. Right, anyhow, besides that, I started thinking with my research group on what else can we do with CVQA. Such a nice data set that we should be doing other things, not just multiple choice question answering. So we started thinking about, well, what about machine translation? What about multimodal machine translation? And what about we explore whether culturally specific text and images, how does adding images help or doesn't help to do a better machine translation? So now we started asking that question, trying to, again, leverage this resource and trying to pose questions that we care about. So we took the data set and we turned it. The original purpose of CVQA is to do multiple choice question answering. So we had to first turn it into caption, images and caption. So we did that automatically with ChatGPT, fortunately. And then what we did is we asked these multimodal language models to translate, and we compare what happens when you just give the text to translate versus you give the text and the image. And so here's a little bit of what I can show you. So the exact numbers are not that relevant, but these are magnitudes, differences between the model that takes only text and the model that takes text plus image. So the further you go to the right, then the larger the improvement from the model that takes the image. And then if you go to the left, this is where the results, adding the image doesn't help, which is also, we don't expect that it always helps, because even though multimodal models are getting better, it's still really hard to accurately represent an image that is just pixel values and to extract semantic information. We still need to do more progress on that end. But nonetheless, these are two models, so these are GPT-4 and Gemini. And what you can see that for the most part, when you add images, the translation becomes better. Now, this better is quantified using blue score, which may not necessarily be the right way to ask or to evaluate, because one of the things that can, first of all, these are very short sentences, so you don't have a lot of words. And even if the text changes, it may change 1 or 2 words, but this will not necessarily be reflected with a blue score. Like a blue score is just a very blunt measure. So we did a more qualitative analysis with Spanish Mexico. We analyzed manually the translations that we have in CBQA. And we look into the different directions, going from Spanish to English and the other way around. And so we quantified when we see changes in the translation of having image versus not having the image, we quantified and we saw that for this very small number of images and translations analyzed manually, we have a lot of instances where the translation is better. Like qualitatively, it's better. So I show you some examples of what we mean. Here's an example of a text-only input from our data set. The source sentence is el personaje de la estatua se conoce como el santo. If you're familiar with Mexican culture, then you would know what that means. The translation with only text is the one shown there, which is sort of okay-ish. Again, if you were Mexican, that's not how you would expect the translation to come out. But then if you give the image to the model, this is a picture of El Santo, then it turns out that the model kind of understands that it should not translate El Santo, that is like a named entity, and therefore it keeps it as is and lets it go as the character is known as El Santo. So this is a very nice example on where having the image allows the model to localize or to specialize a translation. It's not necessarily that the first one will not be understandable. It doesn't have the right terms. It doesn't narrow it down to the right entity. And we have some other examples like that. Se observa un molcajete en la imagen. It's translated to one mortal embezzle something. But if you give the model the image, it actually keeps the word molcajete, because that really doesn't have a direct translation into English, right? And so having the image allows the model to add the background to do a better translation. And then I have another example. The red powder in corn is pecking pepper, and you can translate it to el polvo rojo en el maíz es chile piquín. Sort of okay-ish, but once you look at the image, then you immediately know that the best one is to actually call elote, because this is what we call this vegetable, right? It's elote. Corn and maíz are, yes, they relate to the same concept, but in this case, once you see the picture, then this is a better translation. So these are the kinds of questions we ask, but that we wouldn't really surface unless we actually go and look at the data, right? So when we look at just the general numbers in blue score, when we look at the translations, this experiment we did with CBQA across different languages, there are differences, and the differences look small. But what kind of small? But there are differences, and if I show you these examples like this, it looks like it's relevant. Yes, you can understand the meaning of what the original sentence is, but you will have a better fit, a better representation. It will capture better the actual intention or background or origin of the text if you actually do at the images, which I think is a pretty cool finding. We are analyzing the other language pairs because we also want to know what happens in other languages, except I don't speak Arabic or Amharic. We have 26 languages and I only speak 2 of them. But the team is looking into this, and so we hope to surface that. And of course, after you surface this, then it's a question on, well, how do you improve? How can you make these models better? But anyhow, so this is so far what we are exploring to do with CBQA. We are expanding CBQA as well to have a speech modality. So we are collecting more languages and we are adding speech modality. And we hope to continue adding more languages in there. Okay, so that's the first part. Now I want to talk my thoughts. 5 minutes, yes. Sometimes in academia, I feel like that. I feel like we're losing our identity, like we're losing our reason of being, or we're losing our ground or our North Star, I feel. Where is this confusion coming from, I think? So I was doing a, again, very qualitative and small sample experiment. I searched into EM/NLP proceedings and look at the list of co-authors, only for the first 20 papers because I'm lazy. It's, you know, cannot do the hundreds of papers that we have at EM/NLP. But then I look at the first 20 papers and then I look at affiliations of those papers. And I was identifying affiliations that were not in academia. Guess in those first 20 papers, how many of those have authors that are only in academia? Bold. It's not zero, but I asked ChatGPT this question. It's 70%. I asked ChatGPT the question. Complete the sentence. 70% of papers published at EM/NLP are, and ChatGPT says, exclusively authored by academic institutions with no industry co-authors. That's wrong. It's backwards. A small sample, but out of 20 papers, 70% of papers include people from industry. Now, please, 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 do not throw me to the fire and think that I don't want industry to collaborate with us. I do, I think, I value, I think it's important, I think they play a role. They bridge theory and practice, access data infrastructure, they expose us and our students to real world problems. It's a great training opportunity for them. They give us funding, right? But what if we overdo it? What if we are overdoing it? What if we are being pulled into just the SOTA numbers, just bigger models, just this is what is important. We keep fighting for that. What about that? Caption this image. Now you have the context. So I'm going to end with a question to you. I really want to hear your thoughts. What should we do? Should we do something? Am I the only one that thinks of like this? Am I completely bonkers? Am I out of touch with, with the world? Thank you for listening. Thank you for being here, and I'm looking forward to your thoughts.
And since I'm a proud co-author of this paper, with Paula, we had a lot of questions how to translate. Like, sometimes we were using we didn't translate the proper name, sometimes we did. And I was wondering, how do you consider the standard? Because it's not a gold standard, what you have by the humans. It's more like a silver standard. So what did you do with that?
Yeah, so I've worked in named entity translation for a long time, like named entities in general. And my recommendation is named entities should not be translated. There are just some concepts, and there are just things that you cannot be translating, right? Like the molcajete may not be a named entity, but it's such a unique concept that it may lose the right meaning. But for us, if it's a named entity, definitely we don't translate.
Maybe I was thinking, for example, names of fruits, that the fruit exists somewhere else, but it's a very Chilean name of fruit, for example.
But so if the fruit doesn't exist other places, right?
In some places.
I think if the fruit exists in that place, the right thing would be to translate to what is called in that place. But if you translate it to a language where the fruit doesn't exist, the right thing to do would be to just keep the name of the fruit, right? But it's hard because it's not even a named entity. First you have to identify these concepts, and you will have to have background knowledge of this doesn't exist in that target language.
it's not a question. I just want to add an additional point to that. So, for example, in Uruguay we have the Santa Lucia Bridge, but Santa Lucia is not something that you should translate like Saint Lucia or something like that. It's just a name. So maybe you said Santa Lucia Bridge, but not Saint Lucia Bridge.
Yeah.
So it's in the same line.
Yeah. So I think the first goal of translation was to be able to map it to a target language. But once we get good at it, we need to recognize when these are things that need to be kept. Right? Sort of like what humans do when they translate a book from one language to another. They have this judgment, right? They make these judgments calls on things that cannot be translated.
Hello. During the talk, I was trying to link those concepts with respect to the talk we had on, I think it was Tuesday, in the practical session on biases. I don't remember the exact title. And I was wondering, how do you ponderate the fact that you want not to lose your identity and the things that make your cultural identity, but not to be like biased or this other stuff, like the typical example that they presented, and I think Lucia is here, I don't know. Like Mexicans all time being represented with sombrero, but do you want maybe not to lose it, but do you want not to bias those data sets? So how do you make this trade-off?
Right, so I think that's a very complicated question. What we try to do, or what is recommended when you're collecting this data, is precisely you raise awareness with the community about trying to step away from providing data that will be reinforcing stereotypes of the given culture, right? So for example, in the case of Mexico, it's much more than a sombrero and mariachi, right? Actually, I'm not sure that we have sombreros in there in CBQA. And so this should be intentionally designed, and you should train the people contributing so that they're not giving you these images that are going to amplify the stereotypes that you have for different cultures, because a culture is much more than this, right? So these the stereotypes, besides, you don't even need them because these are already ingested in these weird data sets, right? So those are the images that are there. So what you want is to contribute to provide a richer picture. I'm not sure if that addresses what your question is, but it's complicated. Yeah. There's one person in the back.
Adding a little more to the previous question, I was thinking about some examples of some words that are culturally different, but in the same language. For example, I thought about popcorn, that in Argentina only is called pochoclo, or pororo, or pururu, depending on the province where you're in. And even in some other countries are called different, even in Latin America and other. I saw that around here in Chile called cabrita, for example, in the neutral Spanish translation that we were used in the cartoons, it's called palomitas. How do you manage with all of that?
So we have not worked yet on that. We were trying to launch a project to represent different Spanish varieties. So I think when it matters is when you want to do, for example, translation from English to Spanish, and you have to choose which of the Spanish languages or regions you want to map to, right? So this is where it will matter, because if you're, for example, dubbing movies and you're or captioning movies and you want to, and it's because for an audience in Chile, then you have to use a term that represents what the culture here in Chile is expecting, right? And that has to be different from what is being named in a different Spanish country like Mexico. So, I mean, to some extent, Spanish, humans already do that. The question is, you have to have representation for that. So you have to, if you want to do it automatically, You have to have some regional representations for the target languages, right? So this is what we're trying to do, right? So you can, it's not just one language to another. You have to have one source language to a target context of the language, right?
Thank you very much, Tamar. Nobody answered your question. What can we do? I don't know. What can we do? Now we will have Viviana Kotik. Viviana Kotik is an associate professor in the Department of Computer Science at the Facultad de Ciencias Exactas y Naturales, Universidad de Buenos Aires, UBA, Argentina. She is also a researcher at CONICET, Argentina. Her current research focuses primarily on biomedical data science, with a particular emphasis on natural language processing for Spanish texts. Welcome, Viviana.
Thank you very much. Do you hear me? Hello, everyone. I want to thank you for being here, and also KHIPU organizers for such an amazing event and for keeping the details, being attentive to each detail. So, my talk is about biomedical natural language processing. I will talk about challenges, projects, and opportunities in this area. Imagine you are physicians and you have thousands of reports like the one you are seeing here, and you want to be aware of urgent findings or to dig into some report because of the contents of this report. Then it takes a lot of time to read each one of these reports. If you would be able to do some information extraction, it would be much easier to do these tasks. For example, here you have a named entity recognizer. That's identification of information units in text, an assignment of a class. You can see in blue, you can see the anatomical entities, and in orange, you can see some findings and also negation of those findings. You could also be interested in classifying lots of clinical notes based on the primary diagnosis communicated by the healthcare provider, for example. It's also interesting to be able to answer to some questions, automatically answer to some questions. And also, given the large amount of articles, of papers there, if you want to study something, for example, drug-drug interactions, you won't probably be able to read all the papers. So if you're able to do some information retrieval to automatically retrieve those papers that talk about this subject, then you might be able to read them. So these are some of the motivations of why biomedical NLP is important and interesting. And it's a very active area. First of all, because the increasing adoption of medical information systems worldwide, and also because information is in many, you can see it in many formats. There are lots of images, signals, also genetical information, but a lot of information is in textual format because it's the way that physicians can handle the information better. They can talk about what they are finding. There's also a lot of structured information. And when you talk about text, there are a lot of type of sources of information with different writing styles. For example, you have newspapers articles that can talk about health issues, scientific articles, and discharge summaries that are those documents that write the doctors when the patient is discharged from a healthcare facility or hospital. And those three types of texts are usually well written in a formal style. And you also have clinical notes that are the notes that physicians write while the patient is in their office with not much time. And also imaging reports that are reports that sometimes physicians also write from the images they take in ultrasonography reports, for example. And those two kind of reports are usually not that well written because of lack of time. So now that I introduced the importance of biomedical NLP, let's talk about the challenges of this area. First of all, the biomedical domain has a very specialized vocabulary that not everyone can read. There are a lot of orthographic variations, and there's a high presence of abbreviations. You can see that there's no nomenclature standard that can happen in the same hospital or in different services on different regions, different nomenclatures. Very ambiguous abbreviations. For example, this abbreviation has more than 8 expansions, and some also in the same domain of the medicine. And they are also often inconsistent. That means different names for the same term. So, and usually reports are written in a telegraphical style. That means no accents, no spaces between words, ill-formed sentences without verbs, and so on. So, also we need resources, at least to test systems. And there's a scarcity of publicly available corpora. In medicine, it's one of the important issues is that they are scarce. And that is because medical data, as you might imagine, is very sensitive. And there are a lot of regulations to handle this situation. For example, the Health Insurance Portability and Accountability Act from North America. That's a legislation that establishes norms for protection and confidentiality of health data, and the General Data Protection Regulation from the European Union that also talks about sensitive data, such as health data. And also each country has its own regulations. So then you need text annotated by experts, and as I just mentioned, it's very difficult to obtain the text. There are ethical committees that should approve the use of data, and that's not easy at all. And also data has to be anonymized, which is a process that's not easy at all either. It's a problem in itself. And then you have to annotate the data. And first of all, it's an interdisciplinary task with all the difficulties that those kind of tasks have. There are usually no annotation standards. When you want to have a project and annotate some data, then you have to think what you are going to annotate, if that's an anatomical entity or not, or what you should consider as an anatomical entity, and discuss with all the stakeholders. Then you need annotators with expertise in comprehension of biomedical text. That's not that easy to have people who can comprehend that and that are able and have time to do that. And also, if you want to have a good quality data set, then you wish to have a high inter-annotator agreement, and that's not easy at all because there are a lot of challenges. The challenges of annotators to understand the task, and of us that think what to annotate to understand the language and the needs. And also, for example, there's a problem with an entity boundary there that it's not always clear where the entity ends. That's just an example. And also, as every human annotation process or human process, it's very expensive. And you have to have resources to do that. Also, as you can imagine, it's very difficult to publish the annotated data, although it's anonymized, and although you have the ethical committee's approval, then one thing is to work with the data, another thing is to be able to publish the data you have been working with. So this lack of shared data hinders the advance of biomedical NLP, as you may imagine. There's another challenge that is the language. Most research is done for Polish text and for English. But as you know, for example, in Chile, the clinical notes are written in Spanish, not in English. And Spanish is the second most spoken language in the world by native speakers. So it's important to work in languages like Spanish and others. And the technical vocabulary, as I mentioned, is very specific. So when it is translated from English to Spanish, for example, although it is a good translation, it might not be the translation, as you mentioned, the translation that is used in medicine in Spanish. Other challenges of Spanish that you might know are the morphology and inflection, that are the form that words are formed, morphology and inflection also, as we have gender, how the inflection of the words, and that we have less resources, lexical, corpora, benchmarks, and so on. And also that there is, as we mentioned now in the previous talk, a lexical variety in different Spanish-speaking countries. For example, paracetamol versus acetaminophen. I don't know who of you says acetaminophen. Where? No? Colombia, thank you. In Argentina, we say paracetamol, for example. So there are variants. There's also the issue of the biases. There are demographic biases. For example, you might have heard now that heart attack symptoms were mainly known for men and not for women. That led to an underrepresentation of these kind of illnesses for women and undertreatment, underdiagnosis. Also underrepresentation of some rare diseases like Chagas, for example, and also a bias in data selection. Like not everyone has access to healthcare or to private healthcare, so the information that one works with when it's accessing to this data may not represent the population, doesn't represent the population at all. And there's also overrepresentation of data from specific institutions or regions. For example, if you use the MIMIC data set from the United States, then you're working with this data that doesn't represent our data from Latin America, for example. So another challenge is the evaluation. Here you have the same entity I showed before, that, for example, the system could have said right pleural effusion. The annotator might say right pleural effusion is the correct term, and the system says pleural effusion. So if you make an exact match, this won't work. You will have two errors for missing what the annotator said and for having an entity, a discovered entity that's not right, but instead of having two errors, that is a partial match and should be taken into account. And there are a lot of partial match measures, but there's no standard, and there's not that much work on it, and it's something that's a challenge also, because if not, the measures don't give as well as they should be. So now that I mentioned a lot of challenges, I would say there are also some resources, and there's things to be done. There are a lot of resources. There are databases of abstracts, papers, and their metadata like PubMed and PMC that are from biomedical domain. There are a lot of challenges from which we can take data to train or test our systems. There are ontologies that have the standard nomenclature of clinical terms and the International Code of Diseases. Some of them are in Spanish, some of them not. And also there are pre-trained models for Spanish too. So this schema, I want to show this schema just to understand what I'm saying afterwards. On the left, you have the general domain data like Wikipedia, then you have pre-trained transformers like BERT, Beto, Robert, and so on. And then on the right, in orange, you have specific domain annotated data, for example, from those papers. And with this data, you can further pre-train the pre-trained transformers and have an adapted model for the biomedical domain, and then you can fine-tune or post-train with a small set of annotated data to have the final trained model who will be tested. So the yellow thing, we have models, adapted models for the biomedical domain, and it's interesting to have them adapted. They have better results as if they are not adapted. So, but the main resources we have are for English, and not many include clinical notes, but also we have for Spanish. There's a lot of information in this slide, so I will guide you. I only want to show you that on top we have English resources, BioBERT and BioGPT, that are adapted for the biomedical domain, but not with clinical data, not from reports. Like they are further pre-trained with papers, so they might not have such good results as when they are annotated with clinical data, not trained with clinical data. And then we have some Spanish resources. Some of them are shown here, one of general domain, the first one, and then we have another one of the biomedical domain, but without clinical notes. And then we have some others with clinical notes. One of them is trained with a Chilean corpus, the waiting list corpus, that was used to fine-tune these models. So I now will tell you some of our projects that we have been doing in this area. our projects are mainly for Spanish. That's why I talked a lot about Spanish. They have an interdisciplinary nature, and the main tasks we have tackled are information extraction, classification, and corpus generation, where we worked a lot. From information extraction, we worked with radiology reports that are, as I told you, those reports written by the physicians, that are the quality of the text is not as good as another kind of text because of lack of time. And then what we did is named entity recognition, recognize those pieces of text and assign them a class. And here you can see anatomical entities findings, and we also take into account measures and other entities. And as more than 50% of the findings in those kind of reports are negated or hedged, like put into doubt, we also analyzed negation detection and hedge detection. We also worked in epidemic intelligence. That is an area specialized in public health and epidemiology, where the main goals of this area is to detect, analyze, and respond to diseases outbreaks. And it's based principally in two types of systems, the indicators-based systems and event-based systems. The indicators-based systems are those systems, the formal systems, that when a physician sees something like a measles or COVID case, he has to report that to the official authorities. So this is the official source, the one on the left. And there are also event-based systems that are the informal sources, like newspaper articles, tweets, and so on, and also information taken from electronic health reports. And according to the World Health Organization, more than 60% of the outbreaks of diseases are first noticed by event-based systems, the informal sources. That's why it's important to work in this area, and we have worked in this area. They provide more timely information than the formal systems. So one of the projects we did there with a lot of people was one project in the COVID era that was funded for many Argentinian institutions. And we worked in classifying electronic health records in Spanish into COVID-19 categories, like COVID positive, negative, probable, and so on. Then we noticed that as COVID symptoms were changing all the time, it was better to detect symptoms and not classify as COVID, not COVID, because it was not timely to have this information. So we worked on the detection of symptoms associated with many febrile illnesses, COVID-19 among others, diarrhea, pneumonia, and so on. There were, I don't know, more than 30 symptoms and syndromes also that we detected. And another thing we did is to work with news taken by PROMED, that is the program for monitoring of emerging diseases. And we worked in order to, we downloaded a newspaper articles that talk about diseases from Latin American countries, and we focus on some specific diseases as Chagas, dengue, Zika, antivirus, and also measles, that's not Latin American only. And we did a big annotation project, annotating, among others, diseases, their causes, the dates, the number of people affected, and so on, and worked on named entity recognition and relation extraction. In a previous project, we also worked a lot with embeddings I didn't mention, but to know the effects of embeddings training with different kind of text. So, and one of the other things we have been working a lot with is in the creation of corpus, given that we didn't have any corpus of our area. There wasn't any corpus available. So, among others, and we released those that were possible to release. In order to detect negations in radiology reports, we created, there's a trigger set of NEGEX. NEGEX is an application to detect negations for English that has been made by other researchers. And we translated and adequated this for Spanish and for German, and with very good results. It's a very simple algorithm that is done and works very well. Also, we annotated this corpus for radiology reports, for named entity recognition, negation, detection, relation, and so on, and for radiology reports and from those PROMED mail articles. And we organize a challenge. All those corpora are published, except of the radiology reports. For this corpus, we organize an international challenge where we have many participants to prioritize the corpus and the task. In those tasks, we worked a lot into defining the annotation criteria, iterating it many times until it was stable, and then annotating, calculating inter-annotator agreement, and so on. This has been done with many collaborators. The main of them are here. You can see there are linguists, physicians from the radiology domain, epidemiologists, and computer scientists. Some of them are colleagues, some of them are students of mine, and from different countries. And, well, now that I've talked about the challenges, and said so many challenges, and also what we have been doing, what I do think we can do in this area. Some directions I think could be explored in this area. Annotation is still something that should be done, at least for evaluating. Pre-training with datasets in Spanish is still something that can lead to better results. It has to be studied, the need to work with different Spanish varieties, that I think it's important. Also further evaluating LLMs to annotate, and also larger LLMs to predict and to see how they are working versus our gold standards and our previous systems, and also generation of synthetic data. Also working with lower resource languages is something that might be done, and we will try to do. And also working with image language models, as you have heard previously, is something important to do. And there's work to do, studying evaluation metrics, bias, work on smaller models for reducing carbon footprint. We usually work with models not that big, and the differences we notice are like 1 point, and we think it's important to continue in this way, because it sometimes might not make sense to have, 1 point more of F1 and using a lot of energy, therefore. And also in anonymization, expansion of abbreviations, there's a lot of work to do. And some other opportunities I think could be explored is to further explore collaboration opportunities in Latin America and other Spanish-speaking countries, and possibilities of sharing corpora and other resources. So, thank you for being here and for listening to me. That's all, and feel free to reach me out. Ya está apagado. Está apagado.
I see. Thanks, Viviana, for a wonderful talk. About the expansion of abbreviations, like everybody in the field knows that it's a pain because of all the different meanings, like you were showing, like ambiguation, like two letters can mean so many things. For me at least, looks like too difficult to make. But do you have some insights? Like, I know that it's a thing that we should do at some moment, but I don't think I know how to tackle.
I have the same sensation. At some point, we have to do it. We have looked a little bit with rules at some point, and then we left it. And we have looked for dictionaries of abbreviations, and there exist no standards for that. So no, it's something I know we should do, and we haven't done yet.
So sorry, a follow-up question. Like what we did once was to check papers, and every time there was like something in capitals and then like a parenthesis, we were like creating a dictionary for abbreviations, and I think, but we haven't done. One option is to get the context into play and say, okay, I have a list of possible expansions, and then the most likely, according to the context, is the one that we should choose, but we haven't done. But maybe it's a nice master thesis or something that we could explore.
I thought about that thesis also. Yes, the thing is that in papers, the abbreviations, well, they are usually expanded, they should be expanded, but in clinical text, they are not and are totally different. Yes, in papers, we have seen some solutions like those. When you see something between parentheses and some sort of characters that might be an abbreviation, then retrieve this, but for clinical notes it's not possible. And I've also seen physicians that are writing something and then an abbreviation appears and it's like ophthalmological abbreviation and they are endocrinologists, so it's very difficult for them. It's something to be tackled.
Thank you for the talk. I have a question. What's your opinion on using these proprietary LLMs to analyze this sensitive information?
Thank you for your question. We haven't used them and we can't use them because data has to be in servers, private servers, and if we use LLMs, they have to be on our side. We can't upload this information. So this is also a challenge.
Okay,
I forgot to mention.
I was thinking because, well, medical jargon can be quite difficult to make clear concepts, as you said, that right, well, that disease and right with all of the disease was different. So what about making, I don't know, it might be difficult to present that, but making right there as, I don't know, standard use colors for whole concepts or, well, how I call objectives with the concept.
I'm sorry, I haven't understood. Like, you can do it in Spanish if you want, and I translate.
It might be more difficult in Spanish.
Okay, sorry. I assumed you were, sorry, my fault. So you were mentioning the thing
can
of
you
the...
go back in the
Yes.
picture? All right.
Sí. Can be other language. I don't speak every language.
Yeah,
Okay.
right there. You colored, bueno, coloreaste el concepto, ¿no? Y hacer eso mismo, en vez de tener que hacerlo con, después hacerlo con otras personas, porque la misma persona va a entender lo que está escribiendo, ¿no? Entonces pasa como por dos procesos innecesariamente. A eso voy.
Okay, I'm not sure I'm understanding, but when you have those kind of things, you have to do annotation criteria and you have to say, if you find such a thing, then you should include right into the entity or you shouldn't include it. And then you wait that the person understands that right also includes left also. So you have to write it in order that they understand that. I'm not sure if I'm answering you. No.
No.
The person who writes should annotate as well. The physician? That's not possible. They don't have time. They work a lot, and in 5 minutes or 10 minutes they have to see the patient, understand the patient, say something, and take notes, and read what was written before. So that's why also the notes are not that well written, because they don't have time. But we usually have physicians annotating afterwards, but not the same physicians that annotated it originally.
Yeah, that's the problem. It's like trying to make the telephone game, and yeah. Well, thank you.
You're welcome. There's...
Thanks. Super quick. Regarding some of the comments about the difficulty of entity linking, which is what you're doing, right? With synonyms, and also linking it with the comment regarding the proprietary LLMs. So we've done a little bit of experiment so far with entity linking using publicly, like open LLMs deployed locally using Oyama, for example, or Olama. And I am amazed. I mean, I've been doing NER for years, and basically all that I've done before is worthless compared to what I can do now with LLMs, especially doing like these weird abbreviations and stuff. So I've found that if you have definitions of your entities, of the terms that you want to find, the good, like modern LLMs are super good at doing entity linking. Of course, it's slow, right? Because your list of entities, like UTMS or something, has thousands of entities there. You cannot pass the whole list to the LLM. So you have to do several passes and stuff, but I think this is a promising direction in entity linking.
I know. I understand you say the use of LLMs is a promise in this sense. Yes, we are working on evaluating this to know how well they are working in this area. But yes, some things are much easier, not everything. There's a lot of work to do anyway, I think. I don't know what you think. Thanks. Well, thank you very much.
Thank you very much, Viviana. Now we will have the third talk by Alvaro Soto. Alvaro Soto received his PhD in computer science from Carnegie Mellon University in 2002. He joined the computer science department at Pontificia Universidad Católica de Chile, where he is an associate professor. His main research interests include artificial intelligence and cognitive robotics. Since 2021, he is the director of CENIA, the Chilean National Center for Artificial Intelligence.
¿Tiene?
Super. Well, good morning, everyone. It's a real pleasure to be here. Well, again, good morning, and thank you for coming. Thank you for the invitation. It's a real pleasure for me to be here. And actually, it's very good to have KHIPU. No? We need more KHIPU in Latin America. So thank you to all sponsors and the organization for doing this, and this time Chile, and I hope this goes through all the region. So today I will tell you about an initiative that we are doing with the collaboration of several people and several institutions in our region, and it's the development of a large language model for our region. So I had a question. Is there anyone here that doesn't speak Spanish? Oh yes, so I need to do it in English then. You should learn Spanish. Okay. So I will first tell you a little bit about CENIA. CENIA is the Chilean National Center for AI. The region is mainly in the Chilean National Policy for AI. That was on 2018. In 2021, 3 years ago, CENIA was created. And at this point, it has more than 200 members between researchers, engineers, staff, and also a lot of PhD students that have some affiliation with CENIA. So CENIA has three main duties. One of the duties is research. So we publish a lot. We focus in conferences and journals. And then we had also, as a second duty, tech transfer. So we had a group of, at this point, it's around 30 engineers that are doing mostly software engineer and AI solution for industry and also for the government, mainly in Chile. And our third duty is outreach, vinculation. We, for example, lead the development of the ILIA, that is the Latin American Index in Artificial Intelligence. And also we had several activities with schools and with institutions to try to promote a healthy ecosystem of AI in Chile and also in the region. So, but today I won't tell you much about Xenia. My focus will be, I will take time, okay. Will be on the Latin GPT. And mostly I will try to answer 3 questions. So the first one is why a Latin GPT? Then what is a GPT, LLM? And third one, I will show you our how we are trying to develop this. So let's go for the first question, the why. So one of the reasons is that currently the LLMs knows not that much about Latin America. For example, if I ask one of these models what is a Chilean, I'm a Chilean, he give me some answer that, well, but then if I show me one, he showed me a very cute, creature, but it's cute, but I don't really feel so close to that, And what is the reason for this? The reason is that most of these models are trained with data that is not from our region. It is for other parts. For example, this is some data that is public, the original GPT 3.0 paper. The 90% of the data is in English. So maybe there is information from Latin America in that English part, but probably not that much. And Spanish and Portuguese, 5%. Probably the Spanish, some of them is from Latin America, but maybe a lot from Spain. And other sources. So this is telling us now that maybe this is the reason. There is not that much data. And so I try to do this, and at least for Chile, most of the books are written by Pablo Neruda. I don't know why, but Pablo Neruda, because it's so popular, and the model hallucinate, start to explain, in what part of the life Neruda wrote a book that is not related to Neruda. So it is really not good. So that's one reason. The other reason, also related to knowledge, is that this model works pretty well when for the interface with Spanish or Portuguese. So it's not about languages, at least for these languages. But in Latin America, we have a lot of more languages. And these are really not supported by the models. So the third reason is the need, I believe, to develop local capabilities to be in position to develop and to do research with this technology. So this is something that is happening in other regions of the world. For example, the people in United Emirates, they develop Falcon, and Saudi Arabia, they develop Alam, where Mistral is very popular in France, and so on. So this is data from the Stanford AI Index. This is the last data from last year, and it shows the different parts of the world where these models are being developed. And this is very sad for us. There's none model developed in the global south. So this is the technology that is transforming the world, and we are not being part of this, at least in terms of developing capabilities for this technology. So this is something that should be saying to us that an effort like this should be something that we need to embrace. So that's on why. So the second question is the what. So the key abilities of, we're talking here LLM, no? Our first model, and then maybe move to multimodal models. But this one is just about text. There are three abilities. One is the language, the syntax and the grammar. The other one is the knowledge. We want to really interact with a model that knows a lot. And the third are some capabilities of reasoning, to do plans, to have some math reasoning, and so on. And according to the different, or the papers about this, syntax and grammar doesn't require that much number of parameters. You have this paper, for example, the tiny stories, where they make a case that 3 billion, you are okay. You will create a model, that produce correct sentences in the language. So semantic knowledge, that's more difficult. It requires a lot of parameters. Takes the case of Mistral. Mistral was a model that introduced some technical innovation, mostly in the attention and other, and with a model of 7 parameters, they were able to match the performance of bigger model, like 70 billion. In most of the benchmark, but not in the benchmark related to knowledge. Did you see the paper? All the reasoning and other abilities, they were able to match, but in knowledge, all the benchmark related to know many things, they are still not doing it. And the reason is that you will need a lot of parameters with the current technology to grasp, for example, enough knowledge from Latin America. We're talking about politics, culture, art. So, and reasoning, I believe is, if you see the papers that analyze a different scale of the model, you see that the benchmark related to math reasoning start to be with good performance when you have model with more than 20 billion. So this is mostly, and for all this, you need a lot of data. For example, 1 trillion data. So this gives us some indication of the what. We need a model with more than 50 billion and 1 trillion tokens if we want to get all these capabilities and be able to be in a position to provide some good model. So, and the third question is related to how. A possible how. Now, there's many ways to do this, but I will tell you about the way that we are doing to do this. So I see this as rocket science, and in the sense that this is not something that a small group can do. It really needs the collaboration of many people, many groups. And if we want to be in a position to be an active player in this AI revolution, no, we are not player in this revolution, the space revolution. We are not really being a player. But if we want to be a player in the AI revolution, we need to create the rocket. And for creating this rocket, we need the collaboration of many people. That's something that we are doing here. And we are following what we did with the AI index. 2 years ago, we did the first version of the Latin American AI index. And we include information for 12 countries. So that was very difficult to do by a group of people in Chile. We need to really people and collaboration with people in other countries to get the data, to provide a good picture of what was going on with the AI in Latin America. So a lot of people participate in this. You can check the acknowledge and the participation in the document. And last year, actually, we did it for 19 countries in Latin America. Latin America and the Caribbean. So that's what we are doing also for the Latin GPT. And so there is a lot of people. I see today at lunch, we will join the people that we are working in the data group. So, So a lot of alliances. Sorry if I don't include, because this is very dynamic, so maybe there is some institution that I don't include it here, but there is in the webpage. So there are more than 100 people in all these institutions trying to help, to do this a reality. And so the way that we organize our group is in five groups: model, data, alignment, evaluation, and low resource languages. So I will tell you a little bit about each of these groups. So for the model, this is the pre-training. So as I'll tell you, this is our target right now, a model of 70 billion and 2 trillion tokens. For this, we had a good collaboration with a university in the north of Chile, the University of Tarapacá, that is putting in place this infrastructure. This is in 2 phases. The phase that is under construction right now is 12 servers with around 100 H200 GPUs that are connected by a fast network. So each GPU can talk directly with InfiniBand to each of the other GPUs, and they had also a network for access the data. So this is the up-to-date infrastructure that we are using for this. And in the second phase, we will double the capacity to 200 H200s. So our calculation, you can do the calculation about this. With this infrastructure, this model will be trained in 37 days. So 24/7, 37 days, you will be able to train that model. And so we are building this over Llama, and also the speed we are using for the distributed training. We are training this with clean energy, very important these days. So in the north of the country, we had a lot of solar energy in Chile. So that's one of the reasons also we are doing this there. All models, code, and weight will be open. Everything that can be open, it will be open. This is a very, even the data, we had a data governance agreement, so we are kind of fostering that all the data could be shared with the communities in our region at least. So that's pre-training in data. So we are building this corpus of Latin data. Does this work? Yeah. So this is mostly the data that we are building. And one thing that is different in the way that we are doing this is that instead of going to a massive scrapping of the web, we are going to all this collaboration and providing direct sources or links to do the scrapping of very targeting data. So we already built actually a large pipeline for this data. So it's difficult to explain all this, but what I would like to show you with this slide is that there is a complex, set of filtering and classifier that are being in place to get clean, diverse, large volume data about LATAM for the training of this model. So there's different type of filters. If you want, we can talk later about the details of this. So then one of the things is that we are trying to get this diversity of data. So we are doing topic analysis about countries. So guys from Mexico, you need to help us. We are also doing analysis of topics related to different things that we want to be, that this model is competent. And well, that's mostly about data. So what I mean, a group of data. So this is a group that has regular meetings and is the duty for that group is to provide this clean data for the training. The third group is the group of alignment. So I don't have time to go into the details about this, but this is very standard. We are using DPO, and we are collecting also actually with Somos NLP. We had I think in a couple weeks, how call this? Hackathon, a hackathon, where we will open this to all people in Latin America, so we get data for the alignment and for the instructional part of the model. So probably you will talk about that. For evaluation, in evaluation, what we are doing is that our hypothesis is that we will be able to provide a model that is good in things about Latin America. So we are creating benchmarks that measure this. No, actually, the previous talk, the first talk, you show the case that you need maybe a special benchmark that shows how this model really works with things that are important for Latin America. So there is a group of people that is creating now these benchmarks, about different knowledge, like cultural things that are relevant for Latin America, but also about our politics, our history, our art, and so on. So we are creating those benchmarks. So I hope, at the end, when this is ready, when we train on when we test on this benchmark, this model do better than the current model. And we hope that we test in the standard benchmark, we don't do that bad. We know that probably we won't be able to beat those models that are sometimes bigger, but we want to have a good performance on them, and had a better performance in the Latin benchmark. And then the third part is to include in this model also other languages that are from our region. And I will give you an example. This is already a model that we deliver on December. And this is a transductor for Rapa Nui. And that is one of the native languages from Chile in the Eastern Island. So that's you can check this in that webpage. And so we are working at this point on all this, but the one that is already out there is the Rapa Nui translation. So this is something that it requires some specific working. In this case, that's Carlos Aspillaga, the leader of this initiative, and the idea here was to build this in collaboration with the communities. That picture is in Eastern Island, and we provide we have a lot of support from the community. So we try to match also that this initiative is I already had the 5 minutes or no? 6. Good. So let me give you an example. Or maybe I have time, so I can tell you a little bit more about this. So I went in December to Easter Island because we are launching this initiative. And before going there, my view of this is, this is good to do this because, if we put these languages in these AI models, we will preserve these languages forever, because they will be there, forever. But when I got there, I really realized that that's not the important part. Maybe it's important, but it's not the more critical part to have these languages on a model. The most important part is to keep these languages alive. And what I mean by alive is that the people use it. That's the real way to keep these languages alive. If you foster the people to use these languages. So now we had a project with the government. So in the government in Chile, in all the web pages that interact with people, there will be a possibility to do that in Rapa Nui. And also we are talking with the big technology companies, so they can maybe include Rapa Nui in the social networks or whatever. So that is important also in terms of what I believe to keep these languages alive. So this is an example. So when we they test this translation, and one of the words that they introduced for the translation was astronaut. So astronaut is a word that doesn't exist in Rapa Nui. So, and I love this translation. It was like walker of the stars. So So they see that this translation is how they see this word. No? It's the conceptual view that in the Rapa Nui they have for the word. And you don't really get to that level of result if you just go plain data training. No? But if you work with the communities, you start getting a more deep view of how this communities see or use the languages and the conceptual view of the world. So by the end, I will give you a possible application of how this could be important too. So one of the things that we are doing with people in biology is that we are training what we call a plant GPT. And so this is in the scope of what I call a new way of doing science. So we are, probably a lot of people here are scientists, and the way that we work every day is just reading papers. Actually, not reading, but studying papers. And that is a very slow process. You don't read 10 papers a day. And if you are doing it right now, be careful, because probably you are not studying papers, just reading the papers. So it's a slow process. So I think these new tools like a research copilot can help you to accelerate the scientific discovery. But for that, you need to have the right tool. And in Chile, in the north part of the country, we have the driest desert in the world. The driest. But even is the driest desert, there are plants, small plants that grows there. So it's very important to study, how you do it. This is a very tough environment, but you are still, growing here. So, but for that is, plants are unique to Chile, because there's not this type of desert in other part of the world. So what we are doing here is try to create a plant GPT that knows a lot about plants and help us as scientists maybe to understand more about these things that are specific to the type of plants that grow up, in this case in Chile. This is a project that we're doing with a group in Chile. So the idea is that then scientists can interact with this research copilot and ask questions like, what do you know about the interaction, whatever, and to, in that sense, do the discovery, testing some hypotheses with the help of this copilot. So we are doing this. We had like 1 million papers. We are targeting 7 billion parameters and 80 billion tokens. So this is an ongoing research in collaboration with a group of Alexander, how's it called? The EVO. The EVO is another center that is located here in Chile. So that's it for my talk. I just want to end with an invitation. As I said at the beginning, to build this rocket, we need the collaboration of anyone, any hands that can really collaborate on this is welcome, and we are very open to that. And now we are close to deliver the first LLM, but after that, there's a long way of things that we need to keep doing, like multimodal, maybe some specific model for languages, or some specific model for some specific need of the region. And this is totally an open initiative. And together, I think, we can do it. Thank you very much.
Thank you, Alvaro, for the nice talk. I have a question about the model parameter initialization. Did you use the previously trained Llama 3.3, or did you initialize the model parameter randomly?
That's a good question. We had a discussion about this. I was in the side of, well, let's start from scratch, But a lot of people was in the side of, no, let's start with the pre-trained weights, And 2 weeks ago, we had a meeting with a group of people that developed a sea lion. This sea lion is Southeast Asia, the sea. And it's a group of very similar initiative, but in Southeast Asia. They was led by a group in Singapore, but it has a collaboration with several countries there in the area. And they said, well, probably you will have the same result, because if you had a lot of data and a lot of computing, you can forget the initial weight. Doesn't really make a difference. But what they recommend is that if you have some constraint in terms of time, I mean, you will get a good model faster if you start from the weights or the pre-trained weights. So at this point, we are following that because it's good to train models faster. So that's, I mean, usually if you do a lot of computing, you will do some catastrophic forgetting, so you will forget the initial weight, but you can converge faster if you start with the pre-trained weights.
So thanks for the talk. Regarding the Plan GPT, I had a question. You said that you were going to take papers. Can you comment more on what's the source of the papers? And also if you thought like, for instance, I had a project with agronomic engineers in Patagonia, and they have YouTube channels with a lot of information that is very regional, but they are practitioners, not researchers. So would you consider, for instance, taking subtitles from YouTube videos and learn from that?
Okay, well, thank you for the question, Luciana. And well, papers are messy. At the beginning, what we did is the straightforward solution. We got the papers, we get the text on the paper, and we train. And it didn't work well. You know? And for easy question, it provides a good answer, but when you go for more complicated question, it doesn't work that well. So one of the reasons that this is what we are doing right now is that papers has a lot of extra information. They had tables, they had reference, they had figures, diagrams. You know? So what we are doing right now is to all the parsing, the initial parsing of the papers, we are going further just the plain text. And that is what we are doing for the model. So that will be an advice at the initial. Don't just go with a straight solution of just getting the text for the paper. You need to use all this metadata or more sophisticated information that is in the papers. And I think you had more than that part of the question.
If you would consider more informal knowledge, regional knowledge, for instance, from captions from YouTube videos of practitioners in this field.
Of course, we should use that. So this is our first try with this. So it was more straightforward to get the papers because they are out there. And when you scrap the web, you will get a lot of noisy data, and you have to be careful with that. No? We know that the current model has some problems with bias or toxicity that are getting because they are just massively scrapping the web. But when you go to papers, it's not that way. You will get clean information. So that's the reason we're doing that way. But you are right. If you want to have a more complete model, probably we'll need to also go to more extra information sources, like books, for example. And others. So that was our first. We were really busy developing the Latin GPT, and this is something that we do an extra. So we, as I told you, we tried the first solution, just train it. You know? We had already the capability to train a 7 billion model, but it didn't work well.
Thank you very much, Alvaro. I'm sorry we can't have any more questions, because now Maria will tell us, for those who are interested, if you want to go to I don't know if we have a coffee break now. If you want to go, you can go. But Maria will tell us something about Somos NLP.
Thank you very much. I promise I'll be short, but of course feel free to go to the coffee break. Oh, where's the... Does this work? Oh. Okay. So in that QR code, there's like all the links I'm going to talk about. So if you want to just like scan it and then go, that's also fine. The good thing of speaking after Tamar, well, like all the speakers today, is that I don't have to motivate why we need to include many languages, many cultures in LLMs. So just to stress this out, we're 600 million Spanish speakers. Also, so this is a language spoken in 21 countries. And this is not the only language in this country, so we have like many other indigenous language, co-official languages. So we should really try to include all this diversity in the next generation of language models. So for this, I founded Somos NLP 4 years ago. Somos NLP is a community, international community of Spanish speakers that we're interested in NLP. Some people are from industry, from academia, but what we try to do is to create more open source resources in Spanish and other languages from Latin America, Caribbean, and Spain. We do this by organizing hackathons like the one I'm going to present today, and also we also try to organize talks, workshops, and everything is free, open source in YouTube. In the Hugging Face Hub, you can find everything. So we've been organizing hackathons for 40, this is going to be the 4th edition. We have every time a lot of great participants for all over the world. We've created a lot of cool models, cool data sets, cool workshops. Everything is, again, online. And one of the follow-ups of last year's hackathon is La Leaderboard, which I was presenting in a poster 2 days ago. This is already live, so you can go ahead, check. We have already evaluated 50 models, and we accept submissions from the community. So if you want us to evaluate your model, you can also send it. We're going to take some time, but we're going to evaluate it. And also, we would like to extend the data sets, the evaluation data sets that we have, to include more Spanish varieties, languages, also some ethical considerations. So if you also have evaluation data sets, feel free to reach out. We would love to include them. And for the hackathon of this year, we would like to focus on not only languages, as Alvaro was saying, and also Tamar. It's really interesting to do multilingual, but also we need to focus on having multicultural LLMs. So we would like to focus on 2 things: cultural adequacy, not only cultural knowledge. So for that, we want to create a benchmark and also an alignment data set. So these are going to be part of what we're going to do, use for the first training of the Latin GPT, as Alvaro was saying. So Thenia is greatly collaborating with this. The idea is that, for example, we're going to have different challenges. One of them would be, for example, a team from Chile would create a data set, then they will align a model, and, for example, just create a presentation. That would be the minimum example. Then another team is going to create a model, a data set, align a model, and if people is interested in academia, we also help them create or write their first paper and publish it in a workshop. And the other option is when people is more interested in industry, we also help them create an MVP of what could be a product. And if they're it's a good product, then maybe it would also have some funding to for a startup. And the idea is that cross-sectionally, as the organizing team, what we want to do is just collect all these really cool data sets that the teams are going to create and create a benchmark and an alignment data set. And for this, there will definitely be a paper with many co-authors, the ones that we really like currently. So yeah, please join us. There are many ways of participating, so you can either be one of the teams, you can also volunteer, you can be a speaker of one of the events, talks, workshops we're going to organize, also a mentor, and of course we are looking for sponsors, so it can be either for prizes, in-kind donations, and also just visibility is always great, because we would really like to include every country. So yeah, visibility is one of the also easiest and more impactful things you can do to help. So yeah, just to finish, to be inclusive. If we really want LLMs to be inclusive, we need to include the community, as like many like initiatives that we already have. So there's the hackathon, La Leaderboard, Latin GPT, CVQA, and I would also like to mention one last one, which is Include. This Include is already there's already a data set that Cohere and EPFL and many other institutions created, and it's online since December. But now we're trying to extend it because the first version only includes Spanish, Portuguese, but Spanish is only from Peru and from Spain, so it's definitely not inclusive, and also none of the other languages spoken in Latin America is included. So yeah, we're collecting exams, tests from any kind, any topic, any language, any country. So yeah, this was all. I hope this was quick. Thank you very much for staying.
Bueno, muchas gracias a todos por haber estado acá. Disculpen el retraso. Habíamos empezado un poquito tarde, entonces nos tomamos unos minutos. Muchas gracias por todo.
De nada. Estoy también en la silla. Ya, perfecto, los voy a dejar allá arriba.
Es del presentador,
es que por eso voy a
creo.
pasárselo al chico para que vea lo de la batería.
Bueno,
eso lo vengo acá de la universidad.
Estos papeles estaban acá, los dejo.
quedo aquí para no coger el micrófono. No comparto. Esperamos. Y yo lo voy a hacer en PDF, ¿cierto? No hay problema.
No, debería ser tu pantalla.
Ok, entonces la desconecto, ¿cierto? Por ahora, ¿la dejo ahí?
hay un pase slide por si necesitan.
Ah, ok.
Ahí
Bueno,
tiene,
creo que van a tener la laptop.
ahí tiene el USB.
Ya,
Entonces
ok.
lo conectas en la laptop o en el multi.
¿Quieres...?
Para señalar, no. Y también está el micrófono en solapa si es que alguien necesita.
¿Quieres el micrófono en solapa o vas a estar aquí nomás?
Como tú prefieras.
¿Vas a caminar o vas a quedarte?
¿Ya? Sí. Tiene toda la... Va a quedar abierto. Oye, lo hago al final. Si no, también hay micrófono volante. Como ustedes prefieran. Mira, te explico por si alguien quiere usarlo. Ahí está el on-off.
Ah, ok.
Se apretan esas patitas de los lados para abrir la tapa.
Ok. ¿Y Johan dijo que no iba a usar?
No, no lo voy a usar.
Ok.
Yo ahí lo dejé apagado. Tienes
Ya.
que mantener apretado para prender y ahí tiene un mute.
Ya.
Eso es todo.
¿Qué entonces a ver si le empezamos ya de una vez?
Voy para arriba y te hago la señal que está todo aquí.
Perfecto. Okay, bienvenidos. Welcome everyone to the RL parallel session. This is reinforcement learning. If you're not here for reinforcement learning, well, now you'll learn about reinforcement learning. So we have 3 speakers today, really exciting speakers. And the way it'll work is each one will speak for 25 minutes or so, and then there'll be some time for questions. I'll leave it to each speaker to decide if they want to save questions for the end or if they'd like to be interrupted, but I'll be timekeeper to try to keep it within 30 minutes for each speaker. So first off, we have Johan Samiron, who is originally from Colombia, and he's actually one of the success stories of KHIPU. He attended the first KHIPU, and that sort of started his career so far. He's a PhD student at the University of Montreal and Mila, and he's been doing a lot of really exciting stuff with reinforcement learning, combined with deep networks in particular, and he'll tell us some about that right now. So without further ado, please welcome Johan.
Okay, hello everyone. Hope you are enjoying the summer school. So today I'm gonna present sort of like an overview about a research problem that I have been exploring for the first 2 years of my PhD. So let's start with a question. So can neural network learn forever in deep RL? So, okay, before like jumping and try to explain a lot of like some paper that I have been reading and that are really important for this topic and some paper that I have been involved, I would like to quickly explain what is deep reinforcement learning for those who don't know or haven't worked before on this. So basically we have an agent and we have an environment, and the idea is like try to find the optimal policy. So so the agent will be interacting with the world, with the environment. So we take an action in the environment and then we receive a reward and a new state, the state. So the goal, the general goal is to maximize the expected cumulative reward, which is like, and for doing that, what we want to do is like find the optimal policy. So let's just see this example. So this is a mini grid. So this is our agent and we have a goal and we have like two negative rewards, which are the bombs. So, and the idea is like, okay, I want to find an optimal policy to achieve my goal, so how can I do it? So this is like a trial and error. So basically the idea is like, okay, how can I achieve the goal? So at the beginning, our agent will be like exploring, so the policy will be like random, but at the end, when the policy converge, you will find the optimal policy. But there are many problems. Like for example, we want that the agent be sample efficient. It means like learn a policy quickly, and we want to also solve like the problem that overfitting in deep RL. So we will be focusing on this problem. So and then like once our agent learned an optimal policy, we will see something like this plot where we find like, okay, the optimal policy, which is the pi star. But then like this is easy, and we can use like tabula rasa for finding the policy. But if we want to, let's say like, okay, we want to solve like complex problems, like for example Atari. So we don't want to use like, we cannot use like tabula rasa because it will be a bit complex, and it's complex. So in this case, like let's say like we want to find a policy for Atari. And in that case, we use like neural networks, which parameterize our value function, which in this case is like the Q value. So the idea is like, okay, I feed our neural network with some images from the game, and we want to find like through the interaction with the environment, eventually we will find the optimal value function, and from the value function, we will get the optimal policy. So yeah. So this is like a quick overview about deep RL. Also, that's why it's deep reinforcement learning, because we are using deep neural network. So something that I have been interested to explore during my PhD is about like, so when we are training these agents, something that is common is like you see that, like for example, the QN start learning a good policy, but at some point it just plateau the performance. And what we expect is like the performance continue growing. Like if we are not achieving like the maximum reward, the maximum score, why not our agent is continue learning? So there is an issue about overfitting, and like 2 years back, someone from Mila like explained the problem about plasticity loss in deep RL. So I will just read the meaning of plasticity. So it's the ability of learning system to adapt to changes in its environment. I will explain a little more with some examples, but this is the motivation. Like for example, what we want is like in the past, we use like a cell phone, but now we have a different cell phone with new features. And we as a humans, we are learning different, like we are frequently updating our policies. So if we want to do something like that in deep RL, and we want to do something like this, we don't want just to find an optimal policy at some point, and then when we are evaluating on different tasks or similar tasks, like changing some, like let's say the background of the Atari, and it doesn't work properly, is not something that we want, that we expect. We want to solve this issue. Sorry. Okay, so grounding a little bit this problem is like, okay, this is good, but let's see like in Atari. So if I train in this game, and then I just test this policy in the same game, but I just change the background, it doesn't work well. So then if you go and see what's happening with deep RL, what you observe is that you just like, your policy is not like learning, it just plateau. So we want to solve that issue. So motivated by that, because we want to like train agents that behaves well on different type of games. So, and we are observing many problems with deep RL when using deep reinforcement learning. So I feel motivated to explore, but something that is also important to mention is that deep RL itself is a really hard problem. Why? Because the temporal difference, we have a bootstrapping issue, is that opposite to supervised learning, where you have like, for example, the label of your dataset, which is fees, and you know how to optimize that neural network. In this case, like for example, the target that when you are minimizing the TD loss that I will present later is changing. So like it's a really hard and complex problem to minimize. And also like the general thing that everyone, I think, is trying to solve is like, we want to train policies that generalize across different domains. So okay, let's move about like let's speak about the plasticity phenomenon in deep RL. So there is a paper which is called the primacy bias, where they show that, for example, if you interact with the environment and those interactions are wrong or are not good, so then like you won't be able to recover from that. So your performance will be bad, and like how can I recover from that? An example is like, for example, if you are learning to play like guitar and you have a bad experience, so it's really hard at the end like to play pretty well. So you have to forget that if you want to learn a better policy. So that's like the intuition behind this, and this is from cognitive science. So what they propose here is like, okay, what about if I reset some layers? So they did it for SAC, self-autocritic, and also for SPR, which is a self-predicted representation on top of DRQ, and they apply reset. So the idea, okay, before explaining about the primacy bias and reset, it's pretty important to explain to you about the replay buffer. So when your agent is interacting with the environment, you will be storing saving those transitions in the replay buffer. This is pretty important because, for example, I know some guys who are trying to explore the idea of resets for PPO, but PPO doesn't use like replay buffer, so it doesn't work pretty well. But in this case, when you have the replay buffer, it works, and why? Is because you have knowledge in your replay buffer. So the way that we minimize the TD loss is that, at least for value-based, that is, I think we will be focusing on value-based for now, is like you sample uniform, like some transition from your replay buffer and minimize your loss. So also we have this concept of replay ratio, and it's about like, for example, you are interacting with the environment, and then you just like update your gradients once you interact with the environment, right? But you can also like, how can I reuse the data that you collected and you have in the replay buffer? So this is like the replay ratio concept, and it's pretty important. So you can also think about like, okay, if I have a data collected and I reuse that data for a lot of time, it will overfit, right? So why do they want to do something like that? But this paper shows that you can do it. You can reuse your data in the replay buffer, and using resets, your performance will increase a lot. So just like some quick results, this first plot is like, for example, the blue line. So with the blue line, you start is SAC, and you start like interacting with the environment, but you won't update your parameter. So you will you won't be interacting with the environment. So basically, you will be just like interact with the environment, collect samples, and just like update your parameters with that replay buffer. So you won't interact with the environment. What is happening is that it collapses because it's like the primacy bias problem. So, and in the other one is just like online, so it will be just like interacting with the environment, and we can see like better performance. But there is an interesting question here. It's like, okay, is because the dynamic of reinforcement learning, or is because the data is not good enough? So what they show is that, for example, we have like SAC failing, and SAC with failing agent buffer. So the point here is we have this like agent who is not working well, and we just collect that data. So we think that the data is wrong, it's not good enough, but then we just train a new agent with that data, and we can see that the agent is capable to learn good policies. So then it's like, okay, the data in the replay buffer is good. The problem is like with the dynamic of deep RL. So they tested with, and just like, so these two results, we have SAC and SPR with resets, and they scale the replay ratio. So now we can see that the performance is larger. So now we have this paper is that, so if we use reset, right? So what is happening is like you learn a policy, but when you reset your ways, then you just like go down, drop the performance. So imagine that you are doing something like this in robotics. This is pretty bad because it's like, okay, I'm training a policy, and at some point I reset, so the ways are you don't know anything, so you will behave bad. So you can like destroy your robot or something like that. So that's not like, we want to improve that mechanism. So what we do is something like, okay, we have like this CNN layer, and it's like, okay, we know that some neurons are like dormant. It means like they are not getting activated. So what I can do is something like, I find those neurons and I just like perturb or reset those neurons. So they tested on different environments, and with they compared with different baselines, like reset or weight decay. So this is, I think, the good summarize. It's like we have DQN and DQN plus redo. So we have the dormant neurons. So if we do the dormant neurons, we can see that the performance is bigger, which is the pink curve, and the other one is like the blue one. So it's like there are more, this is like the baseline, and once we apply redo, we can see that there is better performance. So of course, like if you want to understand a little more, we can chat later in the coffee break, and I can explain the math behind this. So this is just like the baseline, and this is what I was saying before. Like for example, if we apply reset, so you will have that behavior, which is not good for some applications. And instead, if you use like redo, which is the pink one, so we will get better performance, and it's more like a stable behavior. So also something that is interesting is about how redo can help you to deal with when you are increasing the replay ratio. So if we start like increasing the replay ratio, which is good, there is a paper which is called Breaking the Replay Ratio with Reset, and the performance is so big, so we should aim for increasing the replay ratio. So this method is also helping. So now, okay, so let's think about like what I presented before. It's just like a static environment. I mean with a static environment is that you only focusing on training in one single game. But what about if I, for example, I have 5 game environments and I just train in one game and then continue training in another game and come back and train in the first game. So the task will be a bit complex. So in this paper, what they showed is like ReLU doesn't work pretty well. And I think in the supervised literature, it has been shown that ReLU is not a good activation function. Why? It's because we find like a lot of dying neurons. And why? You can think about like, for example, if you have like a latent space and you have an output from your neuron, and then you apply the ReLU. So if you have like negative values, so that output will be 0. And in that case, sometimes like the neurons start like output, like give an output like 0. So then if you just calculate the back propagation and so on, you won't pass gradients and you won't be learning anything. So what they propose is like, okay, let's use like concatenated ReLU. And it's also interesting. I will say why. So first, this solves this problem of feature collapse or performance collapse in deep continual deep RL. But also let's think like, for example, the idea is like, if we want to solve complex problems, we want to increase the capacity of the network because we want to have better representation of the environment, right? So in this case, if you see like this concatenation, it's like, let's say like we have an output of 512 of a dense layer, and if we concatenate it, so we have like 1024. So we are increasing the latent space, so we can have a better vector for representing your features. So this is a new environment. It's not a new environment, but it's a new setup. So the idea is here is like, for example, you train in Alien, then you move to Atlantis, and so on. And then once you finish Centipede, you come back to Alien. So this problem is more complex, and you can see, like, for example, the blue thing, a curve is like, okay, I start learning and I found a good policy. Then I went to Atlantis and I also found a good policy. At the end, when I come back, see what is happening with the blue. So the network is not capable to learn again a good policy. So this is like loss of plasticity. It's really hard to fit the new target. Instead, if I just apply reset, so here, there are two components, catastrophic forgetting and loss of plasticity. So I won't be speaking about catastrophic forgetting because you can say like, oh, I was expecting that when I came back, my policy should be able to solve the problem of Alien, but no, this is not the case. I'm focusing on why this is not learning again to to learn the new policy. So if you see like, at the end, the network is not capable to fit the new target. So this is like the plasticity loss problem. And we also have like this, like for example, then they apply, say, ReLU, yeah.
So within alien, what's switching? Is he switching from alien to Atlantis to boxing?
Yeah, exactly.
Okay, and then so the different plots on the bottom are what?
Okay, I mean like, for example, each like 25 millions, let's say, oh, sorry. I changed to Atlantis, and then I changed to boxing, and so on, and then come back, yeah. No, I didn't. They didn't. Yeah. Okay, so this is like, okay, then they tested like say ReLU, and then they did the same. So you can see that the say ReLU is helping, right? Because when you like go from centipede to aliens, the network is again capable to learn the policy. So a natural question is, okay, this is obvious, maybe because if I just use like ReLU and C-ReLU in alien, just focusing on just one single game, which is this. This is not like the continual DRL, it's just like I'm training just for alien and Atlantis. I can see that ReLU works much better than C-ReLU. So it means that C-ReLU is powerful technique for continual deep RL. So that's something that I want to clarify. And also, this is also cool for those who want to explore more. This topic is about, like, for example, breakup. So it has the option to change the mode. So, like, for example, it's the same game, but in this case, we hide some type of information from the game. Or, for example, we have space invaders M0, space invaders M1. What is the difference? It's just like in the first one, these elements just move horizontal, in this case, horizontal and vertical, and in this case is height. So that's interesting because if you train in this, what you expect is that your policy works pretty well on this one, but it doesn't.
So this is in the standard alien environment, they have these variants available, or this is something new?
No, this is something new, that's another repository. Yeah, but they are using that one. So this is just like the mode. So we can also see that, like, for example, the C-ReLU is also working when we change the mode of the games, and that's all. So I just want to show this plot because there are a lot of things. There are a lot of things to do. Like, for example, this is like if you train from scratch. I mean, if you just train a policy for breakup, not doing continual deep RL, you get this performance, which is so high, right? When you are doing continual deep RL, even if you use like the C-ReLU and you are getting good performance, there is still this gap. So we would like to close this gap. Okay, so let's now speak about another project that some guys from Miller also work on this, and it's the bigger, better, faster human level attack with human level. So the idea here is like, okay, we want to train a data efficient model-free RL. Yeah, and yeah, that's the idea. So what we propose is like the BBF method using a bunch of tricks based on what we explored before about the loss of plasticity and overfitting and deep RL and so on. So, okay, before moving that, one of the key things that from this paper is like increasing the capacity of the value function. So you will say like, okay, what is the function approximation? Basically, what I explained before is like we are using a deep neural network for learning the value function. So in the standard DQN paper from Nature, they use like the 3CNN and the ReLU, and then we have like two fully connected, where the last one is like the value function. So what we can do is like, okay, maybe let's make it wider, or we can also do it like, make it deeper. So in this paper, the BBF, we explore with both, like making wider the CNN, and deeper is like, we use like the Impala CNN. So it's a bit different what I showed before, because we are using the skip connections. So, and it's a standard architecture, so that's why we choose Impala CNN. So in this paper, what we show is like, if we increase the scale, which is a really hard task in deep RL when you are training from scratch, is like we are able to like get really high, good performance. in both cases, using the Impala CNN and also the increasing the width. In this plot, it's really interesting also because if we increase the replay ratio, we are like, the performance is increasing. And this is like the summary plot is like, for example, what people have been doing is like, we trained Rainbow for 200 millions, right? So in this case, we are only comparing like for 15 millions. This is Rainbow, and this is DQN. With our BBF paper, we only need like 1 million to match what DQN Rainbow, found in 15 million. So this is pretty exciting. Now you will ask me like, okay, Johan, how did you do it? So of course, like we use a lot of things, like for example, scaling the architecture, but I will just explain like the main components here is like annealing and also the reset. So why this paper comes to this presentation is because if you see, like we are also mitigating the issue of plasticity loss when scaling the architecture. So in this case, we have like we have the annealing for the gamma and also for the multi-step learning. And so for the annealing, we move from 0.997 to 0.99 exponentially. And in the case of the multi-step learning, we move like from 10 to 3 during the training. And now we have the harder reset and reset. So you will ask me like, okay, what is the difference between those two? So reset is like fully reset. We reset the two, just like the penultimate layer, not the, both. And for the harder reset, we do like something which is called shrink and perturb. So what we have is like, we have some random ways and our reference model. So we just apply this. So why harder? Because we are saying like the 50% of those ways are random, and it helps a lot. And just to conclude our talk, it's about, this is cool, right? Like increasing the capacity, like mitigating the problem of mitigating the loss of plasticity, help us to increase the capacity of the network. But, and also keep in mind about the redo paper, like we found that some papers are not activated. So we were thinking about, okay, how can we, like, what else can we do? And we found like pruning the network when we are scaling the capacity is pretty helpful. So the idea here is like, we have a dense network, like we are using both the CNN and the PALA, and we follow this schedule for 100 million, and we just like pruned. So what we can see is like, just using 5% of the parameters of your larger network, we can improve the performance. So it's pretty excited this, because like for inference, for example, it will be faster, right? Because we are only using 5% of the parameters. And this is like one of the cool plots is like, for example, if we scale the width, like 1, 2, 3, 4, 5, and we only like pruning 95% of the parameters help us to scale the capacity for finding the good, the optimal policy. And here we have like, okay, what about the other baselines? So we compared with reset, with redo, with weight decay, L2, and so on. And what we found is like pruning is a better technique for using the large capacity of our networks. And this is just like about like scaling from 1 to 5. But still there are a lot of things that we want to explore. Like for example, in the RL, we have tried like, okay, what happens if I move from 5 to 10? It's still not working well, but we are working on that now, these days. So thank you so much. These are some references if you want to just check and read and explore some ideas. Thank you for your attention.
Hello. I don't work with reinforcement learning, but I like the idea of redo. How you tried it with supervised training?
With the what, sorry?
With supervised settings, in supervised learning.
I see how people do it in supervised learning.
No, if it can be, if you have experimented.
Definitely, but so we have. There are some experiments in the paper, and I think they showed that maybe this phenomenon is not present in supervised learning. So the phenomenon that we are observing in this paper is just because the problem with the bootstrapping and the TD loss, because we don't have like a fixed target. In opposite in supervised learning, we have a fixed target, so it's easier to optimize, but in the case of DRL, it's a bit more complex. So because we did it for a CFAR task, and we didn't observe like this amount of dormant neurons increasing. So we think like maybe it's not needed in that case. But of course, we can do it, but maybe it's not needed.
Okay, thank you.
Yeah. Maybe one more question. Okay, so your hand first. And Johan will be around, so we can ask, you can approach him later.
First, thank you, Johan, for the great presentation. And I think also as the previous question, I'm not an expert or I'm not even doing RL, but I wanted to ask you, what's your take? Like you presented, plasticity is a problem, etc. We're doing this and that for fixing it. And I wanted to, and there might be a lot of approaches, like we're saturating the capacity of the network with, I don't know, good performance is only found in, I don't know, holes in the optimization landscape or whatever. And there might be many factors, but I wanted to ask you, well, like, what's your take on what's the biggest or most important factor that we can do or play with to improve this? Thank you.
Yeah, thank you so much. It's a really good question. So we and other colleagues are trying to understand, like, formalize, like, what is loss of plasticity? Because I think what we have been doing is, like, characterizing loss of plasticity. So we are showing that this phenomenon is present in deep RL. So we are playing with, like, for example, the architecture, the learning rate, the batch size, and so on. But there is no an answer yet for, like, what is the main thing for mitigating or for answering your question. I think I don't have the real answer. I think, but we are, like, definitely we are exploring that. Like, we want to understand, like, we want a good definition of about what is loss of plasticity, because we don't have it yet.
Thank you. Okay, next up, it's my great pleasure, I'm just going to get the timer. My great pleasure to introduce Kevin Murphy, which probably most of you saw him yesterday. He gave a great talk, and today he's going to tell us about one of his recent projects with reinforcement learning. He's a research scientist at DeepMind, and just, you know, a fantastic machine learning researcher in general, not just reinforcement learning. You probably have read some of his books. He even has a reinforcement learning overview that he put up recently on Archive that's really good. And if you want to get into reinforcement learning, it's a great reference for doing so. So please welcome Kevin.
I'm just going to need a minute to set up here. Cool. All right, thanks. Good morning, everyone. I don't think I'll need the full half hour, but maybe. Interrupt me if you like. Sure, we can run down the clock. So I'm going to talk about model-based RL. So we heard from Johan about model-free RL, where you just learn a Q function, but there's no explicit model of the underlying dynamics. So today we're going to learn a model of how the world works, learn a world model, and then use that world model to help learn a policy. Okay, so why? Well, if you look at some of the sort of headline results in RL, so we heard about Atari earlier, AlphaGo, of course, AlphaZero, and in robotics for like manipulating objects and locomotion. Pretty much all of these success stories have relied on the fact that you have access to a fast simulator and you can just call it as much as you want. And these algorithms are extremely data hungry. So in Johan's talk, a lot of the plots were going out to 200 million steps on Atari. Now, he and his group have been working on pushing that down to like a 1 million or 100K, so aiming for sample efficiency. So if we think about applying RL in real worlds, in most applications, data is expensive to acquire. In supervised learning and LLMs, you can just inhale the internet, and it's like you're just leveraging the prior work of humans. But with interactive environments, often it's expensive to go query the environment and collect data. So we want to focus on, if we want to make RL more broadly applicable, we need to tackle this sample efficiency issue. Okay, so these applications, so Atari, Go, and this is called Dactyl. This is when OpenAI used to do robotics. And then they stopped and they did ChatGPT, and now they're back into robotics, apparently. Anyway, it's a system called Dactyl. They had a simulator, and they trained the policy in simulation using PPO, and then they did some domain randomization, applied it in the real world, and it worked. Okay, but in general, you don't have access to the simulator, you just have the real world. So what can you do? Well, you can learn a proxy model of the real world. You could just learn a simulator, and then you just apply RL, and you're done, right? So that's what model-based RL is all about. Now, it's a bit more subtle than that, because the processes interact, because the data that you collect, that you use for learning the world model, has to be chosen by the policy. So this explore-exploit problem that I talked about yesterday. And also your model will usually be wrong, at least initially, because you haven't learned enough data yet, haven't seen enough real-world data. So it might distract the policy, and you might learn suboptimal behaviors. So it's a little trickier than I made out. So I'll talk about how to address some of these issues. So a key question when tackling model-based RL is what kind of model are you going to use? Okay, so one thing you could do is you could imagine building a generative model of the world where you model everything you see. So let's say I'm going to focus on image-based environment, so you model every pixel. And you want to predict what the next pixels will be given the past history of data. Let's suppose it's Markov, so you just need the previous frame, and conditional on your action. So that's what a world model is. It's just a predictive distribution over the future given the past as a function of your actions. And that's a conditional generative model. And so, you could use diffusion, you could use a transformer, you could use a tokenized LLM. So people can and do all those things. If it's a low-dimensional setting, you can just use an MLP, like in robotics. Now, in high-dimensional settings, you don't want to directly model the observations, so you typically introduce a latent space, denoted here by Z. So you might encode your observation into a latent space, you push it forward through your dynamics, and then you decode back to observation space. So you're training the model to predict pixels, but you have this latent abstraction, and your policy might either be a function of the latents or a function of the observed. So the main disadvantage of this is that you're modeling all of the visual details of the world, and not all of the details are important for policy, for control problems. This is low dimensional typically, yeah. So it's a compression of the data. So think variational autoencoders or Dreamer. Dreamer is exactly, for those who know Dreamer is like a sequential VAE. It's exactly this model, right? They learn an encoder, and you learn a dynamics model, which is a recurrent state space model, and you learn a decoder. And crucially, all of these models, they are trained to maximize the log likelihood of the observed data, the marginal likelihood. And because when you have latent variables, computing the marginal likelihood is complicated, so you use variational inference and all of the stuff I talked about yesterday. Okay, so an alternative approach is to say, well, we don't need to model every aspect of the world. We only really need to model these latent features or latent variables, because that might be sufficient for optimal control. So you might have so your loss function now, it's the similar kind of model, but instead of training it to predict pixels, you train it to predict future latents. And the key problem here is that you can have something called model collapse. So I could learn an encoding of my images that represent it as the constant vector, let's say 0. And now I can predict the future perfectly. I tell you, I guarantee you tomorrow it's going to be 0, because I chose to map all of my data to the 0 vector. And so that will minimize my loss, but it doesn't do anything useful. So to prevent this kind of collapse, you have to have some kind of regularizer that provides information, provides a constraint so that you can't just make your encoder collapse. So one thing you can do trivially is say, well, I'm going to use my latent variable to predict future reward. And obviously, if that goes to 0, I won't get good behavior. But that doesn't work well in sparse environments. So you can add additional constraints like self-consistency. And the math behind that, the reason why that works is not entirely clear. It's a little bit of black magic with stop gradient. But empirically, it seems to work well. So that's the alternative school of approach, where it's like a non-generative. These are both latent world models, but the one on the right is a non-reconstructive latent world model. So this is what Jan LeCun keeps banging on about on Twitter. So these are both interesting model families. Okay, so separately from the form of the model and how you train it is how you use it for decision making. So one thing you can do is you can use it at runtime. You're in a current state. You have an observation history. Maybe you project it to latent state. And then you can roll forward future possible scenarios by using, say, Monte Carlo tree search or some other search algorithm where you're considering multiple possible futures by planning ahead a few steps. And then you look at what you think will happen at each of these leaf nodes, and then you pick the best, and then you repeat. So this is called receding horizon control, or model predictive control. So if you have a world, you need a world model to do this, right? Because you're rolling out, you're predicting the future. The advantage of this is that your model only really needs to be locally accurate. So you need to be able to predict the future conditional on where you are now. You don't have to model the entire world. You just need to model your local environment up to your prediction horizon. So this is extremely common in the control theory community, where they use locally linear models. And linear models are not good representations of the global world, but locally they're often quite good. AlphaGo uses this kind of thing too, right? Because the world model in Go is known. Or AlphaZero learns the model, but they do look-ahead search. So that's one way to use it. The disadvantage of this approach is that it's slow because you're doing a search algorithm at every single step of agent decision making. So for, say, robotics, it's not often feasible. So the alternative would be you use your model and you generate future hypothetical trajectories, and then you just stick them in your replay buffer, the way Johan was talking about. So you can think about a replay buffer as a non-parametric world model where you see your past data from the real world, and you can go back and revisit it, and you can ask, what would happen if I was in state 22 and I did action A? If you've seen state 22 and action A before, you just look up what you did last time. That's a non-parametric estimate of the future. The problem is, you want to know, well, what happens if I was in state 22 and I did action B? Counterfactual, I didn't do it before. You can't answer that with a replay buffer because you haven't tried it. But if you learn a world model, then you can query it with things that you've never done, and you just hope that it generalizes. So you can now probe, it's like a data augmentation. This is how I think about model-based RL. So this figure here is saying you've got some real data, you use it to train your model, then you're going to roll out trajectories with your current policy, and then you're going to stick that simulated data. I think there's a missing arrow here. This isn't my figure. Actually not sure where it's from. I don't even think it's from these guys either. Anyway, I think hopefully you understand what I'm talking about. You make these hypothetical, they're called imaginary trajectories because they're coming from your world model, not the real environment. So you can create them in the background, and then you can add them to your replay buffer. Now your replay buffer is a mix of real data and imaginary data. So this idea of combining models, this is called background planning. So this idea of combining the two data sources goes back to the Dyna paper from Richard Sutton. It's a classic method, and it works quite well. And there's a very recent archive paper that compares and contrasts these two ways of using world models. That's an interesting read. Okay, so so just popping up one level. So basically I said there's like two classes of models at a high level, or two classes of loss functions. You can either train generative models with or without latent variables, or you can try to train self-predictive models, which always work in latent space. And then once you have a model, you can use it for background planning, like this imaginary rollouts that I talked about, or runtime planning. And there are other things you can do as well. You can use world models to help exploration, and so on and so forth, but I'm not going to talk about that today. So I'm going to focus on this top left quadrant. So zooming in now, we're going to do generative world models with latent variables, and we're going to use them for background planning. And there's many, many instances of that model, of that class of algorithms. So Dyna, I mentioned, is sort of a classic thing that used, I think, MLPs, or tabular. Actually, the original Dyna paper was tabular. Dreamer, I'm sure many of you have heard of, from Danaher Hafner. It falls in this camp. Iris is a very recent paper that we'll build on. Delta Iris is a same group in Switzerland. Diamond, these are all like 2024. So this Diamond uses diffusion, Iris uses transformers. So we're going to build on top of Iris. Okay. So before I describe the algorithm, I'll describe the testbed that we use to evaluate the algorithm. And so far, we've only applied the algorithm to this one testbed, which is a weakness of this work. But this is very fresh work. We are pushing on it and extending its applicability as I speak. So this testbed we use is called Crafter, which is a 2D version of Minecraft from Danaher. And luckily for us, a group in Oxford just rewrote Crafter in JAX, and they call it CraftX, and it's wicked fast. And so you can basically get human level performance. Well, you can get, maybe not human level, you can get extremely good performance, like 90% of human performance in 15 minutes on one GPU. Because the environment is vectorized and PPO is super fast. That's model-free. Model-based is a little slower, unfortunately, computationally. Anyway, so it's a fun environment to work with. It's quite difficult. It's partially observed, it's stochastic, and it's procedurally generated. So unlike Atari, every level's different, so you're less likely to overfit. Okay, so that's our playground, and our goal is we want to get maximum performance on this environment with as little real-world data as possible. So in this, in the Crafter world, in Crafter land, everyone aims for 1 million environment interactions. So in Atari, it's 100K. Crafter, the convention is 1 million. So we want to get state-of-the-art performance at max 1 million steps. So that's the goal. And we'll achieve that goal. And actually, for the first time, we have human-level performance after 1 million steps. So how do we get there? Okay, so we start with model-based RL. You learn a world model, but then once you have your world model to create synthetic data, you have to then train a policy with your data. So you need a strong baseline model-free policy learning method. So our policy learning, we're using policy gradient, PPO. We're not doing value-based stuff here, although we do learn a value function or an advantage function. The form of the network is very similar to what Johan said. So we use an Impala net and a GRU policy to maintain history. And there's a few tweaks that Xinghua made to Impala net that actually give us quite a big boost in performance. It's actually kind of an interesting insight. So if you think about it, you've got like Johan talked about the width of the encoder of the visual system, but you've also got the width of your memory bottleneck coming from the GRU. So they're two parameters. And I think in prior work, I don't remember the numbers, but essentially in prior work, they were both sort of wide bottlenecks. And the insight is that if you squeeze the memory bottleneck from GRU, then you're forcing the policy to extract as much information from the pixels as possible. And then the only thing you can do with your memory is encode long-term stuff that's not visible in the current image. So if by having a narrow memory bottleneck and a wide perceptual bottleneck, then we get much better performance. Just in model, that's the only change we made. So we took a state-of-the-art model-free thing, we tweaked this hyperparameter, and boom, we get, do I have a plot? We get very nice results. I'm not sure we show the previous one. But anyway, with this one weird trick, we beat Dreamer already. We're still model-free, and we've beaten state-of-the-art model-based. Just, I mean, it's hyperparameter tuning, right? But it was a hyperparameter that someone hadn't chose to consider before, based on the ratio of the bottleneck sizes, and a few other things, of course. Okay, so we have a very strong baseline. So we're making our job harder for ourselves, right? We've just beaten SOTA MBRL, model-based, with a model-free, and now we're going to try to beat that. Okay, but so how are we going to do that? We're going to learn a world model to create extra data to increase the sample efficiency of our policy-based method. So the world model we use is based on Iris, and what Iris does is it uses a VQ-VAE, vector quantizing variational autoencoder, to take images and represent it as a set of discrete latent tokens. And then it learns a dynamical mapping. So P of Z prime given Z is a transformer, conditional on the action. So here are the latent Z's. So they get encoded with the VQ-VAE. You concatenate it with the action. You push it through the dynamics, which is a transformer, and then you predict what the next set of latent tokens are. So these are just like words in your latent space, right? And from the same representation, you can predict the reward and the done signal. And then you can decode back to pixel space, and then you can mix these generated, well, they train purely in imagination in the IRIS paper, so they reconstruct images or hypothetical future images, and they train the policy on those reconstructed images. And we do that, but we do something else as well. So if you do that, if you just do IRIS, you train a world model, and you train on your imagination. Sorry, let me just finish my thought. If you take IRIS and you train your world model, and you train your state-of-the-art policy on this imaginary data, then the performance drops by 25%. So here we are, we're doing fancy stuff, we're like 10 times slower, and we're way worse. And like the model-free people, let's say, yes. But we're gonna solve this problem. But yes, question. It's learned online. Yeah, okay. Okay, so this is annoying. So one thing, so we're gonna propose 3 fixes to gradually mend the pain and then actually improve on where we started. So the first thing is actually really obvious. So we just say, well, why are you only training on imaginary data? You have real data. You use the real data to train your world model. Why don't you also use the same real data to train your policy? Okay, so it's a little bit off policy, but you can correct for that. So we just do a mix of imaginary and real, which is what the original Dyna paper did. But if you try that naively, that doesn't work either. Which is perhaps why nobody seems to use Dyna anymore. But there's one weird trick. You just wait until your world model is good enough. So you warm it up with, like, say, 200K steps. And then by then, it's a pretty good world model. And your imaginations are not too hallucination-y. They're more realistic. So then you can faithfully mix. So here we go. We're training the world model. And then after a certain point, after 200,000 steps, you can start sampling imaginary data, and you can do PPO optimization on imaginary trajectories in addition to the real trajectories. So basically, you figure out how the world works, and then you start using it to help your planner. So that's an obvious idea, which apparently hadn't been done before. And that's what I just said. If you stare at the pseudocode, if you don't, you could learn the world model, and if you set this threshold to, say, 1 million, then you never use your world model. You're training it, but you never use it. So that's just model-free RL. So just by changing that parameter, we can interpolate between the 2 settings. And we get, lo and behold, a pretty nice bump. So if we start with our baseline, and then, which is the model-free, and we do this baseline plus Dyna with warm-up. So the warm-up starts at 200K steps. So this is just model-free RL. Then we add imagination. It hurts initially because the model isn't very good, but then it improves. Since making, do I have another figure? No. After making this plot, we have a new version where we anneal it, and it doesn't have that nasty drop. It's a nice smooth increase, but I didn't have the figure. Okay, so that's trick 1, very simple. So trick 2 is also very simple. It's a little hacky because it's specific to this environment, but in Crafter, it's essentially a grid world. So the underlying true generative process is composed of image patches. So rather than doing a generic VQ-VAE, we partition the image into a set of patches, which is really a proxy for using some unsupervised segmentation model like SAM or something, but this is like a cheap and cheerful approximation to that. And then we quantize each patch separately. So they're disentangled by design. And this will recover, there's basically this is a particularly simple environment. So there's a one-to-one mapping, not entirely, but there's almost a one-to-one mapping between the pixels and the underlying generative factors of the world. So if you quantize them separately, you're sort of recovering the underlying symbolic representation, more or less. And so this helps a lot. because our codebook now is much more meaningful than it is with a generic VQ.VAE. So we get this big boost. So that's the patch assumption. The other thing is with VQ.VAE, and this is related to Devon's question. So we're learning the codebook online, and we're also learning the world model online. So in language models, the tokenizer is usually frozen, right? And you're just predicting the words, and the words aren't changing under your feet. But here in latent space, the meaning of the vocabulary is changing, and you're trying to predict what the next word will be. So it's a non-stationary distribution. It's very difficult to learn. So what we did is, as a simple hack, we just do a nearest neighbor tokenizer. So we greedily grow the codebook, but once a codebook is created, we never change it. So now the targets are stationary. So we might discover something new that you've never seen before, and you have to predict a new vocabulary item. But if I want to predict token 22 always represents, let's say, a heart with a 7 on it. Or token 25 is always like a tree. So the meaning of those things never change. So it's a much more static distribution, and it makes the world model training a lot simpler. Okay, yeah. We do, so it is a redundant codebook. So I think we limited, 1,000 code words. And I don't think I have an image here, but you can sort of see it filling up over time. Because so what we do, here's the equation. So it's nearest neighbor tokenizer, but if it's not sufficiently close to any existing neighbor, you just instantiate a new code word. So what happens is after training, there's some redundancy there. So there's obviously more things we could do with, if we're willing to, we can talk offline. There's a lot of improvements you could do. This is like quick and dirty. Okay. And here's a visualization of some of the code words that are learned, and you can see, the quantized versions of the corresponding patches. And so that gives us a nice little boost over the continually changing patches, so a 6% boost. And then the last thing we do is the form of the world model. So this is kind of interesting. Let me pull up all the figures. So in the prior work, like Iris, what they do is, so each image is now a set of tokens, and then you're trying to predict a sequence of frames. So what they do is they predict the top left token, and then the next one, and then the next one, and they do raster scan, and then they move to the next image, right? So they're serializing within an image. But what we do is we basically predict them in a block. So in parallel, we predict all of the tokens in the next frame. But we can cross attend to all of them, so we can get this block attention mask. So we can capture correlation between the tokens without having to serialize them. And then once we've computed the logits, we can sample them in parallel. So this is faster. It's twice as fast. And it captures the statistics better. So this is a weird trick, one weird trick you can do on top of transformers on sets. And we get a little performance boost, and we get a speed up as well because of the block decoding. So if we put all three tricks together, we get this red line, and we break through this barrier. The dotted line was human performance, and this is the first time anyone's beaten human performance on this particular game. And we're significantly better than prior model-based work, and also better than prior model-free work, although we haven't tried BBF and some of the fancy model-free stuff. What am I doing on time? I wasn't really paying attention. 5 minutes. Okay, so I guess I can go through this. So yeah, I mentioned the patch assumption. So we know the ground truth is 7 by 7, I think, in this particular version of the game. And so, that's side information that we exploited, and it seems a little hacky. So that's the red curve. So we ablated that. So if you pick the wrong patch size, then performance drops, not surprisingly. But it's still better than the baseline. So this is like I was pushing for trying like an unsupervised segmentation method, like segment anything, which I think might work. And it's completely generic, but we haven't tried it yet. The other thing that's interesting is we tried not quantizing. So extracting patches, but using continuous latent embeddings, and then not learning a codebook. And you can still train a transformer on that, because the transformer works in embedding space, right? The input's discrete, but the very first thing you do with discrete things is embed them. So it's really a mapping from continuous vectors to continuous vectors. So if you do that and you get rid of the discrete bottleneck, performance is much, much worse. So there's prior work showing that discrete latents are quite useful for forcing the model to pay attention to the relevant bits. So that's patch size. We also, we call this the ladder of improvement. This is deliberately modeled after the Rainbow paper. We even chose a similar color scheme. So the idea is like, there's no real aha. It's just a series of hacks that we put on top of each other, but they all complement, right? And they add nicely. So if you remove them one at a time, then performance drops. So that's what this figure shows. And then this is the warm-up thing I talked about. So if you start using your world model too early, then performance is pretty bad. So that's the blue curve. You can start it later, but then you're kind of wasting time, right? Your model's good, you may as well use it. So 100K is good, 200K is good. You can anneal that parameter, so you can do a weighted combination, and then you don't get these nasty little drops. So we added that experiment after the paper was submitted. But this emphasizes that you do need this warm-up trick. And this is consistent with prior work, right? I mentioned this at the beginning of the talk. If your world model is wrong, your imagination rollouts are wrong, and then your policy will do the wrong thing. So, okay. What is this? Okay. I have some eye candy. This will be fun, I think, and then I'll stop. So we start with an initial frame, and we have these different kinds of models. This is our baseline. This is our best model. I forget what M3 is. And we can roll out. So we can take the action, make stone sword, and like this weak model, it hallucinates a tree when there is no tree. It hasn't moved, right? So it's just a fact of the world that trees cannot spontaneously appear in this environment. Cows can. There are moving objects in this environment, but trees are stationary. So you can't just hallucinate a tree out of nowhere. So that's an error. That's a false positive. Similarly, yeah, like the inventory toolbar changes state. So it's just wrong, right? This is like hallucinations in language space, right? But it's in visual space. There's some cow in the wrong place, M3. Anyway, a lot of details on this particular environment. You can roll out further, and then like here's another example where it's spontaneously placing plants in the wrong place, even though it didn't create that action. Whereas our best model, has many fewer errors. So you can sort of stare at the tea leaves, and it's a nice environment for debugging in that way. Okay, but that gives you a feel of how these world models work. And it's actually, even though philosophically I love generative models, right? It's cool to generate images. It doesn't feel like we should be generating images for control problems. That feels like we're working too hard, but it really helps the debugging. It really does. And it's actually it's a fly in the ointment right now. We learn a latent space, and our policy is trained in pixel space, and that annoys the crap out of me. But we know how to make good policies from pixels. We use Impala and all of that. We can stand on the shoulder of giants. If you start doing policies in latent space, it's much harder because you've lost a lot of the structure of the signal. So you can do it. We've actually been using fun search. We've closed the gap with fun search. But anyway, it's not as easy. Okay, so there's some qualitative rollouts. You can quantify this stuff in terms of prediction error. And it's a stochastic model, so you can measure calibration and all of the good things I talked about yesterday, but we didn't do that. Yeah, so we're still working on this. This is a project led by Antoine Dudois. I forgot to mention him. We're pushing on various directions. The main thing is we want to get rid of this patch assumption and work with generic more, so we can tackle other environments like Atari or ProcGen and things like that. So we learn a more generic quanta codebook. And then we're also considering things like discrete diffusion in latent space as an alternative to transformers, just for fun. And we want to squeeze more juice out of the model. Right now, we only do background planning. We want to do decision time planning, so runtime. And we want to use it for exploration bonuses and intrinsic curiosity. And to maybe get to, as a warm-up to Devon's talk, we train everything from scratch. This is like pure, good old-fashioned RL. But we're kind of working harder than we need to. Maybe we could just take a pre-trained transformer off the shelf and fine-tune it. And so we're trying that as well. That should improve sample efficiency even more. Okay, thank you.
Thank you, Kevin. Any questions? We have maybe time for one or two.
Hi, thank you for the talk. I want to double check my understanding on this. So basically, you are creating a model that is like predicting the future visually using generative bio, right? So another question I have about model-based RL is if they use like YOLO, like object detection algorithms as a way of understanding the world, because this world has a lot of objects like tree, cows, and all that. I don't know if there are any research in that line. That's the question.
Yeah. So the question is, right, so our visual encoder is creating patches, and it's, effectively you can think of that as extracting the objects. So if we wanted, but here, like we hacked it because we knew it was a grid. If it was real world images, we've talked about that. So we've actually done experiments where we use a visual language model, and we prompt it to try to extract the objects in the image, and then we use that as a symbolic representation of the world. So it's like an object-oriented world model. So we're working on that, actually. Yeah.
Okay, maybe one last one.
Thanks for the presentation, Professor Murphy. Well, my question is more of a semantic one. You talk about control, reinforcement learning, and so on. So my question is, where would you define the line between the two? Which definition would you say is, oh, this is definitely a control, this is definitely reinforcement, or you use any other label to describe different types of algorithms of this kind?
I mean, the RL people would say control theory is a special case. They're really just different communities with slightly different goals and techniques. So in control, it's usually continuous states, continuous actions, often model-based, emphasis on mathematical rigor, and stability, robustness, and so on and so forth. It uses a lot of the stuff I talked about yesterday, common filtering and stuff. A lot of that machinery is comes from control theory. Whereas RL is more Wild West, deep learning, but they're very similar. And there's a lot of overlap. Like things like model predictive control. Here we learn the world model, but then that idea comes from the control theory community, this thing here, right? So, cool, thanks.
All right, thank you. And again, Kevin, Johan, and Devon will be around. So if you have questions, sorry we can't get to everyone, feel free to approach them afterwards. So last but not least, we have Devon Helm. He's a researcher at Apple. He's been I've known him as a reinforcement learning researcher for many years. We overlapped in Montreal for a few years, so there's a connection there. I'm really thrilled to hear what he's going to talk about. So please welcome Devon.
Give me a moment. Let's see. Allow. Yes. Continue. No. Okay. Thanks for coming to the talk. Thanks, Kevin, for the nice segue, because all the other work that we've seen before covers more or less how to train RL from scratch using environments. In this case, we're thinking a little bit more about, well, we've got these existing large-scale models that are making a big splash. How can we leverage those models to possibly solve some very hard problems in reinforcement learning? Okay, so the key motivation here is that we have a lot of text available, like lots and lots and lots of text. And this text has a lot of information that's actually relevant to embodied settings. It says things about things that you can do, examples of success and failure, dynamics. Actually, can you give me one moment? I have a presentation issue here. That's very strange. I'm missing my notes. Let me retry this. I like my notes, and that's okay. Okay, well, I guess I'll do without. So you have all this information that's in text that's actually very relevant for embodied settings. And so you spend billions and billions of dollars and you get a generative model that can generate text that can also exhibit sort of like some of these, that can express this type of information, for instance. You can query it for instructions on things that are relevant to embodied settings, such as like making rice or making a dish or pretty much doing anything. If you ask a chat bot, it will insist that it knows something about it. So our main question is, can we extract this information in some meaningful way from these foundation models such that they can actually be used in embodied settings, because there's many challenges here. So chatbots or generative models work within text. RL generally does not, especially when you're talking about robotic arms and stuff like that. Now, I need to put a preface in this whole talk that, because people always ask this, is Apple working on robots? The answer is, I have no idea. None of this talk has anything to do with this sort of thing. This is purely fundamental research, and so you should enjoy it as this. Don't make any inferences. So anyway, which problems were we aiming for? Well, okay, so robots are in here. I'm sorry. All the hard problems, and all the hard problems that involve sort of like using text as input, so like linguistic instruction, all the problems that involve generalization, long-term planning, all that sort of thing. Okay, so two kind of like basic approaches for extracting this information that I'm going to cover in this talk. One is direct modeling. So this is when, at some point in your model, you're going to take your foundation model and use it to generate actions. So an example of this might be if you're in the discrete setting, you ask the model, please, I need to do this sort of thing. It outputs the action, pick up the object, right? Or alternatively, you have some way for it to output the actual values for continuous control, say like the joint movement and all that kind of stuff, or the location you want to move to. This is maybe potentially very nice because you're using the foundation model as is, and you get to leverage a lot of its capabilities as is. But it's very challenging because, well, fine-tuning or training or adapting large language models in this way is very expensive. You need a lot of data. And in addition to this, large language models may not understand things about your environment, so that kind of like puts a little bit more emphasis on the fine-tuning aspect. And there's some key approaches like prompt engineering, chain of thought, supervised fine-tuning, RL fine-tuning, et cetera. They're going to be key to these sorts of approaches. The next type that I'd like to discuss, which is a little bit more akin to what they call RLIAF, which is basically where you're asking the model, the large language model, for responses, and you use these responses in some way as an intermediate variable that you're going to use to train a policy. So an example of this is like, well, suppose you want a world model like Kevin's interested in. You can ask the large language model, what of all these images, you give it a bunch of queries, is most likely to happen conditioned I'm at this particular state. And the large language model can say, oh, it's this one. And you can use this task as a pretext task to develop a world model. You have to do some additional training off this data set, but you could potentially do this. And so the idea is that you're using these intermediate variables to actually train the agent, not the large language model directly. Potentially much easier because you need less training to train this additional model, but you're probably losing a lot of information from your large language model and also functionality. Okay. So in this talk, I'm more or less going to share about 4 works compartmentalized into 3 different sections about direct modeling and indirect modeling. So the first thing I'm going to talk about is our first direct modeling technique that we call LARP, Large Language Model Reinforcement Learning Policy. And what's our target domain? So our target domain in this case primarily is going to be this environment called Habitat. The lead author of this work, Andrew Zote, was one of the main authors of this environment. It can be vectorized, and it can involve a lot of really complex tasks that involve a lot of planning, and also, more critically, generalization, and also complex text and instruction control. So for instance, if you have some sort of instruction where it's like, locate a tool, like not specifically like the tool, to fix a loose screw on the sofa and bring it to the sofa. Well, you can infer that this means actually like a screwdriver, but these are the sort of tasks that we're asking this model to do. And this task is actually like in the setting of it. It's never seen this house before. Now it needs to be able to figure out how to do this from egocentric observations. So it's not the top-down view, it's actually looking from like a little camera in the simulation. And there's a lot of steps that it has to go through this, like it has to navigate around, and eventually it needs to pick something up, and it needs to take that thing and then place it at the final location. So it's a very hard task, but we're very much interested in generalization as well. So in this case, we created a benchmark called language rearrangement, where we're querying the model, its ability to be able to solve complex tasks that it's never seen before. And so these, or they're variations of tasks that it's seen in the past. So novel instructions, like instructions that it hasn't seen specifically, novel objects, multiple objects. So it hasn't been asked to do something with multiple objects, but only like a few objects. Changes of how you express the task. And, oh, I don't know why that was, sorry. I got a bug. Sorry, and then you have this time thing, and then you have to wait. Okay, are we good? We're good, okay. This should not be timed. Anyway, you get the idea. Thank you. Okay, so, and the way we're going to do this is we're going to embed the multimodal large language model, the foundation model in this case, into a reinforcement learning setting. So there's going to be like an environment loop. It's going to be generating actions, and the foundation model is going to get rewards in return, which is going to help train the thing. So how do we do this? Okay, so we have to be a little bit careful. And at least in this particular work, we wanted to actually like retain a lot of the capabilities of, in this case, a large language model. This is not a vision language model. This is a pure text-based model called Llama. So we wanted to retain some of those capabilities so that we kept the large language model fixed in this case. But we also wanted to do vision, so we had to incorporate in a vision encoder, in this case VC1, to import in vision information into that large language model. So in this case, anything that is blue, we're not training. So the vision encoder is actually fixed, but there's an embedding that transforms it to something that the large language model can interpret. The language embedding isn't changed, it's kept fixed, but we are, given the last activations of the model, training a network, NLP, to produce the actions, in this case, continuous actions. So this is like the basic idea. Very simple sort of like approach to trying to like see if the large language model has capabilities to help you in this case.
Just a quick question.
Sure.
From the visual encoder, you're getting one dense embedding? It's like a
Yes. Yeah, single token. Yeah. Yeah, there's a lot of different approaches for doing that, but in that case, yeah, just one. Okay, so our method, LARP, does well. At least there weren't a lot of like good habitat benchmark or baselines out there, so we trained a lot of different other things to compare to sort of like see if this is actually a good approach. And it turns out it is. So using from scratch and training the large language model end to end does much worse. So that means that there's something about those parameters, like there's something about the information that's in the large language model that's helpful. We also tried like just training with RL. There we go. This is really weird. I press the button, nothing changes over here. Are they changing over here? Let's see. Oh, they are. It's not changing on my screen, so that's why I'm confused. Okay, so I'll look at this. So we had a RL baseline that we also trained using LSTMs. And then you can also compare to like zero shot using ChatGPT. And you also get benefits in terms of training speed, which you know you would hopefully get. Yeah. Okay. And then finally, you can compare it to using imitation learning. So if you have a bunch of expert policies, which are actually easy in Habitat because you can programmatically design them, and using RL is like super critical for both speed and overall performance. Yeah. Okay, so next part, so that was the version 1 of that work. But there was something deeply unsatisfying about that because we were just like using the hidden states and having them output actions. And so the consequence of that is that you can't necessarily use the actions from your prior observations very well unless you have an additional encoder. to condition your current policy to take future actions. So say if you want to use a full history, you're forced to kind of like maybe only use observations, unless you have some way to encode them. So we thought we'd like to bridge the gap between like sort of like how large language models work, where they're working in text, and actions, which are generally not text. So for instance, continuous control, you have joints, you have angles, you have locations, and all that sort of thing. How do we bring that action space a little bit closer to language space so that it could be used in the large language model as the large language model was designed to be used, because it was pre-trained using text, discrete tokens. So we introduced this notion of an action space adapter, and it's just basically a module that's going to be used on top of LARP. And so this is the prior architecture, as I said. And this is kind of what all the pink parts are the ASA, or the action space adapter. So the action space adapter, what it's designed to do is it's designed to take the tokens of the actions. So we're going to tokenize our actions at some point, and then we're going to embed them into a large language model and use them, in this case Lava, so we actually do have a vision encoder component that's coming from our pre-trained model in this case. And then we have an adapter head that takes the hidden states of the large language model and outputs the language tokens in this case. But when it really comes down to it, all that text and the actions are kind of like in the same space in this case. And so then given those tokens, you need to decode them into some actions that you can actually perform. So there's a number of ways that you could possibly do this. So how do you tokenize actions? So one example of doing this is that you can just output the actual continuous like values. So this would be like continuous prediction. However, to bring it a little bit closer to the large language models, a very simple thing that you could do is you could take all those continuous actions and break them into chunks, like basically bins. And you basically, for a large, like say if you have a 2D action space, you would have a big grid. Or a 3D action space, you'd have like a cubic grid or whatever that's called. So everything's evenly distributed. That actually doesn't work very well. What we found works really well is that you use vector quantization, as Kevin had brought up. So it's this method of like learning a code book. But in particular, we find a lot of success when we use something called residual vector quantization. So what is residual vector quantization? Okay, well, I'll cover that in a second. So we're going to extend beyond habitat in this case, because we're actually interested in the capabilities of this under numerous action spaces. So just to kind of like show that this method is general, it applies to a lot of different environments that have different action spaces that look different, including discrete ones, but in this talk I'm going to focus on the continuous ones. Okay, so, well, I didn't cover what residual vector quantization is, so I'll say it in brief. I should have had a slide. So anyway, so what residual vector quantization looks like is when you encode, like say your actions in this case, and it's a VAE sort of setup, so you need to reconstruct at some point. You're going to have these codes that the model selects at the high level, at the latent level. Okay, so it's going to select a code based on on the nearest neighbor to the embedding, and it'll find one. Well, that embedding is often not 100% correct. Like there's a little bit of an error. So the residual means that you take the residual error, you pull the error out, and you pass it to another code book, and then you repeat the step, and then so you have a set of codes. Now, they're selected from a set of code books that are used to reconstruct the entire image. So that means that instead of just one code for a particular action, you might have 5 that represent it. And the idea is it increases fidelity and precision and stuff like that, and it actually helps a lot. So in this case, you can see that using a residual vector quantization method for tokenizing your actions and injecting them into a large language model is far more performant than anything else that we had tried. And better than continuous prediction, so this kind of like highlights the point that Kevin was making, that using quantized representations is actually probably a pretty good thing, especially if you're using a large language model. I would assume so, because they're designed to do that. Yeah, we use expert data. Yeah, and so like one of the main reasons why that actually might work really well is because experts probably spend a lot of time statistically around good states. So you can imagine something like, say you're asked to pick up an object, right? It's super important that you're precise close to that object, and the experts probably spend a lot of time, or you see experts doing very similar things around there because precision really matters. But when you're approaching the cup from your arm, it doesn't really matter. You can go from here, you can go from here, so there's a lot of variance. So you'll have less codes to describe things that are happening out here than you will here. At least that's kind of how I see it. Just a note about tokenization, like using the residual vector quantization, more codes are better, but there's a point in which you start to decay, and then code book space size is actually important. And this is just kind of like a point across different environments. You see more notable improvement as the number of degrees of freedom of your embodied agent increases as well. Okay, so that was part one of the direct modeling. So we had done this method LARP. We had gotten some lessons about the action space. We saw some positive signal as far as like applying these to large language models. So in the prior work, we were training all these different models independently on different environments. So the question that arises from that is there any point in training like a large language model on many different domains, on many different tasks? And also like evaluating in the generalization setting. So this is sort of like the notion of a generalist agent, an agent that can do many different things because that it's seen many different domains, many different tasks. And one of the key ideas here is a generalization, but also cross-domain benefits. So the idea that there are things in some environments that contain information when you solve those tasks that might be useful for solving other tasks in other domains. So this is one of the key questions is if we do this thing, like is there a point to it? Like is it better to just train one model that's good at that one thing, or is there actually benefits to training a generalist model, agent that's seen lots of different domains? Okay, so it's basically like the same similar sort of architecture as we were looking at before for LARP v2. In this case, we're using Lava 1 Vision, sort of like a little bit more advanced large language model. So as our research progressed, also the vision models were also, the foundation models were progressing, so we used them. And so one of the key questions here is though, like we had this action space adapter kind of module, but now we want to be able to use this action space adapter for many different domains. We have a very different action spaces. In this case, like continuous and discrete action spaces. So the key idea is like, well, we're just going to learn a shared code book against all these things. So you train, like as per Kevin's question, we do pre-training with all the expert data across domains, but we use the same code book across those two domains, those multiple domains. And one of the, you can just use some very simple tricks to make sure that everything can be projectable into the same codebook space. You just basically can use things like padding for action spaces that are smaller. You pad the action space to the largest action space in your domain. And then if you want to actually generate, that means decode to actually do an action, you just clip when you get to the action space. How am I on time, by the way? 8 minutes, okay, good. All right, I can breeze through this so we can get to the next section. Okay, so because you have to change the prompting a little bit because now you have to inform the agent which domain it's actually embodied in, so you have an additional prompting, additional context to tell it, oh, you're in this domain, this is the type of thing that's happening here, you're a mobile robot, your action space kind of looks like this. So this is all part of the training, and it's given the instruction. The output is the action tokens. Then you use the action space adapter decoder part to decode into an action, and then you implement the action in the environment. And it can be done in any of the environments that the model was trained in, and it was trained in all those environments simultaneously. So how do we do the training? Okay. So first, we take our pre-trained large language model, the multimodal LLM, 1 Vision in this case, and we do supervised fine-tuning on instruction data. Lots and lots of data, like 2.2 million trajectories or something like that. And this produces our base model, which we call GIA base. And then I assume you can see it there, because I cannot. So then you do additional fine tuning. Oh, sorry, and the first step, we actually fine tune the whole model end to end. So we don't freeze any of the weights anymore. And the second step, we do online RL in simulation with some continued supervised SFT on the prior interactive data. And we find that it really helps to be able to do both of these in conjunction with each other, but we do far more online RL to get our final model, which we call GIA. And so we do a large, diverse number of tasks. In addition to the embodied data, we also incorporate in some vision language data to retain some of the capabilities of the original vision, the multimodal model. So it's still being trained on some of the data that the original base model saw before we ever got it. Okay, and we're interested in generalization experiments, like new instructions, new backgrounds, new objects, new scenes, et cetera. So almost all the things that we're gonna see now are related to generalization experiments where there's a specific held out task that you're gonna evaluate the model on. And we're gonna compare both with other generalist models and also specialist models which are only been trained on those domains and are kind of like state of the art in the field. And this is what it kind of looks like. So all the brownish orange ones are prior works that were state of the art in those particular domains, and the green is ours. And nearly all of these, except for a few exceptions, the majority of these, we outperform those specialist agents that are very specialized in that domain, which is great. Like, you can get more average, better performance if you train on all these domains using GIA than you can with any of these individual models which have only been specialized in those domains. So this one is, the importance of RL. So training with the RL, comparing, this is basically why do we continue to train with RL? You get a boost in performance, a little bit more performant in some environments than others, but overall the benefit is good. And then there's probably something you can see. Okay. I don't know what's going on here. Okay, so I'm probably running out of time. I'll just run through this. RL is also important. Online RL is important over offline RL. Best performance is like the model that we showed you. Also, training happens a lot faster if you use the initialization using the supervised fine tuning. And then, here's one of the main points. So, does the cross-domain stuff matter? Does it matter that I've trained on all these models? And actually, it does. It helps. Like, somewhat statistically significantly in some settings, but you never lose capabilities based on the fact that you did this, and in some cases you gain capabilities. So there is some argument that you are getting some of these cross-domain benefits, which is really interesting because that's sort of like just a hypothesis that we had, that you should be able to gain benefits from doing lots of cross-domain training. So generalization capabilities are good, but of course it fails in some places. Yes, you are seeing the X, and then it fails. So for instance, like in some more complex tasks, it fails to generalize to those tasks, and also like super novel tasks that it's never seen before. They're completely different from what it's ever seen. Novel objects and novel instructions. Oh, sorry. Okay, so final part of the talk, indirect modeling. So I promised that there was going to be a second part where we're talking about not how to use the large language model directly, but how to extract information through intermediate variables. So in particular, I'm going to talk about indirect policy learning using AI feedback. So what AI feedback is attempting to do is it's trying to build a reward model where the reward is the intermediate variable that you're trying to extract from the large language model. So how do you do this? So you basically elicit preferences from a large language model. I'll go over in more detail in the next slide so you know precisely what I'm talking about. So you gather a data set, and then you distill that information using another reward model, which is basically trained like a classifier. And then finally, you use that reward model in the loop to do RL. And in our case, we only use the reward model. We don't use the external reward that the environment's provided. And sort of like this is going to be a test to see if that information in that large language model is relevant to training an agent. If this succeeds, that means that there's reward information in the large language model. If it doesn't, then maybe you use the wrong prompt. I don't know. Okay, so we're going to remove ourselves a little bit from vision because a lot of the work we were looking at with vision involved a lot of adaptation, but we're looking at this environment NetHack, for instance, which is pure text-based. So this is just like a rendering of what the agent actually sees. What it sees is just text. It does have like a map, sort of like text-based version of the map available to it, but did it go all the way through? Sorry, I can't see what's going on here. It must have. Yeah. But it involves generalization, planning, exploration, stuff like that. Like it's a difficult environment because there's a lot of difficult RL problems kind of like embedded in it. Okay, so the data set collection part looks like this. You ask the large language model which of these trajectories are better. So it'll see these two trajectories, and then it'll make a decision. And that's how you collect your data sets. So you have your trajectories, and you have the labels which correspond to the preferences. Oh, sorry, yeah, almost done. So then second part, you train a classifier on these preferences. And then finally, we test the resulting reward model, which comes from the classifier on all these different environments. So here's a quantitative or qualitative example of the agent going through the environment. But I probably don't have enough time for the rest of the video, but I do want you to see what's on the bottom right-hand corner. And so that's the output of the reward model. And so what you get is something very smooth, as opposed to having almost no reward or very sparse reward in this environment. You get a smooth reward model, which could drastically help with learning. And it pays attention to good stuff if you look at it carefully. So I'm going to breeze through this. AI feedback, there's different ways to extract reward models. We test them. AI feedback does really well. Compared to indirect policy, comparing to direct policy, if you don't train the LLM, AI feedback is actually really good, so that's on the point of efficiency. And you can also prompt the model to do additional things like exploration, which is really cool. So if you're interested in other problems in RL, you can possibly solve those using methods like AI feedback. So here's the final slide. If you want any of those papers, lots of QR codes. Most of the work was done by our two interns, Andrew Soto at Georgia Tech and Martin at Mila. And then there are some of my colleagues, and thank you.
Thanks, Devon. So again, maybe one or two questions. Okay, one back there.
Thanks for the presentation. I was wondering if you have tested this type of agents on environments that kind of like defy the logic of what you will find in text.
Oh.
So maybe different kind of generalization, which is different from the direction of just making it more complex, but something that might not make sense in any of the text you find. So like teleporting stuff, or like, I don't know, putting weird stuff in the oven, or like something that doesn't make sense.
You open the closet and there's a bear.
Yeah.
Yeah, that makes no sense. No, we didn't specifically. I mean, I suspect that this is the case for a lot of these environments because the pre-trained large language model probably hasn't experienced a lot of data that are specific to those environments. But yeah, that's true. I mean, there's things that are like almost counterfactual in how they represent the world. And so, no, nothing like that specifically, which is really interesting.
Thanks. Maybe one more question. If not, you can also find them, all three speakers, during the rest of the day. All right, so let's thank the three speakers again, Johan, Kevin, and Devon. So here's the Vatican flag that I was
Oh,
thinking.
wow.
Which one? This one. Yeah.
Thank you. Can you send them to us?
Yeah, I will.
Yeah. That was my model.
1, 2, 3, probando, 1, 2, 3.
Oh. ¿Quieres conectar ya? ¿Quieres conectar? Sí.
Micrófono. ¿Esto bien? Sí.
Hello everyone, thank you for being here at the Computer Vision Parallel session at KHIPU. We are going to have 3 speakers. We will start with Hilberto, who has already had a participation in KHIPU as a spotlight from Mexico. Gilberto Ochoa Ruiz is a researcher at the Advanced AI Research Group at Tecnológico de Monterrey. He obtained a master in computer vision and in robotics from Heriot-Watt University and a PhD in computer vision and electronic imaging from the Université de Bourgogne in the Laboratoire d'imagerie et vision artificielle. Well, thank you everyone for being here, and Gilberto, the floor is yours. Thanks.
Thank you so much. Thank you, everyone. So, I will be presenting some work, as I mentioned in the introduction, spotlight today. I was saying that I work mostly in endoscopic video analysis, so we'll be presenting some of the stuff we have been doing recently. This is a collaboration with Centre de Recherche Automatique de Nancy, which is a university in the east of France. We also have some medical collaborators from the Nancy Hospital. So very quickly, as I mentioned, this is my group. We do mostly computer vision and machine learning for image analysis and understanding. And for the last few years, like 6 or 7 years, I've been working on endoscopic video analysis, and I really like this subject because when I was a child, I remember looking at these movies that you could send a robot inside of the body and to fight malignant cells, for example, or try to cure someone from inside. So there is this book from Isaac Asimov that is called Fantastic Voyage, and actually a lot of inspiration in the literature and in popular media, as well. One of my favorite cartoons. In particular, this episode, they make the chip. They make a small version of the chip. They send it inside of the body, and basically there are many motivations, but one of the main motivations is that cancer is one of the largest, most mortal illnesses right now, right? So especially in the case of colon cancer and other kinds of cancer, you don't have an early diagnosis, it is very little, right? So people usually what they do now is you have to go regularly to screenings, to have inspections, especially there's some preconditions there. And for that, we use a technology that is called an endoscope. It's basically a tube that is very sophisticated. I'm not going too much into details, but you can bring light through laser, through optical fiber. You have a very sophisticated camera on the tip, and you can even bring many instruments inside of the body through this instrument. It's a very interesting instrument, and enables to collect images from different parts of the hollow organs, like the colon, stomach, urethra, and many others. And the idea is that you can use this video feedback that usually the doctor will see through a screen to for example, detect and characterize lesions. And there are different kinds of lesions. I'm not really going too much into detail of that. And as I mentioned, you have the camera, you have sensors, which, for example, the camera, or you have other micro tools that you can bring inside of the body. For example, we have other big project on ureteroscopy for classifying kidney stones directly from the video of feet. But in this particular case, I will focus a little bit more on the different kind of things you can search for in the video endoscopy, like ulcers, inflammations, or there is also some work on celiac and Crohn's disease, and so on, that can be precursors of cancer. And it's very interesting that the doctors can actually go inside of the body, but one of the problems is that because the video, it can be a very long process, like half an hour or even more, and there is no recording. You can record the video, but the problem is that since you are going in 3D, you have a 3D information and you have to locate yourself inside of the body, it's very difficult. So there is no way to recover that information, and actually one of the goals of this project is to, I will explain in a moment, is to create this. So apart from these some related areas, we work in endoscopy, but also a little bit on laparoscopy, and in particular more like applications, we work in computer-aided detection and diagnosis, and more in particular in computer-assisted navigation, that is the topic of this talk. Some of the applications we do related to this project, we do instrument detection, segmentation, classification, we do lesion characterization using language models, we use lesion detection, segmentation, many other different things that are very particular to this domain, that the methods typically developed in normal computer vision don't apply to this kind of data. So it has its own challenges. And as I was explaining before, one of the main problems is that imagine that you get a diagnosis today or something suspicious in a video sequence, and you have to come back in 6 months after having some treatment. The doctor doesn't have any information or cannot share where the lesion was, what was the progress of the lesion, and so on. So people have been working for some time in developing kind of digital media or support media to have like a 3D map of your body, basically. So this kind of, ideally what we want to have. So basically to have like a complete 3D representation of the side of the body, and you can actually try to locate the lesions that you found in the video signal. You can have registration with all parts of the body and so on. So typically this is the kind of thing that we want to do, but we're still very far from this goal for some of the reasons I will explain in a moment. So, ouch. So in particular, there are many challenges with this video signal. We have a very limited field of view. We only see a very small part of the organ. This makes operating conditions very complex, and there is also problems of the main shift that I will mention in a bit later. But also you have very diverse scenarios. This limited field of view leads to very large changes in illumination. And also other problem related to this is that there are very few data sets to develop computer vision models. One of the things that is needed for the 3D reconstruction, usually what most methods do right now, even in robotics for autonomous driving, is that you, especially in this supervised scenario, is that you have a source frame, and because you lack data, for run-through data, normally what people is doing is using warping synthesis to predict the next frame from the source frame, and trying to predict a depth map. So most methods are based on this approach, but the problem is that, contrary to normal computer vision or robotics, in endoscopy there will be a jump in illumination. So this is called, normally in robotics we make an assumption that is called the brightness constancy constraint. So basically what it says that there is no illumination change, large illumination change between frames. So this makes basically the supervision makes ambiguous and can lack two different problems, and these problems are mostly related to, so basically what we want to do is to have some immediate input. We have to predict that map, then run some 3D reconstruction methods based on SLAM, and then we want to produce either like chemosizing, because we want to enlarge the field of view. For example, in some cases you might be interested in enlarging the field of view to see the whole picture, or you want to create a 3D representation of the whole column, for example. The problem with the change in illumination is that either we have variable illumination in that case, so you have very large illumination changes that need to be taken into account, or you can also have lots of specular noise and artifacts, which are not common in normal computer vision. So this will lead to reconstruction that has missing zones or holes on the reconstruction. So this is something what we want to do. So there's like something like this. So at the end, what we want to do is to produce a 3D representation of the column like this, but as I mentioned, there will be some missing expected areas and gaps, which are not the same. Errors in the reconstruction, because also as you go longer in the video sequence, you will start accumulating error, and some other problems. But basically, this is the main issue that we want to attack. And also related to this reconstruction, as I mentioned before, there are other applications like context awareness, robotic-assisted surgery, image registration, and so on. So it's a topic that is very interesting in many different application areas. And as I mentioned, the main problem of these approaches is that typically right now what most people do, even in robotics, is using a depth map, a depth CNN, or now transformers, to predict depth, and then you also have a network to produce the pose, and you use the combination of these two networks to warp the next image and then produce the map. But the problem is that in endoscopy, we don't have these linear changes in illumination. Some people, more like from medical side, for example, this work from Chapel Hill, they were trying to use some time ago recursive neural networks to predict the changes in the illumination, but the problem is the results are not very good in terms of contrast, but at least they show that it was possible to predict that. And then we also have some work that I'm not showing here, using, at the time we started with generative adversarial networks to produce like fake changes in illumination to have like some depth, and then used machine learning-based image enhancement methods. But in this particular case, I will show that we're using an illumination invariant approach to tackle this problem. So this is the topic of this project. We can call it endoscopic view enhancement using self-supervised illumination invariant reconstruction techniques. It's a project funded by Mexican National Science Foundation, and there is the COSNOR, which is a French-Mexican grant. Also, we have support from the Embassy of France, because two of my PhD students got full scholarships to do stays in France, and we're also receiving credits from Microsoft, for Good Lab. So this is the team, basically me, myself, and the Professor Christendorf from France. We have some PhD students, some clinicians as well from Paris. And basically, well, as I mentioned before, this is basically the kind of result that we want to achieve, this kind of reconstruction. And basically, for that, we want to improve the prediction from different views. That one is showing the prediction without any enhancement, and the one with enhancement, the one on the right. And basically, what we want to do is, between frames, you can have slight illumination changes, and this will affect the depth map. Here I'm showing one of the relatively old models now that is called monodepth. And this one is ours. This is called mono-IIT. And basically, one of the contributions, I'm not going too much into detail because of the time, but we are proposing an illumination invariant loss based on Robinson kernels, and a per pixel intensity transformation. And basically, the architecture is something like this. We have some transformer-based depth estimation model. We have the CNN-based pose estimation. We have that projection, but we have two new losses. One is to take into account the variations in illumination, and the other one is to compensate for the changes in brightness. And very quickly, we have all these different losses. We want to preserve edges in the depth map. We want to compensate for the illumination. We have the photometric similarity loss that is quite used in these kind of approaches. And then all this is combined through a global illumination invariant loss to do this. And very quickly to the results. Here's some results on this. I don't remember the name of this data set now, but it's a synthetic data set, but you can see that in some of the images you have like blurring because of the movement. And our method is, it seems to be working well with the depth estimation. And then a more standard data set, there is this one called a scared data set. Here we have different examples with methods of the state of the art. In particular, this one is one of the, maybe the state of the art right now, so it's doing quite well. And we also have some, and then we also doing generalization test, meaning that we train on a scare, and we do testing on other data sets. So this is one Hamlin from the Imperial College, and SERF-CT data set, and it seems to be doing quite well. These were the qualitative results. And then there are different metrics for testing this data. Usually you want to calculate like certain metrics when you are calculating a trajectory, and you have different metrics for error. Basically, it seems to be doing quite well in this scared data and in the Hamlin and CERCT dataset. Finally, some results on, I think I have enough time, but some results on mosaicing. So we are comparing the ground, so we have some ground truth because for this particular data, there is ground truth for that. And we're calculating our the state-of-the-art model against ours, and seems to be having less issues. This is just for comparison. And I think I went very quickly, but I want to have time for discussion and for the panel. So thank you.
Well, thank you very much for such a nice talk and for sticking to the schedule. We have now time for questions from the audience. So, well.
Yeah, thank you for a great talk. I wanted to understand in what ways the methods for natural images are different from those for endoscopy images. Mm-hmm. And in particular, I think techniques that are based on depth estimation as well as camera pose are sort of standard in natural images. Yeah. But I presume that you need to address limited data set, some of the issues that you mentioned at the beginning with illumination and the fact that the distance is smaller. So what were the differences?
Yeah, but probably wasn't very clear because of the for the time. Yeah, basically, as you mentioned, the main problem is that for natural images, when you go to the papers, you have lots of data sets because normally you have a Google Street View and you have a lot of these cards that have instrumented the car so you can get very detailed maps. In the case of on endoscopy, for getting a data, normally you need to run something like structure for motion, or you can, the other solution is that you can instrument the endoscope, but obviously this is not very practical. So there are some, so for example, you have to do it in porcines like animals. So you have like cadaver, or you have even 3D representations, and then you go through the endoscope and you can recover 3D information, but it's very rare. Yeah, so the whole idea of this method is that usually this unsupervised method that is basically is also based on the state-of-the-art, let's say, traditional computer vision. But the main problem, something that I didn't mention quite a lot here is that in the case of the endoscopy, you have less texture. So some people will go through maybe optical flow, or there's the other paper using appearance flow to try to cover that, and also the problem of doing real time. So we'll say this is some of the difficulties, especially the texture thing will be the most important.
Well, first, well, I have two questions. The first one is, how do you compare in the 3D reconstruction with a ground truth if you don't have it? Yeah. And well, the second one is, in the diagram where you show the CNN and the transformer, it seems that works in parallel, and then you combine the information.
Yeah.
And why don't you use it like first you extract the features with the CNN and then you analyze it with a transformer?
Okay, see. Okay. So the first one is, yeah, indeed there are few data sets that have ground truth on them. I mean, there are a few ground truth data sets, but there are very few. Yeah, so for example, in this particular case, there is ground truth because some people instrumented the endoscope, and they created like you know, like they took the intestine of a pork, and they got the data. But yeah, normally it's, you know, these 3D methods you can only compare up to scale. So in this case you can compare, but in some of the other data sets it's not possible. Regarding the other one, it's a good question actually. Why you have the 3D and so basically for that most methods are doing it this way because you are getting different features, but for the depth and the post, basically you're trying to address different things. But yeah, I need to think about it. I don't know how to answer this, why different models, but I will say most methods are based on this approach. And what, there was another other one? Yeah, I didn't go too much into detail of this, but basically the approach is that you have a source frame and you have a target frame. So there will be an homography between them. And what you are trying to, you are predicting the homography and then using that as an auxiliary signal. Yeah. So you don't have the ground truth, but you can use that as an extra supervisory signal.
So I think we have time for one more question. I don't know if anyone else wants to ask. There, Nacho. Can you take the mic?
Okay, thank you for the talk. I have two questions. The first is, I understand the variation in illumination is due to the distance of from the camera and the light that comes with the endoscope to the object, right? Can you characterize the light source so that you can use the differences in illumination in your advantage to reconstruct?
That is something that we want to explore, actually. Yeah. We haven't done it, but yes, we want to explore.
And the other little question is, can you remove the artifact? I know I try to avoid that, but is that difficult to remove those reflections?
Actually, we have, I didn't present that because of the time as well, but we have a complete work on parallel of doing that.
Okay.
Yeah, we created, at the time before diffusion models came all rage, we actually characterize we have some people doing actually, getting these images and then doing image-to-image translation to create a data set. Basically what we wanted, because most methods, these machine learning image enhancement, they usually you need a ground truth that you want to compare. I mean, you can do quality assessment without them, but normally it's better, especially you want to assess the structural similarity and these kind of things. So we created a synthetic data set that contains per image of the non-perturbed image and image with perturbations, overexposure and underexposure. And the most difficult part, I mean, you can do it, and we showed that you can do it, and things are becoming better. One of the main problems was real-time performance. But now the methods of the state-of-the-art are capable of doing that in real time. Especially if you want to do the reconstruction, because normally the other approach is that you do the reconstruction after analyzing the video. But if you want to do the reconstruction in real time and then identifying your missing areas, and you have some kind of alert, then it's important. Otherwise, you can just leave the video and then run it, right? But yes, we have that. We have the data set is available, and it's actually being used by some people.
Okay, sorry, I have one more little question.
Yeah, don't worry.
And are any of these devices capable of using another source of illumination, say structural light, so that you can do it easily?
Yeah, the problem is that, I mean, we can do it in the lab setting, but when you want to convince people like medical companies to change the endoscope, this is the main problem, right? Yeah.
Thank you.
So the main idea of this whole field is trying to do with only the image, basically, without changing.
Thank you very much.
Thank you.
Well, thank you, Hilberto, for such a nice talk.
Thank you for the questions.
Muchas gracias.
Sí, muchas gracias.
Well, and now, Camila. So now we welcome our second speaker, Camila Gonzalez, here present. She's a postdoctoral scholar at the AI Development and Evaluation Lab at Stanford University. She got her PhD at the Medical and Environmental Computing Lab at the Technical University of Darmstadt. So Camila, the floor is yours.
Oh yeah, of course. Hi, thank you so much. I'm Camila, and I will be talking about training and monitoring AI-powered medical devices in the open world. So, there we go. So a big problem that we have in medical image computing is typically a lack of data, and especially a lack of annotated data. It's very rare to really have enough of these very high-dimensional images to train robust algorithms, especially when we need very expensive expert annotations. Now, there have been a few developments that have helped us a lot in the last few years. One of them has been, I have to point here. One of them has been the fact that there are many challenges, like many challenges for, say, segmentation or classification. Many of these are hosted in the Grand Challenge platform, a lot of them by RSNA. And this is great because a lot of people basically submit their contributions, make their code public, the data is public. So this has helped us advance the field a lot. There are also a lot of federated learning consortia. I was part of a big one in Germany that involved all of the university hospitals. So this is great because it means that institutions can train models together without sharing the data in a central location. And we also saw a lot of advancements lately in multimodal learning, say with foundation models, which gives us the opportunity to learn very robust embeddings without needing to have annotations of the downstream task. Basically, we can train a model in an unsupervised fashion, say with radiology reports and images, and then just fine-tune it for our target task. So this is great in the sense that we don't need as much annotated data as we did before. Still, there's really no guarantee that these systems that we design for which we publish papers will work well in the open world. There is this very famous example of a system that was meant to classify diabetic retinopathy, where basically they had a model that worked very well, but when they tried to use this in a clinical setting, it failed catastrophically. So basically, it bothered people more than it was actually helpful because the quality of the images was very different than those that had been used to train the system. Also for COVID-19, we saw a lot of algorithms that were proposed for, say, automatic segmentations of lesions, automatic detection of COVID, but very rarely were these actually used in clinical practice, often due to a lack of external validation that made them robust. In general, even when we look at medical devices that have been cleared for commercial use in Europe through CE marking or in the US by the FDA, even when we look at those, we learned that a big portion of them have never gone through prospective trials, or at least that data is not public. So this is a very, very big issue, because basically it means that only for very, very common and very easy use cases do we actually have medical devices that work. Now, even when we look at use cases where we see, oh, okay, so this system could actually be very useful in clinics, we have no guarantee that that system will remain useful over time. And this is basically the motivation of a lot of the work that I do and also of this talk. So I'm going to start talking a little bit about the problem of data drift in medical imaging. I'm then going to talk about dynamic learning and how we can use methods from federated and continual learning to train models in a way that we leverage data without having to have it all in a central location. And then I'm going to briefly discuss a few challenges that we have to actually make these systems useful in clinics. So, of course, Hilbert already talked a lot about the problem of data drift for, in his case, endoscopic images and lighting conditions. Very broadly speaking, we have three sort of types of distribution shifts that can happen. One of them is covariate shift, and this means that, well, our images can change, say, due to changes in the acquisition protocols, changes in the reconstruction algorithms that we use to produce the images from the scanner, changes in just the institution that we acquire the images at. We can also have label shifts, so this means that basically we can have different prevalences of diseases, say in different institutions. Also, how our annotators annotate the data can vary from institution to institution. And we can also have concept drifts. So this happens when, say, diagnostic criteria changes over time. Like, say, in several stages of the COVID pandemic, the criteria for diagnosing a person with several states of pneumonia changed. Coming back to that example, if you remember, perhaps. I mean, of course, a lot of you don't work with this specific use case, but there were a lot of models that were proposed for, say, the automatic segmentation of lesions. Now, you would think, okay, if I have a model that is state-of-the-art, that was trained on a large heterogeneous data set, it would generalize well, right? However, we saw that this is not quite the case. For instance, here we had a system, basically a model. We trained the NN unit, which had secured most of the winning spots in a challenge. We trained that, and we had around 70-something% dice. Then when we introduced some very slight image artifacts, we already saw the performance deteriorate a lot. This also happened when we tested this on external data sets, and also when we tried to use the segmentation of the granular opacities on patients with other kinds of pneumonia, which were not COVID-19. And this is a problem because in this particular case, for instance, in this kind of lesion segmentation, it's not obvious to see when the algorithm is not working properly, because I can have many different numbers of lesions, and this can have very diffuse shapes. Now, another problem that we had there is that actually the virus mutated. So over time, we went through the alpha, beta, and gamma variants, and it, of course, it had repercussions on how the disease manifested in the CTs. Another example in general of medical imaging is for doing prostate MRI. For a long time, endorectal coils were used. So this is what this looks like. Basically, this had to be inserted in the patient to constrict the prostate. And at some point, this started becoming less popular, so now we don't have those anymore. So this is just another kind of shift that happens over time. So we have all of these images which potentially have been annotated. We have these very expensive annotations, but now the images change completely. How can we still use that previous data? Now, the first step to trying to use all of our methods in the real world is just in detecting these shifts. And I won't go into detail on this because of the time, but there are basically, I believe, 3 big strategies on how we can detect when we have such a shift in the distribution. One of them is auto-distribution detection, where we simply look at the inputs and try to detect when an input is very different to all the ones we use during training. We can use uncertainty estimation methods such as deep ensemble, variational inference, etc. And for certain use cases, we can also just assess if the predictions that we are creating, for instance with segmentation, are actually coherent. So yeah, a first step is just in actively identifying these shifts. Now, moving on a little bit, why do I want to talk about dynamic learning? Well, we know that a big portion of the research papers that we read and a big portion of how results are reported in general for deep learning is in static settings. This means that even when we have data from multiple institutions, we shuffle all of the data into one data set and divide it into training and testing. Now, what federated learning allows us to do is to not have to put the data in a central location. We can basically train models in a distributed fashion, and this is great for medical use cases because it's very, very difficult to share the data between institutions. And this is why federated learning is becoming more and more popular on medical use cases. Now, one aspect that federated learning doesn't consider is that clinics are dynamic environments. All of these shifts that I have been mentioning happen over time. We don't know what kind of changes will occur, so how do we prepare our algorithms for that? Now, if we just simply train a model, say in the first domain that we see here, and we want to keep using it, then inevitably the performance will start to fall over time. So what we want to do is to keep collecting data, and we want to keep updating those models in order to have a better performance on a lot of different domains. Now, one problem that is often not considered is that we may actually lose access to a lot of the data that was used during training in the past. We cannot just add more data, shuffle everything together, and retrain the model. This is very computationally expensive, but also we just may not have access to that data. And this happens a lot right now with foundation models, where we may have access to the model weights, but not to the actual data that was used to train the model. So this is what continual learning tries to address, and it's an area that's growing a lot. It's getting a lot more interest because it allows us to do this. It allows us to keep adapting the model without access to all of the data we saw during the trajectory. Now, our big goal in continual learning is what we call backwards transfer. What this means is that the more data I see, the better my performance, even in domains that they have seen previously. Unfortunately, what tends to happen in practice is catastrophic forgetting. This means that if I just take new data and fine-tune the model, I will really only remember that last data that I use, and I will tend to forget a lot of the knowledge that I learned previously. Another goal that we have is forwards transfer. This means that, okay, if I start with a good initialization because I have trained my model previously on similar data, then I will perform best the second I start training with my new domain, right? However, when we try to prevent this catastrophic forgetting, which we do, for instance, through regularization of the weights, what often happens is that our model loses plasticity. So it tends to remember previous knowledge, but it can't adapt as well to new information. In general, we just want to be able to adapt to all of these shifts. However, we have these problems to deal with, and also an additional problem, which is that when we always collect new data and retrain the model, we may actually gather faulty data, and we may be incorporating failures. So we have to build in additional safety mechanisms to avoid that. So how do we go about this? And again, I will go very briefly to this. Very popular are regularization approaches that try to identify which are the important parameters in the model and just not change those that much. And the problem with this is that a point comes of saturation where you just cannot really keep training the model. We also have sparse connectivity approaches that try to keep different paths in the model for different domains. Again, here we tend to reach a point of saturation. What works best in practice is rehearsal or replay. What this means is that I collect a very diverse sample of the images or just the data points that I have seen in the past, and I interleave this in future trainings. And for instance, we did this in the case of we had a total segmentator model, which is trained with an adult data set. This is a public data set, and we wanted to use this for a pediatric population. And here you see the distribution of the ages of the pediatric and the total segmentator data sets. And in this case, we tried several methods, and what worked best was just to keep 25% of the adult data and interleave this when we were fine-tuning that model on pediatric images. So basically, we first trained the model on all of the adult data, and then took 25% of that and retrained that with the pediatric images. And what we saw is that we had better performance. Here you see basically a rehearsal-based approach is the CL. The blue one, basically we had better performance in the younger age groups, but also on the adults, because we were able to incorporate this new information of the younger images. There are many cases where we may not be able to rehearse these previous samples because we don't have access to them. That is when pseudo-rehearsal, which we call, comes in, which basically means generating images which look similar to those we have seen in the past. We have that sort of method, and we have distillation-based methods, but right now, generated pseudo-rehearsal is the most popular. We have a lot of problems, though, with generating images, especially when it comes to very high-resolution medical data. So one thing that we tried is, how about we don't generate whole images, we just generate features, so we just generate samples in the latent space. And this is one thing that we tried here in this case for prostate segmentation. So basically we have a unit for segmenting the prostate, and then we put a variational autoencoder there, which we can condition with the domain so that we can generate sort of images that look similar to those in different domains. And then basically during training, we just interleave these features, so only here in the middle of the model, and we then train the decoder with these auto samples. And this works relatively well, and one advantage that we had is that because we have this variational autoencoder, we also get sort of auto-distribution detection for free by just calculating the reconstruction error. So yeah, pseudo-rehearsal, also very popular. Another thing that they have looked into a lot are expansion-based strategies. So in the simplest form, this just means just keeping one different model for each domain. So identifying when we have a shift of domain and starting a different model. Here, for instance, so in its most basic form, what this means is, okay, I start training with my model. The second that I have a shift in the distribution, I initialize a new model from those model weights, and I continue training that, and I do that over and over. In this particular case, what we were doing is extending that for a situation without rigid task boundaries. So basically, there was nobody telling us, okay, there has been a shift in the domain, so we had to actively identify that, which we did by always calculating the distance to the training distribution in the latent space. And the second, that we identified a shift in the domain, we would initialize a new model. And then always for inference, we would just calculate the distance to the training data for these different models and pick the most appropriate model. Now, this is a very, very simple approach, but actually this works amazingly in practice. So if you want to do something that works very well and cannot do rehearsal training, this is an amazing alternative. So we see that we are actually able to adapt well to new information while still preserving previous knowledge. We maintain the integrity of the segmentations, which a lot of the other methods that we had tried didn't do. And always an argument against these expansion-based methods is that they require a lot of hardware, but that's not really the case, because the only thing that you need is just a little more persistent storage to store those models. So yeah, other things that I tried while working with continual learning is, say, trying to just learn more semantically meaningful information, so trying to disregard aspects of the data that have to do with the domain. We also tried, say, with BIT models, how about we only fine-tune the attention layers and not the rest of the model. And this works to a relative extent, but not super good. One other thing that we can do is when we are talking about continual learning, like say we have a factor that's changing over time, like sex or scanner, we typically have metadata for this, so we can actually remove this through recursive deconfounding, and this is one thing that we have tried, just to explicitly remove these confounders with the metadata. One thing that I want to point out is very often we look at this as an alternative, like either continual or federated learning. Actually, it makes sense to look at this jointly, because in actual clinical settings, we will have to train in a federated manner that is also continual. In this particular paper, we explore how these two problems are very closely related and why it makes sense to look at them jointly. Okay, just to wrap up my talk, there are a few challenges that still remain if we want to have this sort of training in clinics. One, there was a very big lack of evaluation standards for continual learning in the community, which is why we released this project, Lifelong NN Unit, where we extend this popular framework with a lot of continual learning methods. And also, if we want to have more data and more annotations, of course, we have to collect this over time through radiologists, and this is very, very expensive. So there are some methods for active learning that make this a lot easier. One other big aspect is the regulatory considerations. So for a long time, if we wanted to update our model, we had to sort of go through a very lengthy reapproval process. This changed, fortunately, last year a lot. So all of these efforts for changing this paradigm have been going on for a few years. And last year, both in Europe and the FDA, new guidelines were released that sort of point to a life cycle regulatory protocol where you can sort of determine at the time that you give a submission how you will adapt your model over time, and then you can do it without having to go through a very long recertification. Okay, now just in general, sort of how I imagine sort of this training happening from now on what I would like. In an ideal situation, we would have many different institutions, many different modalities. We would train these multimodal models and then be able to do many different downstream tasks. Now, how this would work, I imagine, say, if you have a system, you wanted to train a system for classification of pulmonary embolism, say. You would start with a foundation model, which involves many different types of data. Then you would fine-tune it for the specific task of pulmonary embolism detection. Then you may want to fine-tune this with local data. And then this means that you have quite a good model if you didn't, during all of these refinement steps, forget all of that rich information that you had initially. And then you can actually refine all of these steps through continual learning. And then optimally also do this in a federated fashion. Okay, so sort of to wrap up, some takeaway, data drift is a huge problem with medical images, causes models to degrade over time. We need to detect these shifts actively, which we can do through auto-distribution detection, uncertainty estimation, and actually assessing our outputs. However, to keep models up to date, even models I believe that do domain adaptation or increased generalization aren't enough. We will at some point need to use new data and involve this into the model. And we cannot do this just by trivially fine-tuning, because then our models will suffer from this catastrophic forgetting problem. which is where these dynamic learning paradigms come in, which I believe are necessary for actually constructing meaningful representations and having at the end robust models that are actually helpful in clinics. Okay, with that, thank you for your attention. I wanted to very briefly, if you're interested in this topic of continual learning, we have this series of continual AI where we have some seminars of people who do research in continual learning. If you're interested in medical imaging, from the MICA Student Board, we have a lot of seminars in YouTube where we talk about this. And also we have a series that sort of works at the intersection of these two topics. Yeah, and thank you to my collaborators.
Well, thank you, Camila, for such a nice talk. We have now time for some questions from the audience.
Thanks, Camila, amazing talk. So just one question regarding this pseudo-rehearsal technique you were mentioning. It's not clear to me because you were saying you will generate images that look like your original distribution kind of thing. And so in that way, well, you don't need those data. Like the use case is when you don't have the data, but you need a model that can generate that type of data, right? So in a real application case, how would you do?
Yeah, that's a great point. So basically, you would, while you still have access to the data, you would train this model that generates data that is similar to the ones that you have, and then make sure that that there is no data leakage there, and then you would be able to do this. Of course, it's a good point. You need to be able to, you need to know that you're gonna need this synthetic data at that point. If you don't know this, then you cannot do that. You cannot generate data in that way.
Ah, okay, thanks.
Thank you, very nice talk. I think you were talking about data generation and also from the architecture point of view. But I've seen some words on continual learning and generalization based on like prototypes, and also I don't know if you have people exploring like making the domain generalization from the data point, from the data side of things, like trying to learn more discriminative features on also. I don't know if you have explored that.
Yeah, no, that's great. I mean, those are two fields where I have seen. I think this prototype-based learning is actually very interesting. We also have a work on that as well that I didn't get to discuss on for reasons, but approaching this from a prototype point of view, where you try to have these prototypes that are privacy protecting, yet allow us to capture this variability. That's actually also a very, very nice approach. And the second thing, the second thing that you said was?
In my case, for example, we are trying to train models that are able to generalize to different, by learning discriminative features, like trying to focus less on the style, for example.
Yes, that's great. Yeah, also like lots and lots of fields lots of works that try to do that, just sort of disregard all of this information that is not interesting, and try to focus on the actual discriminative features. This is a little bit what we try to do in this work, where basically we assume that we have here in this work, we assumed, okay, like say we want to generalize to other data sets. Typically, you will at least have like data from 2 different domains. So let's explicitly try to remove all of this information that is not relevant for both of these different data sets. So this is one thing that we try to do, and we also try some other approaches, and of course a lot of works on this. I would say from it's a very elegant sort of solution. This is ideally what we would want, right? To disregard all of this information that we don't find important, and to actually just learn the information that we want. In practice, I found that these methods haven't worked as well for my particular data sets. But in general, I would say that's the most elegant solution.
Thank you.
Yes, we have time for one more question, maybe, there.
Well, thank you for your talk. And well, my question is simple. What's the advantage of using these techniques instead of just using all of your data or the common method to like transformation to move from one domain to the other?
Yeah, that's a great question. So why do we do this instead of using all of the data together? Well, this is a little bit related to this constraint that I was showing at the beginning, where you don't have access to all of the data. So all of these methods are designed with the assumption in mind that you don't have access to all of the historical data that your model has seen. However, another big reason why you may want to do this is, and especially when we look at the rehearsal learning type of strategy, a lot of what the methods do is to try to curate a very diverse set of images where you don't have like over-representation of certain classes. This may also be a reason why you may want to sort of curate this set that is very diverse, because to get rid of all of these elements where you don't, to sort of curate this set where you actually have all of the variable information with regard to different aspects. Why you may not want to do, say, domain adaptation? Well, one thing is, when we think about all of these shifts that happen, it's not typically, okay, like I have data from one scanner, like I have data from a Siemens scanner, I have this data, and suddenly I have data from a GE scanner. There are a lot of these changes that are happening in tandem. So we have changes with the scanner, with disease manifestation, with the demographics. Ideally, we may want to adapt to all of these things at once. Like we don't have really a discrete set of domains in many cases. We would ideally want to adapt a model that adapts to all of these different aspects, which of course sounds a little bit like a dream. I agree, if you just want a model that works well for each particular domain, the best strategy may be to just adapt this to each particular domain. But that's a little bit the motivation behind that, why you would want to have one model.
Thank you.
Well, we can thank Camila again for such an enlightening talk. And we now give the floor for our third speaker. He's Rafael Grompone. He's a researcher at the Centre Borrelli at the École Normale Supérieure Paris-Saclay. He received a master's degree in computer vision and machine learning, and a PhD degree in applied mathematics, both from the École Normale Supérieure Cachan.
Can you hear me here? Yes? Okay. I think I'll use this one. Well, thank you for inviting me for talking here, and especially thank you for this very exciting week. And so what I'm going to talk about is, what I'm going to talk about is, I will make comments on some work from the literature, and what I'm going to do, what happened here? Well, I don't know what's happening. Let's start again, this. Okay, so let's start again. I will make some comments on some work from the literature, and then what I'm going to do, well, first, works I understand very little about, so what I'm going to do is very, and what I'm going to do about those things I don't know very much about, that will not prevent me from making a speculation, and especially very vague speculations. So as you can imagine, that will lead to things that are either evident or wrong. Or maybe it will be more appropriate to use that sentence by Wolfgang Pauli about those things, those statements that are so imprecise that are not even wrong. So all I have to do is apologize in advance for that, and I just hope it will provoke some thoughts. So I would like to first start by making some comments about diffusion models, and so I will first comment on some of the works There is several works that try to compare the images that were generated to the data set in which the model was trained. And this is just one of those. And what in general, well, of course, there are a lot of details about how it is done, and there are difficulties and how to look in such an enormous collection of data and how to compare the image. So there are a lot of things to be discussed and analyzed. I will not do that. But the general conclusion of those things is that in an important proportion of the case, when they look about, they can find images in the training set that are similar to the ones that are generated. So in this case, the top row are images that were generated, and the second floor are the most similar images from the training set. So this will suggest that they will suggest that these generative models, maybe they are implementing in an indirect way or implicitly some copy-paste and maybe style transfer from the memorized train set. Of course, there are works that show that the diffusion models can, in some conditions, generalize, but this kind of example suggests that this model, at least in this condition, is not doing that. Now, there are people that try to test explicitly this hypothesis, and there is a recent work that they did exactly that. They took some diffusion models, and then they worked on a limited data set, so they could do all the work. And what they did is they try to compare what we can get using this locally copy and paste to what the model generated. And so when they are using the same seeds and this kind of thing, they can manage to produce essentially the same result. They can predict very accurately the result of the diffusion models. So here what we see is some results for different data sets and two models. And in each case, we see pairs of results. And in each pair, the result on the left is the one that was created by this particular copy move, and then the other one is the one of the diffusion model. And what we see is that there are very similar results. Now, these are empirical results, but there are also theoretical reasons why what I think make that this is not that absurd, that maybe it makes sense. And I also will only comment on one of those. There are several works, but I will comment on one. And so this work, what they show, and here is not, this is not about diffusion model, this is about neural networks in general. And so what they show in this work is that the usual neurons, the usual neural networks with the usual training methods, when they are over-parameterized, they behave like an associative memory, even if it was not explicitly created or modeled to be an associative memory. So what does it mean to be an associative memory in this sense? And for that, I will use these two schematic representations to try to illustrate that. So what we see here are two schematics representation of the map between the input and the output. So here the x-axis represents the input, and the y-axis represents the output. And then we have also these black dots that correspond to the training examples. And so in the example on the left, we see a red line, and that red line corresponds to the mapping from input to output. And so the red curves correspond to a case in which what we have is an interpolation between the training examples. So that the result is that the mapping is a continuous curves that pass through the training set, but in a continuous ways. And those points are not special points, that they are one more point among the mapping. Now, in the schematics on the right, what we see is a case in which we have associative memory. So in this case, the mapping is not continuous, but what we have is the output is concentrated in some discrete possible output values and are concentrated on the training examples. So in other words, when we have input we will get the same output as we will get from one of the training examples. So in this way, this is an associative memory, because what we are retrieving is one of the training examples. And so if we have an input that is near but not exactly the training set, what we will get is a recovering the training examples. So, so now I will make a huge speculation, is saying that, well, sorry, I didn't went to what these people did. So what they did is that they show in very simple examples that the usual training that we use in neural networks, they showed that they, at each iteration of the training set, it will push the mapping from input to output more and more into one that behaves like an associative memory. So they were able to show that in very simple and very tiny examples, and they have argument to suggest that in other example is maybe the same behavior that is happening. So now I will take this and I will make a huge speculation, and I will suggest that maybe the strength of neural networks is the fact is that they implement an associative memory. And of course, an important aspect of this thing is the fact of being able to do this association in a local way. Now, of course, this is a speculation. I do believe that this is maybe a good understanding, but of course I'm not sure, and I don't pretend that you will be convinced by these words. But what I'd like to do is what I would like you to do is to take this as an hypothesis, and then try to think a little bit what they will be telling us about the intelligence of these neural networks. And so there are many people that feel that saying that or that the main thing that neural networks can do, or that they are the essential thing that they are doing, is making an associative memory. I think there are many people that feel that this is like an insult to the intelligence of neural networks. But my impression is different. For me, saying that maybe the neural networks are implementing an associative memory is going from neural network work by magic to we have a good reason for why they are working. So, and that's what I will try to convince you, or at least that you may consider that it's not is a possible idea. Now, why that? The first thing is that it's not a small thing to be able to encapsulate and be able to restore partially known examples in an efficient and universal way. So I think that is a great feature that they can do that, and also is a very useful thing that they can do that. But more importantly, what I think is that this is the essential strategy of what we call intelligence, because in a way, intelligence is being able to recognize in our environment a situation, or in a situation we know from the past, and then act in a way that was successful in the past. So that's not the whole intelligence, but I claim that this is an important part of what it is intelligence. Of course, maybe when we do that, what we have in mind is maybe like a bacteria, and maybe there is a gradient of temperature, and so it's behaving in a way that increase the survival of that cell, and in that sense, it doesn't seem like very impressive or very intelligent. But I will try to show you, or I will try to use the work of others to show that maybe when we put together a lot of association or a large associative machinery, we can go much further than that. And for that, I will use the result of this book, this very well-known book that you probably know. The book is called Thinking Fast and Slow by Daniel Kahneman. And so this is a psychologist trying to study human behavior. And what this book describes is a whole collection of experiments and results that show that, well, we can describe maybe the cognitive system of the cognitive capacities into two categories. The ones that are called System 1, that works fast, and what is called System 2, that are mechanisms that work slow. And of course, this is a very simplified, and it's a simplification of what this is, but it's a simplification that lets us think and understand a lot of things. So what is this slow thinking? So slow thinking is what we do most of the time, all the time. And so for give you an example, this morning I woke up, I knew I wanted to came for KHIPU. I knew also that I was sleepy. I knew that I probably needed a coffee. I knew that I like coffee. I knew that I wanted to have a coffee, and then I prepared the coffee, and I was able to drink that. And in all that, I was essentially using that fast way of thinking, that fast way of behaving, of acting. But I will say that in all those actions, there is meaning, there is understanding, there is knowledge, there is intelligence. And so I will say that this fast way of behaving is essentially what we are doing all the time, and is the basis of what we call intelligent behavior. Now, this book claims that essentially that part that is the fast thinking is essentially a gigantic associative machinery. And so what I will claim is that, well, neural networks are indeed implementing the most basic component, the most basic part of what is our intelligent life, and that's the associative part, and is the thinking fast. And so in that sense, I will claim that maybe a large part of the AI we have now is maybe associative intelligence. Now, of course, in this book there is the other part, is the slow part, and maybe I'm dyslexic, so maybe I confused slow and fast. I'm sorry for that. So just before I was talking about the fast part, and now we'll talk about the slow part. So this book also shows, and it's everywhere, contrasting between this fast and the slow part. So what's the slow part? The slow part of thinking, the slow part of behaving, is the one that we need to do scarcely during the days, and this is the one that we use when there is a dilemma, there is something that is not easy, we have alternatives, and it's not very clear which way we need to behave. So for example, I was invited to talk here, and I was a little scared, so it was not easy to me deciding should I accept the invitation or not, and even then, what should I talk about? And so I have to ponder one thing or the other, and it was slow consideration about those things, and sometimes we make the wrong decision. But anyway, we have a whole set of different capacities for doing this slow thinking. And another aspect of that is that another thing this book shows is that in the contrast between this slow and fast thinking is showing that the fast thinking is full of bias, and is full of wrong decision, is full of wrong evaluation. An interesting thing is that kind of bias that we see, that this book shows that we humans do all the time when we are behaving fast, is very similar to the kind of bias that neural networks do all the time. So I will say that's an extra argument for saying maybe that makes sense. But also I will use it in the other way around, because this book also shows that in many of those biases that we humans have all the time, when we are pushed to think in a slow way, when we're pushed to think in a slow way, we are able to sometimes correct those biases, or maybe act in a more reasonable way. So what I will claim is that maybe the only way to correct those biases that we see on neural network is not that easy as a magic bullet that will solve all, and maybe we need all the other tools that we have in the slow thinking to be able to cope with that, to that. So just to show an idea of what's maybe is there in this slow thinking, maybe this is a completely random list of possible things that may be in a cognitive system. And so the first one is associative memory, and that's maybe the one that we are exploiting now. And so maybe I will, again, making a huge speculation, say that maybe if we are having diminishing return of the scalability now, is maybe because we are now approaching the limit of what we can do by associative intelligence, and maybe to go further, we have to go beyond that. We need to start working on those other things. And of course, we are already doing that. Especially, I think we are making, or people are making progress in reasoning, and so that's maybe one of the ways into we can go beyond that. So that's all I want to say. Thank you for your attention.
Hello. Yes. Well, thank you very much, Rafael, for this talk, and thank you for your slow thinking system for having accepted giving it here. So we now have time for questions. Yes, I can. Well.
Okay. Well, thanks, Rafa, for such a thought-provoking presentation. And since you mentioned it, I wanted to ask you, what are your thoughts on these reasoning models that are doing this kind of chain of thought or inference time compute? Because I've seen online that some people are claiming that, oh, maybe this is this famous system to thinking.
Well, what I will say first is that I didn't mention that, but I think that probably I will say that this associative machinery is probably the base on which all the other things are based on top. And I think that this kind of reasoning that we are making are probably the right way of doing it. Probably, my guess will be that when 10 years from now, we will see, well, that was very naive approach, but that was the way to go into the would-go way. So my impression is that that's probably the way of doing that. And also, I will claim that, well, for me, it's very interesting. I think these are things that are pushing into making, maybe letting us understanding more about our reasoning. And probably we'll discover that reasoning is not as special or magical as we thought, and it's just going hand in hand, pushing concept one to another and doing that. So from my point of view, it's a very interesting and probably very well-directed approach. But of course, I have no idea.
Okay, thank you. Thank you for the presentation. The first thing I thought when you were presenting this associative memory issue, and I will quote that, is that, oh, that looks really similar to me, to the concept of overfitting. It's like
what, sorry?
overfitting. It's like, it seems like an overfitted model. Can you, give you, the impression if there is any relationship in between possible models that are overfitting and associative memory, or I understood everything really, really wrong?
Well, I don't know. I do believe that this is probably some kind of minor overfitting, of course, but that's all I can do. And what I will say is, yes, I think it is indeed a kind of overfitting, only that because we have such a large collection of data is not a bad thing. That's what I will say, but I don't know.
Okay, thank you. We have time for maybe 2 more questions. Anyone risking a question?
Thanks for the talk. So what sort of methods would you say from the deep learning side are more towards the slow learning, like maybe like symbolic learning or graph models or?
Well, of course, I don't know. I will say that from what I know that is happening now, my impression is that those approach into reasoning are what is more promising going into that direction. But I don't know. There are other aspects in this list. Well, this maybe will appear at some point. There are other things that need to be done, and I think there are other things in which there are probably and we heard yesterday a talk where they were discussing about other things that were also in this list. But I have my opinions, but I don't think my opinions have any particular value, so I prefer not to waste your time with that.
Okay, thank you.
Does anyone else want to ask a question? If not, I will give the second question here. Okay.
Thank you for a really thought-provoking talk. If we think about the 50 years of AI, or maybe 70, there's been a lot of bio-inspiration, and the question of building associative memories has been around from the very beginning. the question of how to design networks that do incorporate feedback and reasoning has also been around for a very long time. And the fact of the matter is that at the end of the day, none of those bio-inspired approaches made it to really be successful in practice. And so we went in a fully artificial way that it's not actually inspired by neuroscience or memory or anything like that. And now we seem to be trying to map it back again to neuroscience. And the question is that needed or not? Maybe it is because the models are so large that all of a sudden they might naturally have all of the abilities that previous models that were so small would just never be able to have. And still, even though the models are very large, they were never necessarily trained with reasoning, or if we think the percentage of training that was reasoning or associations or anything like that is not even 1%, right? If you think about the LLMs, probably 99.99 was next token prediction, right? So what are your thoughts on, and this is maybe a crystal ball, it's more of a debate, of whether neuroscience will ever be successful for this or not?
Well, I don't know. what I can, the only thing I can say is that maybe when we try to do those kind of things in the past, we were trying to reason with very little things to reason about. Now we have an enormous set of knowledge in which we can reason about. And maybe reason is not that complex as we thought, and maybe small things well done can do the job when we are doing that on the right base of knowledge. But I don't know why I'm saying that, because I have no idea.
Oh, well, one more question and then we move to...
Thank you. Not so much a question, but more of an opinion. On the history of the influence of neuroscience or cognitive science on AI, I'm looking at the code here of something that is like a DeepSeek model. It has things like dropout. That was biologically inspired. That's how Jeff Hinton came up with it. If I look at an encoder, conv layers, that was biologically inspired. That was Professor Fukushima, working from the works from Hubel and Wiesel, and then later Jan LeCun added backpropagation. Backpropagation, maybe not biologically inspired. But a lot of what we exist today was biologically inspired. And you could just talk to Professor Fukushima or Professor Jeff Hinton, and they will corroborate this. The one thing that didn't last the test of time was this crazy idea that symbols exist inside minds. Symbols are tools in the world. And nowadays, with tool use and so on, with these giant associated, it's completely correct. It's just it was a question of scale and compute and data. Now that we have that, we're using symbols in the world through chain of thought, through information retrieval. The debate is gone. But at the end of the day, this sort of association and it's basically all there is to it. Intelligence is not such an amazing thing. So you only really need to predict the next token, which is the basis of association, is entropy minimization. And entropy minimization is all that is needed.
Okay, thank you for your attention and your questions.
Well, thank you, Rafael, for this talk and all this polemic. Now I invite the three of you to come here for a panel discussion. We have 10 minutes, where the good news for the rest is that now you can ask questions and the three of them will answer. So. So now the idea is to devote these last minutes of the session for a panel discussion. We are open to questions from the public, but if not, I will start to break the glass. And I'd like to ask the fabulous speakers we have here, what are the difficulties or the challenges you identify in the current state of computer vision?
Who wants to start? What are the challenges that we see in the current state of computer vision? I find this difficult because I find that it's always better to see sort of the advancements that we have had. Like there are certain challenges that we've always had, such as from traditionally like lack of data, overfitting, etc. And it's always a little bit easier to see sort of these advancements that we have. I would say maybe in a very like wide scale, one thing that's a little bit strange going on is how we are, like how companies are working who actually make, say, large models available. Like we are seeing like this sort of race happening, which is moving very quickly, and sort of lets a lot of questions unanswered on, okay, what sort of payment model will we use for being able to use these images? What are the privacy regulations like, etc.? So that's like sort of a challenge which is not really connected to computer vision. I would say from my perspective of somebody who does a lot of like continual learning and also like reinforcement learning and such, one big challenge that we still have is how do we also avoid this bias where so much of the output that's generated now by humans has been influenced by different models, also in computer vision. So how are we able to, if we want to use this data for training models, how are we able to distinguish what is actual human input or human annotation from what is created by a different model? Or are we coming into a thing where we are sort of retroalimenting what some models have done in the past? So I would say that's maybe from an annotation point of view a little bit strange that's happening. Anybody else would like to give some other answers?
Yeah, I will say from my perspective, something that is happening is that I think we have to go back to physics and go back to understanding the way where to do like continual learning stuff, to do domain adaptation, domain generalization. We need to understand what is happening there, right? And the problem that we hit the wall already, only working with data. And I think that we need to, especially to work more closely with a specialist in order to do more interesting solutions, I would say. Because we see, as you were mentioning in your talk, it's very difficult to test models with different domains and so on. So I would say it's important to try to understand how to do models more robust against these kind of things and trustworthy as well.
So now we can move to public questions. Does anyone want to ask something to the panel?
I would argue that one key challenge in computer vision today is over-reliance on language. And I think reliance on language was a great thing because associating visual inputs with semantics, it's mind-blowing that you can do text to image and everything that has happened in the last. But whether foundational models with vision truly understand the vision aspects of it. And so I think some push for reducing, if you do it without language, can you do it? And it's not clear. And so I think 3D reasoning seems to be, you can easily construct 3D reasoning examples where you would get failures. But certainly the great success thus far has been the use of language, I think.
Yeah, that's a good point. Actually, one of my students started working with VLMs for robotics, for example. And one of the things we saw is that people don't even know how to evaluate this kind of thing. They're only using like success rates, for example. But I think I saw a poster. Some of the posters were trying to understand the reasoning process. I don't remember. Very interesting stuff, because you change the order of the components in the scene, and this will make the model to completely fail. So yeah, it's a very interesting. Trying to introduce the 3D aspect, 3D reasoning aspect, I think is quite something there.
Yeah, I agree 100%, and I think in general, so many of recent advances that we saw lately have started in NLP and then been transferred to computer vision. And I think to a large extent this has to do with the amount of GPU memory that images require and video even more, which is also a huge challenge in computer vision, how we deal with this. So this tends towards an over-reliance in language and language data. I agree 100%. Yeah.
If I can add something, my impression is that it's not only a problem of GPU, but also that the world of vision is much more complex, I will say, than the world of words. So the world, even if it is enormously rich, I will say that it's tiny relative to the one of image. So I will say that we still don't have models that really understand the visual aspect, and that's something that maybe will come, but probably the great problem is how to get data in an efficient way, or maybe it's easier with simulations, I don't know. But probably that's, I will say we may have a good base of knowledge in language, but we don't have at all any similar to that in vision, I will say. But something that probably will come, I hope and I guess.
Thank you very much for the question. We have a
Hello. Going in the same line with the NLP analogy, I want to know your thoughts. I think this is a very interesting time to be doing computer vision, and the fact that transformers are the state of the art in most computer vision applications blows my mind. If you asked me like years ago, this is the right approach to work with images, I would have said, no, the way we do tokens, the way we do even the positional embeddings, even though there are some works specifically to adapt them for images, it's pretty much plug and play from NLP, and it breaks all the things that we handcrafted, the convolutions, the multi-scale representations. As a computer vision scientist, it really blew my mind when transformers took away. And I think we have so much work to do to tailor the architectures and understanding towards really vision, state-of-the-art vision algorithms. So in that line of reliance on NLP, not just the connecting images to text, but also on the using, kind of borrowing their architectures and they are taking over. What are your thoughts, or what are the interesting lines where we could work in the next 5-10 years to make more image-based the NLP architectures?
I think that maybe something along the line of introducing physics, no? The way the world works, especially for some areas like robotics, but I'm not an expert in robotics, so I can't really say.
Yeah, sorry, go ahead. I will say that it's very hard to make predictions, especially about the future as the world goes, but I will say that my impression is the same as you. I will say that probably we will need a new kind of architecture that will be more aimed at images and vision than transformers, but I don't know. Probably we will get the solution when people will start working really hard on that, and they will need a good architecture that will go fast and will be able to handle the information. And so my intuition is that we'll need something that uses the same kind of ideas in a more adapted way for images, but I have no idea. People will find it, not my intuition.
Yeah, I agree, we can't know. What I do think is we will have to start going away from just using raw data, and for a long time this has worked quite well, right? Like we just had like raw data, like raw images, and then we applied convolutions, etc., and we use this directly. I think this just creates a lot of practical difficulties that we can potentially circumvent by representing data in a different way, like say for instance in scene graphs or in voxel clouds, etc., in a way that where we compile the relevant information in a lower representational space. So of course I cannot make any predictions, but that's how I imagine, especially if we consider, okay, like say even for natural photos, like we are moving away from like 2D pictures to like data collected by the Meta AI glasses or whatever. It makes sense how we are going to start representing this as just sort of a scene representation, perhaps, instead of like a video with very high resolution frames, because that's just not feasible to work with that sort of data. So that's maybe my prophecy. I don't know. Let's see.
Well, yes, we shall do one more question since he had already asked for it.
Thank you very much for this opportunity. Okay, my question is, what do you think about the state of robustness in computer vision today?
Yeah, I can start. So, of course, like in my particular field of working with medical data and also in particular with CTs, MRI, we are very far away from where we believe we are. There are still, like, as I'm saying, like state-of-the-art models that perform amazingly in challenges, products that are commercially available that when you actually test this, the robustness is so much worse than you are expecting. A big reason behind this is yet the lack of prospective testing. Another big reason is the lack of defining metrics that actually align with what we expect from these models. But to give you some context, for instance, there is this one product that's quite popular for ICH detection. We did a small user study with radiologists from a university, and less than 50% said that they found it useful in some way for making their predictions. And from the other portion, like around 40% said they actually found it more difficult to work with it. So in terms of robustness, we are quite far away from where we want to be, I think. At least in my particular field, I think a very big reason behind this is so many landmark works in computer vision have been done with these sort of benchmark data sets like CIFAR, ImageNet, MNIST, which just don't really represent real world conditions. So when we move, and even then, you know, we have like these papers, I say by Hendricks, where even like some slight permutations already break the models. But if we try to work with actual real world data, we immediately encounter a lot of robustness issues. So yeah, we are quite far behind in that respect. I do think that sort of self-supervised models that are trained with large amounts of data have helped increase robustness a lot. Like starting with a model that has been trained in a self-supervised fashion by a lot of data does tend to result in more robust predictions.
Thank you. One thing I will criticize, and one of my students is doing adversarial robustness, is that a lot of people, you ask them, why are you doing this? What is the application of this? And they cannot tell you. This is my main criticism. And the second thing will be, I think that what is needed is what happens in Mikai, more open challenges. Because normally in computer vision right now, people is working, as you said, only one data set, two data sets, but maybe people is trying to combine different sources of data. I think it could be more interesting to actually test more robust solutions. This is just
Well, we have come to an end. I'd like to thank you again to the three speakers for having accepted being here, and of course to all of you for assisting to this parallel session. We can go now for coffee. Hello, you have to come back at 4 p.m.
Okay. Yeah.
no sale esto, ¿no? Hello. Okay, it's okay. Good afternoon. Welcome to the afternoon slot. We are now starting the last research talk, and it's a pleasure for me to introduce Barbara Poblete. Barbara Poblete is a senior applied scientist at Amazon Search Experience Science in Seattle, USA, and also a part-time associate professor at the Computer Science Department at the Universidad de Chile. She was one of the founders and PI of two of the largest research centers in data and AI in Chile, IMFD and CENIA, respectively. And formerly, she was a researcher at Yahoo Labs. So welcome, Barbara, and thank you for being here.
Well, thank you for inviting me. It's very exciting for me to be here and to see like familiar faces and former students and everything. I hadn't been giving a talk in Chile for, I would say, about 2 years maybe. So I tried to do kind of a bridge between some of what I was doing when I was in Chile in academia, kind of setting my own research agenda and doing whatever I wanted and whatever my students were interested in, and then how I had to translate that knowledge into studying the sort of same problems that I thought were still interesting in industry. It's not going to be like a journey that I'm going to be narrating, but more like different research projects that I've worked on and how we have leveraged, machine learning in some of them. I'm not going to go very much in depth in that. You can see this talk as a talk coming from somebody from the application side, that I use AI and machine learning as a tool. So I'm a consumer of all the things you guys make. And every time I'm excited when new advances are made. The work I'll be talking about from, oh, that sounds different, yeah. The work I'll be talking from academia is work done at University of Chile and has nothing to do with the work done at Amazon, so I'm making that disclaimer. And the work in industry is the work I've done at Amazon. So I started in BUCHEF, which is the engineering school here in, one of the engineering schools here in Chile, from the University of Chile. I worked there for about, I would say, 12 years, a very, very long time, and I did a lot of research on social media analysis. I started off working at Yahoo Labs, where I was looking at search logs, and from there, when I switched to academia, I had to find a public source of data that I could look at that could be interesting and generate value. So then we started looking at social media, and oops, I just wanted to show the other logo. That's the place I went to afterwards. I went to Amazon as a visiting academic. I was there for a sabbatical. After a while, my family really didn't want to come back for some reason, so I decided to switch to an applied scientist career, which at that time I didn't know was like starting a second career. And I wasn't expecting it. And it's been like a very fun ride to do that. So in this talk, I'll talk about applied research of social signals. And mostly, one thing I always try to emphasize is that since I'm like not a core machine learning person, most of my insights come from like deep observation of the data and formulating hypotheses from the data, and from there, testing and evaluating and doing interesting things from identifying those points automatically. So that's basically part of my work, and leveraging machine learning as a tool, and also how this tool has become increasingly more easy to use and increasingly more useful, allowing us to save a lot of work. Let me see, so outline, I'll talk about academia a bit. I'll talk about e-commerce, those two things. I think, haven't given a talk in a while. Sorry about that. There. Okay, so online social signals at a low level, when we look at them, are mostly like things, what is the content that we produce? Like, what are the trails that us humans are leaving online? And what can we learn from them? So at a low level, it would be like content of social media posts, the text, the images, whomever I reply to, whatever I choose to share, that is also part of it. And different interactions, who I become friends with, that's kind of the low-level version of that. Also, there's the high version when I'm trying to look at sentiment. So what is the sentiment regarding a certain entity? What are the opinions regarding certain events that are happening? So that would be like higher level signals. What are the preferences that people have? And what are the networks that emerge throughout as an event develops, for example? Mostly, it's anything of how we express ourselves online and how we express our needs online. I like to focus mostly on the part that is this explicit contribution that people do on the web, like when I choose to post something in social media and I choose to make it public. I like to look at that kind of information. Or when a customer at Amazon post a review, and they want to share certain things in those reviews. Or you submit a search to a search engine. So that's kind of what I'm looking at, and I'm mostly looking at the content that is published. So in social media has this thing where it's become really useful for the area of crisis informatics. My group in the University of Chile was doing a lot of research on that, which is like, we live in a country that has a lot of natural disasters. I hope like none of them happen while KHIPU is taking place. I'm pretty sure it won't. But I still will talk about it, don't get scared. But this is a post I found on Instagram that was like one of the first posts I was able to identify with a video of this plane that was landing in Toronto from Delta and that it flipped over. So that was one of the first things. So social media provides real-time information. So sometimes it will be the main information source for a lot of people. There is also this other post that was on Facebook of somebody that got off the plane and took those pictures. So this is like the way in which we achieve instant information, or in which we used to achieve instant information. So you've noticed I've sent Twitter. I'm not saying X for now. Okay, let's see. And that was a video actually of a person that they posted on Snapchat that they were inside the plane. So the video shows as she gets out of the plane, manages to get out of her seat and jump off the plane. So that was posted on Instagram. So all these information sources where people are publishing and sharing content. Might have to stay over here. So the first work that we did, in which switching over into academia, was looking at earthquake data. And this is something I'm going to mention. It's a work that we did very long time ago, but I wanted to mention it because I think it's a good example of the things that we can do in Latin America without a lot of resources and research and have a huge impact. And still, like right now, there are so many tools available to all of us and that are just have so much capability. So I believe more than ever, like research can be done anywhere in any size institution with the resources we have. So I was in a very small lab at this time, and there was an earthquake in Chile, which was like the eighth largest earthquake in the history of ever recorded. And what happened was that there were no communications, so all the communications happened online on Twitter. And we just decided to take a very deep look at that data, at what were people sharing on Twitter. And we found that there was a lot of misinformation being shared online. So we did this manual classification of rumors. Some of my students have seen this many times, but I'm still going to talk about it. We did manual classification of rumors. And why I'm emphasizing this, like, we could have a hypothesis, but we first need to look at the data and explore it and see what's there and see what makes sense to study. So we looked at all the misinformation that was being spread during the earthquake. And you have to remember, like, there were no other communication sources at that time. So whatever was posted was like the absolute truth. And there were like funny things, like people being like famous actors or soccer players that were supposed to be dead, but they were not. So I thought that was kind of funny at the time for some reason. And then there were other things like the airport of Santiago is closed, things that ended up being true. So just by doing this simple analysis, we were able to kind of, and doing some feature engineering to identify like clear differences on how people spread rumors. So when a rumor turned out to be true, you can see that almost nobody would deny that. Like, we wouldn't see any other comment saying that's not true. When something was not believable, a lot of people would say, hey, where did you hear that? What's your information source? Things like that. So there was like a general intuition in the overall network of what was happening. And that phenomenon was interesting to see if we could learn from it and learn to identify what information was like more credible in the network than other information that was going around. And we envisioned this as maybe at some point we will have a tool that everybody can just look at it and say, is this true or not when you're consuming information? Like, we had no idea what was going to happen like now, where many people don't really care if somebody has said this is false and then somebody has posted the evidence that it's false. It's mostly, it has evolved into something where it's aligned with your political values or principle, how the truth is defined. But at that time, we did not have that. So we were envisioning this tool that would tell you if something was credible or not online, and it seemed super straightforward on how to do it. So what we did was just apply like a machine learning approach to a general scenario that was not a crisis scenario. We annotated, like we used a mechanical Turk to annotate a bunch of rumors on Twitter, those that were newsworthy, not newsworthy, those that were true and not were true. And then we just applied like feature engineering and decision trees on them, and we were able to get pretty good results in classifying newsworthiness versus non-newsworthiness. So that worked, and we published this paper that was information credibility on Twitter, and that was in 2011. So we had pretty good metrics for newsworthiness and credibility. And things that we found was that if you relied on network propagation and like the top tweet element features, also like the approach was relying on features that were not related to content. So it was very much language agnostic. So this feature engineering that we did was language agnostic because it was relying on propagation in the network. And it worked pretty well. And one of the main conclusions was that the less that you rely on varied sources of information, so for example, if you rely only on a few social media accounts that you follow, the more likely you are to believe false information. And this is absolutely true right now. But it has expanded to also formal news media that has also been spreading misinformation as well. So it has taken this whole new color. At that time, this work was the first work to study online misinformation, to identify it as a problem and write a paper about it and propose a solution. We were awarded the Test of Time Award at the web conference 10 years later for doing this work. And I remember at the time that the work came out, there was a lot of reluctance from other scientists in believing that we were able to do this because they couldn't understand how this small lab in Santiago had done this, that the researchers at Twitter at the time had not been able to do or had not thought about. So it was met with some criticism, but I think after 10 years, it looked like it was, okay, reasonable research, well-grounded, and opening up this whole new area. So this is kind of the message. Anybody can do research, and we can do it from any part of the world, and I actually think it's an advantage to be in a place where there is a diverse group of people and we are exposed to very different circumstances than the mainstream, like the global north, because we're exposed to a whole series of problems. We were exposed to an earthquake and lack of communications, so we wanted to look at that. So I think everything is an opportunity in that sense. So that's one kind of social signal when we look at what people do in social media to try to identify crisis. So from there, one of my co-authors, Carlos Castillo, wrote this interesting book that was called Big Crisis Data. I highly recommend it. And there came out this whole boom on how we were going to use social media to be able to identify emerging crises and identify the resources that were needed. There were like some famous works that studied hurricanes, and they could identify the amount of resources needed to bring for help. And that could be done just like in a few hours, instead of having people on the ground and having them take months doing surveys and analysis of that. So it was like a shortcut at the time. So one of the tasks that was, most of the work was invested in this, in crisis informatics, was on how to classify if a message on Twitter was like the main source, and usually text was being used. How could we identify if a message was talking about a real time crisis that was happening? And how could we identify like relatedness versus non-relatedness, as well as how could we identify different kinds of needs, like affected individuals, caution and advice, donations that were needed, infrastructure, others that were of thoughts and prayers, and other useful information. So what is this useful for? So when a crisis emerges, there is this critical time at the beginning, which is very few minutes that you have to gather information. And any information you gather in those initial few minutes is golden. So it will provide a lot of help. So in the case of the earthquake in Santiago, there was a tsunami afterwards, and this tsunami was not announced by the authorities. So a lot of people died. But it was posted on social media, and there were pictures of people showing the ocean pull back. So that would have been a useful piece of information to have caught at that moment and said, hey, this is an alarm of something that is going on and requires caution and advice. So that's the kind of thing that is one of the tasks that has consumed the area of crisis classification for a very long time. And what we found here was that it's highly sensitive to the training data, and it's highly sensitive to the domain. So I think most of you that worked in applied areas, I think I've heard some talks about this. Like, if you slightly change the conditions, sometimes your model will not work. So this is something that happened all the time in crisis informatics. So if you collect the data in English for an earthquake that happened in North America, and then you try to use that model that you trained to identify those messages, it would not work for an earthquake in Chile, because you're changing the language. And also it would not work for maybe an earthquake that is happening a year later, because language is changing as well. So, or in a different cultural setting, it wouldn't work. The other kind of transfer that you could do was, if I have a model that detects earthquakes, can I detect floods with that model? Can I detect a new kind of disaster that I've never seen before? Like, I don't know, a train crash or something like that. So we kind of wanted to have a multi-purpose tool. And we didn't know how to do it because all the models we were training were so sensitive to the training data. So my student at the time, Cynthia, with the help of my other student, Hernan, this is the paper that we wrote about that, was like, how can we generalize across languages and across domains for crisis classification, especially for low resource scenarios. And in general, I felt that working in Chile, all my problems were low resource scenarios. Like, I never had lots of annotated data. It was very hard, and that probably happens to you, like those that are not working with English most of the time. So this is a problem that is highly sensitive to the domain. Most studies were done on one type of event, mostly for English. It was impossible to generalize this task, and annotating high quality data sets was very expensive, and it made it like impossible. Every time we had a new crisis and wanted to annotate more data, it was very, very hard. And the same happens for hate speech classification as well, because you have like cultural differences between how people speak. Even those of us who speak Spanish will speak differently in different countries, and hate speech is different as well. So we tried a very complex setup for this. I don't expect to explain all the details or for anybody to understand all the details. I just want to give an impression of the setup that we had for this paper, and it took us a long time to come up with this. So what we wanted to do was to evaluate what was the best representation for data that could make the problem, like the model, generalize better. So for example, if we were going to represent the data from earthquakes, if we were going to use like multilingual embeddings, and that would maybe allow us to do some transfer learning to other languages for the same events. Or if we would train with data for our earthquakes and then see if we could classify for floods and things like that. So my student Cynthia, she built this huge Frankenstein data set that gathered all of the available data sets for crisis informatics, and she attempted to unify them. She did an excellent job in unifying the data sets and trying to make like the labels match and everything and have a similar criteria. So that was about 50, it was 7 different data sets. No, it was 53 events. So I would say one event is usually one data set, and about 160,000 messages that she made sure were classified and good quality annotated data. So we used we trained and evaluated with different representations. So we had like linguistic features. We used machine translation with GloVe. We used Muse with language features, multilingual BERT, machine learning with BERT, and XLM with Roberta, I remember. So there's a lot of details in that paper if you're ever interested. And the best we could achieve was 89% F1, only for English, but we were able to generalize to other domains. So we were able to classify for any disaster that we were not able to see before. And this was pretty good for us. So I hope you get kind of like, and we fixed the classifier because we were testing like what was the best representation we could use for this data. So this was our accomplishment there at that time. So it was so much work to make the most of this very valuable small data sets that we could get our hands on. Do you think this would happen today, what we were doing then? Like all this work? Yes, no? Yes? No? No, yeah, you're right, no. So enter very large pre-trained language models and all of the different flavors and companies. And there's this big leap. And everybody's a bit reluctant. Like I started working at Amazon and I was working at the university, like both at the same time. I was a visiting academic. So I tell my students, I think we should just try to see what's the benchmark like that we get by just using ChatGPT on this task, like 0 shot. And they were like, no, that's not going to work. And we tried it. And can you guess what happened? The prompt was something very simple, like, you are a social media message classifier. And you have to tell us if this is related to a crisis, and we give one example. It could potentially have more examples. Remember, our task is very text reliant. So this kind of thing should work well to kind of simulate the real world knowledge that is inside the LLM. And what do you think we got as a result? We used just the pre-trained ChatGPT, I think. From the results we got, I think the information was already there in the model, just because of the sheer size of the model. So we actually got the same performance with 0 examples and just saying, pretend you're a classifier of like disaster messages. Can you say if this tweet is expressing relatedness to a real-time crisis event that is happening? Yes or no? And that achieved the same performance as our past classifier, where we had to test all these models before. So, same performance as this, just like using ChatGPT. And then we did reproduce with like open models, like and also doing like, there's a follow-up paper on this, like trying to see what's the smallest model that we can fine-tune to achieve the same performance. So I think it was like Llama 2 fine-tuned with like tens of thousands of messages would achieve the same performance, but it would lose out-of-task accuracy for anything. So it would become very, very specialized. But the thing is this, like there is enough knowledge, like all the web is in these pre-trained models, and we just need to have the right way to find that knowledge, but also not just to rely blindly on it, but to have a good evaluation system in place, like a good framework of how am I going to evaluate and what kind of task I can do like right away. So in my area, mostly I'm always trying to find these really small tasks that a human can do really well on text that are pretty subjective. Like, is this person shopping for a Mother's Day gift? And the query in Amazon is best gifts for mom, okay? A human can tell you, yes, this person is probably shopping for Mother's Day gifts. So that kind of thing that a human can do simply, and it's like a yes or no, is something that usually would take us a long time to train and a lot of training data, and now we can kind of skip that and shortcut it and only curate a small evaluation set that is of very high quality, but that covers the problem space that we want to target. So that's the thing, because the large language model can generate for everything, like for all the problem spaces. It could generate like the opposite of what I want. And it's very sensible to the prompt and everything, so we need to have a good way of kind of tuning this so it can work. Okay, so some thoughts based on that experience. It's a very good tool. At least I know it's a very good tool for so many other things. It's like I'm just narrowing down this task of looking at social signals, mostly based on text. Like, how do we learn from text generated by humans? So it's a very good tool for that, to give a subjective judgment, and it will only be as good as humans are for that task. So if you have a task where humans really don't agree very well, that's kind of, that level of agreement in our experience is the best the performance the LLM will have for that task. So potentially we can shortcut any task, and we will invest our time instead trying to get a very good training evaluation data set and examples for that. And it can be an iteration. Like, we can identify errors, or the space can evolve, and we can start redoing this, like, prompt engineering. So, considerations. We must evaluate performance. I have worked with lots of teams that will just say, okay, just put an LLM to do this, and it will never be evaluated. It will just look good. And there will not be much exploration on what are the best ways of prompting that LLM to get the best result either. So I think evaluation is key. And understand the problem really well is also important. So now we can focus also on small data, like how to create this really good quality evaluation sets where we want to test our new classifier. I'll talk just a little bit about signals and e-commerce, which is kind of what I started doing at Amazon. So I arrived at Amazon with this knowledge on information retrieval, web data mining, and machine learning. And I was starting to learn about like large language models and fine-tuning and all that stuff. I didn't do my PhD in machine learning, so for a bunch of us, this is just like learning as we go. And I found myself in a place where scientists are actually applied scientists. So you do all your work. I've met people here at the conference, and they tell me, like, who does your experiments? Or who codes like your experiments? It's like, I do. This is, so that was a shock. But then I learned pretty quickly, and it was a lot of fun. So it has allowed me to learn so many things and tools that we have. So what are signals, online signals, and e-commerce? So we have, for example, what products do you click on? I'm talking about Amazon. What things do you add to your shopping cart? What are things that you purchase? What are things that you return? What do you tell us when you file a return? Like, why didn't you like it? Was it like bad packing? Wasn't as expected? Didn't fit? Also, something I really like is reviews. Because they have like opinions, sentiment, images, videos, so many things. This is a review of a bed that I got for my cats, and they really like it. So we all have the opportunity to express ourselves in reviews somehow. I have this idea of creating a specialized search for funny cat reviews. I haven't had much support yet, but it's my dream to do that. So we started, this research that we started doing was, we realized that a lot of people were sharing a lot of information in their reviews, and it wasn't irrelevant information. So people were sharing things like, oh, last year I got divorced, and then I fell into a depression, and I started taking this supplement, and it's like really helped me, and I started hiking, and there's like this very long story. So at the beginning, I was interested in storytelling that people were doing and what were the motivations for that. But then we decided, why don't we just try to understand what are the kinds of self-descriptions that people are voluntarily providing in their reviews? Because if somebody chooses to disclose something that is personal, it's usually because it contributes to gaining others to trust their opinion, you know? Like, you should trust me. I don't know, I have this illness and it's really helped, or I live in this place and this jacket is really good for the weather. And that is very useful. I think many of us, when we shop, we do research. And we will go to like expert review sites that will have done the testing of the products, like Wirecutter, or we will take time and read reviews to see how it goes. This paper was called Characterizing and Identifying Socially Shared Self-Descriptions in Product Reviews. And it was a collaboration with our intern from the University of California, San Diego. And one thing that self-disclosure or like self-discourse or self-descriptions in review does is that it captures additional signals from customers. It allows us to understand what is the identity groups that the customer belongs to. So we can identify communities of people. So there can be communities of like new parents, communities of serious runners, communities of parents of children with special needs. If I'm part of that community, I am very likely to be interested on things that other people in that community value. So there is also this social knowledge sharing in reviews. It's just not in a website that provides that kind of interactions. And that's kind of what I'm looking into. So self-description is making yourself known to others, basically. This study that we did it with public data, with a public review data set from Amazon that was, and that's kind of the distribution in the top 20 product sites. We created a manual taxonomy, so that's the part of the deep dive. We take a really good look at the data and we try to see what are the kinds of self-descriptions that people are doing. And we came up with this taxonomy that we later validated using crowdsourcing. So people that think, things that people disclose are related to their age. So there's an example of a review that explains the age and why that product might not help or just help appearance. So in clothing, apparel, a lot of people will explain their appearance because they hope that other people that look like them or have a similar body shape can benefit from that explanation when they're shopping. There is also ethnicity, race, location, medical, occupation, hobbies, relationship status, religion, like all sorts of things that we found very interesting, and we didn't really expect them in reviews. And why does it matter? Like, I think I skipped this in this example, but for example, one thing here, somebody says for this like hair dye, they say, I have thick, mid-back length South Asian hair. And they used a box of this, and it didn't turn out well. Okay, so it ended up being like the top brown, and it doesn't like look well for that. And I think many people that are like dark skinned like me and move to a country where people have very light skin and you buy a hair product, it usually doesn't give you the same color that it will give somebody with blonde hair. So those kind of things we care about, and we care about kind of having a way to tell customers, hey, this might not be fit for you. So we found the taxonomy, and we find that it spreads differently. So for example, for beauty, there is a lot of disclosure in terms of appearance, mostly, and ethnicity. So in healthcare, there is also a lot of disclosure about what are the medical conditions that take you to buy that kind of thing. So what we wanted to do was to see, like, can we classify this? Because Amazon has, like, billions of reviews. So how can we understand better what customers are doing? We need to classify this and do it automatically. So we created a classifier and we divided the task into 2 tasks. One was if the review had a self description or not. That was initially, but then we realized like 90% of self-descriptions was describing the kind of relationship. I bought this for my husband, or I bought this for my wife. So we added that into the first classifier because that was not very useful for us. And then we had a second classifier that would be multi-label and would separate age, appearance, education, all of those classes for us. And then we applied this to a whole data set of 1 year of data, taking the top 1,000 queries submitted to reviews, sorry. So, and we also studied whether this had we also studied whether self-disclosure was saying if it would make the review more helpful for others. So we did a regression analysis and discovered that they were positively correlated in that sense. So I have like maybe 2 minutes or 5. I'll just mention another different kind of work. So the other one was social signals from reviews. And this one has to do with searches, what people search for in Amazon. This work was published, it's being presented right this week at Wisdom, and which is a web data mining conference. And it's a shopping agent for addressing subjective product needs. I'm just going to go like quickly through what subjective product needs are, but a kind of search that is very difficult for us at Amazon is things when somebody says, I want a stylish bag, or I want a cute dress for going out, or I want a gift for my husband who is very much into meditation, like things where you probably would benefit from somebody else's opinions. Like I would like to know what other people find fashionable. So it's more a subjective thing. It's not something that we can directly ask the seller to tell us what's fashionable. All the sellers are going to say our product is super fashionable. So we actually want to leverage more what customers are saying for subjective needs. So we went through the process of identifying what were like subjective needs. Here are some examples. So sturdy table for crafts, cool gifts for boyfriends, things like that. And basically the whole goal is just to improve your experience and frustration level when you're doing this, and the amount of research you have to go and do outside of Amazon. So we went through several products, and we created a taxonomy again to understand what were the subjective needs that we were finding. And there was like, one is when they have a subjective property. It's saying like, I want a colorful dress, or I want a large lunchbox. The other one were related to events. I'm shopping for Easter, or pregnancy clothes, or Christmas. Or the other one is an activity. Like I need running shoes, and I will probably need recommendations from like the top runners. I would like to learn from them what are the best running shoes, things like that. So, and we studied the prevalence of those. And usually subjective property was up there, like with 21% of that. And we created, again, an evaluation data set. We converged towards making sure the taxonomy was adequate for that. And we did this thing that we had been doing, where we used LLM as this simple classifier for this unitary task, where we describe the task that we want, which is like, can you say if somebody's talking about a subjective thing that they're looking in the product, and that is subjective property, or if somebody's shopping for an event, and all of that. And we were able to achieve like pretty good results just with this like 0 to 1 shot learning for this task. So something that would have taken us a really long time to have all the annotated data, to have all the agreement between the annotators to identify this, we could just do in a couple of weeks. The model we were using here was Claude 3, KHIPU, which I found worked really well, and I'm expecting that if we move to like 3.7, it will work a lot better. And that's kind of the distribution where you can find subjective property. So you can find it like more in apparel, and this can have like design implications into how we want to present our products and everything. And we created a shopping agent based on this. It's just a prototype that our intern created, and works really well. And the only thing it focuses on is on what are the subjective needs that people have, and looks for the best products for that based on reviews. So what people mention in review that matches the subjective need is what we will surface. So it would be something like that. There are the references to the papers if you'd like to know more details. Just to wrap up the talk, I would say some of the takeaways for me is that for any problem I've worked with, understanding the data is really important. And I'm like, it sounds really obvious, but when you work with lots of teams in industry and in academia and everything, many people don't look at the data. And I found that as far away as you're from the data science side and more close to only the machine learning side, it's like data doesn't matter. We just put it through this grinder, and it's going to produce the right result. And I think data is so important, because from here we were able also to identify biases and things that are happening that we do not want to surface. And it allows us to ask the right questions, and also to break down to the right task. Like, I don't want the LLM to do everything because I don't trust it. I just want to do the simple task that maybe I could have asked anyone, human, with a brief explanation to do that for me. And that will work really well. And it will save me like weeks of annotating data. So at least for me, that's what I'm doing right now. If I move later to work with images or other things, I will learn new things, and it will be a completely different problem space. But for text and subjective judgments of things, this works really well. Some key differences from academia, like from moving, I would say it's just the fast pace. And I think lots of you might have that experience, like that they're maybe a PhD and then move to academia, to industry. It's like you're thinking about a problem, and then you should do a prototype for that, and that prototype ends up being what is being used by everybody afterwards, because it was good enough. And it works. And you probably don't have time to go back and make the best solution for it. So I think that's why I emphasize so much evaluation. So it might not be the best solution, but if you're able to identify to which degree it fails or it works well, I think it's a good solution enough. The nice thing is to have real-world impact, in a sense that it just, I don't know, Amazon touches so many consumers that I think if I can make their shopping experience better so they don't have to waste time looking at things that they don't need. I don't know if that's the goal for everybody, but that's my goal. And find exactly that gem that they were looking for that would make me happy. And I get the opportunity to learn a bunch of stuff, and which was very refreshing. about some time and doing the hands-on work. So yeah, that's my presentation. Sorry it took me so long.
Thank you, Barbara. We are get out of time, so we have time only for one question, please. So if you are interested, please.
I can take questions offline as well.
Yeah,
I'll be around.
On the coffee break, maybe.
Hi, thank you for the presentation. I have it's one question, but it has like 3 parts. Okay. First, why do you think that people like to give out their self-descriptions, like their personal info? The second part is, what do you think is the limit of the information that the companies get from us? Like, I don't know, the trajectory of your mouse. And what is your view about restrictions to the access of APIs of, I don't know, Instagram, Facebook, and the dangers of it?
Yeah, so this data we work with was public. It was published by another researcher that did a crawl of Amazon data, and we wanted the study to be reproducible. That's why we did it with that data. It doesn't have the names of the users that posted it, so it's almost impossible, I would say, to kind of join messages from one person. In the work we have, when we have talked about ethical implications in the papers that we publish, we mentioned that we only look at aggregated level and mostly at the product level. So we say, this product is enhanced by these features that we extract from reviews, that it's like easy to carry, it's stylish, it's good for people that have diabetes, things like that, but it's not tied back to the actual user. And that's the way I think it should be used. I don't work in personalization. I don't know how that's done. I know it's like highly confidential information, and it's treated that way. I think I forgot one of the parts of your question.
Yes, I think it's more like psychological, but why do you think that people likes to give out their information online, like for no apparently like return?
Yeah, I think we did it. This study has another part that I didn't mention because it was such an overload of things I wanted to talk about, but it is on the paper. We studied like different themes of why people would share. And there is one like when you share about your profession or your background, you say like, I'm a teacher, or I don't know, I'm a computer scientist or something. And you're trying to establish kind of authority and expertise so others trust you. And things like that. Those are the kind of themes that we studied about what could be the motivations behind that. But it does make the messages more successful. People find them more useful if they know something more personal about you. Maybe it makes them think you're not a bot. I don't know.
So do you think that, so when I enter to Amazon and I make a review from a product, do you think the most of the people are doing it like for thinking about the others, like for helping the others?
I think people honestly think about helping others because many times they have had such there's like 2 sides. This is my personal opinion. Like one is, I will not let other people buy your product if it's been so bad to me. Like I don't want it to succeed. And the other one is, I want to save others from like my pain. That's kind of what I've seen.
Thank you very much.
Okay. Thank you, Barbara. It's time for our last sponsor, and while he's preparing, and I need to pass an advice. We need that people that didn't ask for the reimbursement envelope. It's the last time at 6 p.m., please. Okay, it's time for our last talk, and I'm honored to introduce Nando de Freitas from Microsoft. Nando was born in Zimbabwe, and after a really unbelievable growth journey, he was joined to DeepMind as a full scientist in 2017. And since September of the last year, he is the Vice President of Artificial Intelligence at Microsoft.AI. From the other KHIPUs, I know the desires of Nando to visit Chile. I'm very glad that you are here. Welcome.
Muchas gracias. I might need some help here. Any extra? Start mirroring? Muchas gracias, Chile, por recibirnos también en esta universidad bella, y ha sido un evento increíble hasta ahora, y bueno, y me imagino que continuará siendo así. Y gracias a todos por venir, a toda la gente de América Latina. Muito obrigado aos brasileiros por vir aqui também. Estou feliz de estar aqui com todos vocês. The organization has been amazing. This event has been so smooth. Thanks so much for the organizers for having done this and for having given me the opportunity to be here. So I'm here representing Microsoft.AI. I only have one slide, so we're going to go for the photo after, so make sure you're in time for the photo. We're a very new team. And we're so new that we don't have slides. We have one slide. This is all you get. I will parse these two statements, which are basically the two defining statements for us. We are about superintelligence, first of all. We're about inventing machines that are able to do things that humans can't do as well as those machines. Whether it's dealing with patients in a pipeline, doing it better than, we're not just talking about multiplying faster, but we're talking about doing significantly important things that we're starting to see our machines being able to do. Things like theorem proving. These days, the proofs for my papers are just like one of the GPT models to fill in most of the lines. And the same is true with code and so on. So in many ways, the machines are becoming superhuman. And the big question is, how do we use that to augment people so that people are capable to achieve much more and actually do meaningful things? And that's the second part of our statement, which is about shipping, it's about product, and it's about putting the user first and meeting the needs of the user. I think the best way to do AI is to make sure that we directly interact with everyone and we ask the people to define in which ways the technology will enhance their lives. So that's Microsoft.AI in a nutshell, with a new team, about 70 people or so. It's a lot of people very excited about the future. And hopefully we'll continue being here, and I really look forward to us continuing to sponsoring events like KHIPU, and hopefully having an even bigger presence and more slides next time. I don't know if anyone has a question that you're dying to ask me. No? Oh, okay.
Hi, thank you so much, Nando, for being here. So my question is, how do you see the landscape in research in Latin America regarding the big companies, if they are going to invest and have offices here for doing research?
That's a good question. So there's already a few good companies here. Mercado Libre, Globant, tal vez hay unas cuantas más. So it would be nice for them to be here at KHIPU and to sponsor. It'd also be good for more of the big companies, including the one in the previous talk, to have more of a presence here funding this event and participating, because that company got their cloud EC2 developed in Africa, and they benefited a lot from the South, so they might as well just pay back now, because the cloud has kind of been a good business for them and for others. So I think I'm just being blunt and honest. It's impossible for the world to develop unless the South is part of it. That's a responsible path forward. And so all these corporations should be investing in Latin America, in Africa, everywhere in the world, if they really are to stand by their mottos of making the world a better place, or whatever their latest motto is.
Thank you very much, Nando. It was a very short talk. Now we have some announcements about a photograph and a queer that also Enzo is going to share with us.
Sí, pero no lo voy a mostrar. Okay. Okay, so just a couple of announcements here. So you should have received in the via WhatsApp a form where we are asking you to provide some feedback for us. Sorry. Oops. Just trying to. Okay, here. So if you didn't receive it, you can use the QR code to provide feedback. Basically, we are looking for what you liked, what you didn't like. We know you didn't like lunch. Okay, that we know, okay? So that is okay, it's not necessary to put it there. But ideas on how to improve or what you loved about it, everything is gonna be well received and checked by the steering and the organizing committee. I'm leaving it there for a couple of seconds so that you can take a picture, and otherwise it's in the WhatsApp community. Now, we will be taking a group photo now, so prepare your faces. We will be going out there, and the photographer is gonna organize us there. After that, there will be the coffee break, and then at 6, we are coming back because we have 2 amazing panels. One on the relationship between industry and academia, and another one on startups in Latin America, okay? So if you, you have to be here because the speakers are amazing. So now let's go to take the picture and then enjoy the coffee break, okay? ¿Cómo? Guys, one more comment. Okay, for tomorrow, anyways, we will repeat that, but now, just since you are here, you will have to bring headphones for those that do not speak Spanish or Portuguese, or English. Okay, Maine, you can do that.
Okay, I'm not going to be translating tomorrow, so some talks are going to be in Spanish and some talks are going to be in English. So if you don't understand Spanish or English, please bring your headphones because it's going to be live translation tomorrow. In your phones. That will be, so phones with battery charged and headphones that work with your phones, in case you didn't understand.
1, 2, 3, probando. Sí, sí. 1, 2, 1, 2.
Hi, everyone. Welcome to the last session of KHIPU main event. We have two absolutely outstanding panels. The first one on the collaborations between academia and industry. The panel will be moderated by Professor Guillermo Sapiro. He is a professor at Princeton University and what is it, like something engineer at Apple?
That's okay.
He's like a truly outstanding engineer at Apple. That's the translation of it. And I will let him do the introductions. Please welcome Guillermo.
Thank you. Thank you very much. Before we start, so this is my third KHIPU, and if they keep inviting me, I will keep coming. But I'm going to just thank the organizers for making one of the most fantastic meetings that we frequent every year. And I think the mission of having students that are fully covered for their trip to a conference is a great accomplishment of this conference. And to that, I'm going to use the fact that there are three of the sponsors sitting right here to thank the sponsors as well that have made this happen. When I mentioned that to Apple, I say, what better way to use your money than to pay students to go to a conference? And I'm sure it's the same argument that you use at Google and Microsoft. And it's a very easy sell. But that goes to the credit of the organizers that made the sell so easy. So thank you very much. And thank for the students for being here. Today, I hope everybody did your homework so you know everybody here, so I don't have to do long introductions. But I'm going to start. This is about the collaboration between academia and industry. It's not about the competition. It's not about that. And I want to try to focus on the research. Everybody knows that academia has a major role, which is to educate. But let's just try to focus on the research. I'm going to start with Laura, that is 100% in academia, or more or less, closer to 100%, or a bit closer than most of us. And I want to ask you, if in your experience from the academic side, what is something that you see that industry is doing really well in supporting this collaboration with academia?
Okay.
And
I'm taking one of these. Okay, thank you. I also want to thank the organizers. I know this is an effort that takes years and years, and that they don't only do this for the days that we are here and the week before, but they have been keeping this going for many years, and it takes a lot of thinking and a lot of taking many things into consideration and getting to be understood with people who think very differently, and they still make this happen, and they still create this atmosphere where very different people can speak from very different points of view and hopefully get to understand each other. I think this is something very nice that KHIPU brings, that people from different areas, genuinely from different areas, bring criticism, that this criticism can be spoken and heard, and that we all go home with food for thought and hopefully for action. So I thank you for creating this place where we can speak our minds and be naive and still hope that we will enrich each other. So, and about this, what does industry bring to academia? I cannot speak for big corporations, but I can speak about the industry that I know, that are the industries that cater to local needs, and not only small but also bigger companies. And I think what they bring is grounded problems, no? That they, this is something that has been going on for the whole KHIPU. It's not me saying this, many people have said this. Remember yesterday someone said A/B testing needs to be done. Yes, we in academia don't do A/B testing for many reasons. First, we don't have the resources or the setting to carry out A/B testing. So what do? We make as if it didn't exist. Yeah, and this has been going on for very long. Now that we are in this evaluation crisis, we are working as if we couldn't evaluate things properly, but only with error-based metrics. And industry brings us back to things that really matter, like, no, I need to evaluate whether this language model is actually producing bullshit, because I don't really mind if it scores 100 in this benchmark. I need to make sure that this language model doesn't recommend aspirin for any headache, for example, because I don't want language models making medical recommendations. So I think this is something really, really valuable, and I think we, and possibly also bigger corpus, need to put into value this and not say that the only thing that matters is that you have bigger or faster language models, but also these things that are very valuable for the actual products, these, what did they call it? Product metrics, like A/B testing, evaluations about the things that really matter, baselines.
Thank you. So a big lesson is real problems and grounded in reality. Yeah, you can pass it to Nando because he's going to be the next victim of my questions. For those that don't know, Nando had a life in academia at UBC a while back, a great university if you want to visit, Oxford, and then slowly moved to industry. So I'm going to put you on the spot and see, could you give an example of something that you did while in academia that you think it would have been very hard to do in industry, or vice versa? I will prefer the first one. The second is always computer. But something that you say, this is not something that industry is built to do research on, or so I'm very proud that I had the time in academia to do it, because it would have been very hard to do in industry. Am I putting you on the spot? You can take the vice versa, which is a bit easier. But, and by the way, I'm asking questions to each individual, and the others I expect you can answer. So, Jeff, you can say, hey, this is work I see in academia I would have never been able to support in my research organization. So everybody's welcome to ask to answer these questions. I want this to be as dialogue as possible. Nando is hating me now. Yeah. Nando asked me not to share the questions with him.
I never hate.
So,
it's funny because like my mind was sort of going back to those days, and I remember not just doing research, but teaching. Teaching was like a big part of it. Hanging out with the students, nurturing. Also, you know, the endless committees, as you know. Fortunately, in Canada, it was easy to get grants, and in fact, it was a pleasure because there were people like Jeff Hinton who created the CIFAR deep learning network, and through that, you could go and talk to. It was fun to go and talk to people in very diverse fields and so on. At the university, you also have all these like random people knocking on your door, you know, from astrophysics and God knows, coming with problems that they think this is a problem that machine learning can solve. So that bit was fun. But I really think academia is not just about the research, it's also about everything that comes with it. And the nature of the research. It's just wonderful to work with students. If you love that, I think academia is the right place. It's hard to get that in industry as much, or you're kind of working on other things.
Great. Anybody wants to add, or I can continue? Or By the way, I'm one of the beauties of academia. I say, it's one of the easiest ways not to get old, because every year you get another set of 18 years old people.
I know.
Asking
Did you see that? I was asking people, those people up there, they look like
every year
babies.
You confront another 150 18 years old that asks you 150 new questions that you never heard before. It's just shocking. And they're getting smarter and smarter, sorry, but yeah, so.
I have just a suggestion. One way that you could work in industry with students is by funding grant PhD scholarships.
We do.
Exactly.
Most of us
that's very
do
nice.
That. Yeah.
Yes, I agree, but it's not the same.
It's not
So, and most industry and I think entrepreneurs and so on actually devote a lot of money to scholarships and so on, a lot more than we saw before. When my startup was acquired, Phil Blunsom and Andrew Zisserman, myself, we donated $6 million to the University of Oxford, and those became the DeepMind scholarships, which allowed for international students to go to Oxford. And that was payback time for Phil and me, because what got me to study was that I got one of those scholarships many years ago, about 30 years ago. So yeah, I agree we can work with students, but I also think what I was referring to, being a professor is a very different deal to being a researcher in industry. It feels very different, having done both.
Thank you. Nayad, you have a very particular position. For those that are not familiar, INRIA is an outstanding research institution in France that somehow picked the best locations in France to put their branches. Some of the best computer science, robotics, machine learning work comes out of INRIA. You direct what I think is the first INRIA outside of France, and still the first and the last so far. And INRIA has, and this was asked a lot, it's more a government organization funded by the government with a lot of relations with industry, but it's a research lab supported by the government. So what can you tell us about the role that those institutions or nonprofits in general have in this relationship that we're trying to make between academia and industry? You are kind of in between both. So any insights you can give us?
Yeah, thank you so much, and I take also the chance to thank the organizers and the panelists and you for moderators and the audience. We have a full house, almost full house here at this time. So as you say, INRIA is special. It's a special place because we, as a public research institution, but we have a mission, a mandate, not only to do in research, but also to walk the extra mile to go in depth. And to make those research results available to society, okay? By partnering with industry, by creating startups, or by consolidating the results in open source software, just to mention a few. But as a nonprofit, and more than nonprofit, as a research public institution, we carry, I would say, the burden between what is the theory and what is the application and what is in between of this tissue, in between the academia and industry, and we bring on board, you already said, the best minds. And what differentiates us is that we bring on board to INRIA the best minds and give them the support, okay? The long-standing support and the right support to the result, to have a tangible impact. And this is very, very unique because being a public, again, institution and not driven by profit, but also not driven by losses, I would say that, right? Our mission many times is to assume the risk of carrying out some of the research that part of that other players of the ecosystem cannot do, and cannot do for many reasons, right? So, and this is why, for example, in the 70s, we worked with computer networks and And we created the foundations of the IP protocol, and build the basis of the database system with results like PostgreSQL or Snowflake that come from INRIA, for example. In the 90s, we set up the foundation also of the web, together with XML and CSS, and coming also from INRIA researchers. And now it's not a surprise that we also, in the origins of the AI revolution, we see scikit-learn. What I want to say is that our role is to go where other players don't want to go, okay, or cannot go, but we know that we should go, because we need to train people, we need to educate, but also we need to support the scientists to go this extra mile in the best way to bring these results to society. This is what we do as a nonprofit.
Thank you very much. I just want to mention, for those that are less familiar with INRIA, but you're probably familiar with Francis Bach's work. He's from INRIA. Michael Jordan is currently a long-term visitor of INRIA. So a lot of the names that educate you are part of INRIA. They also have often affiliations with universities, but INRIA is their main home. Jeff, the last question for the first round goes to you. So you've been leading one of the most prolific organizations in publishing paper and doing open research, open code. And in many senses, it used to be Bell Labs, and then industrial research disappeared, and then Microsoft, Google brought it back and make it extremely successful. Mm-hmm. What do you think is what drives you, what is the economic value for a company to do open research, not to do research, but to do open research? You belong to a company, so it has to have an economic reason for doing. Could you educate us? What's your vision on the economic reason for doing that?
Sure. First, though, I'd like to thank the organizers. It's great to be back at KHIPU. I was at the 2019 event, and that was fantastic, and this is also fantastic. I've lost my voice, so that's not going to be good for my talk tomorrow, but we'll see what happens. Yeah, I think the reason you want to publish is because that is a way to attract the best research scientists and to interact with the entire research community and to publish ideas that advance the field. But then because you're doing that, other people will build on those ideas. And then you get this nice synergistic benefit of we publish something, maybe academia builds on it, maybe other research, industrial researchers build on it. Hopefully they publish, maybe they don't. But the reason to do it is really that a lot of the times our advances are things that we want to take advantage of in our products, but it's actually fine if we publish the underlying idea, sometimes right away, sometimes with some delay after we've incorporated it in our product line already. Like we have a very good computational photography research group, for example. So often the way that works is every new Pixel phone has some new interesting feature that is based on the computational photography research group's research for the last year or so, and we deploy that into the Pixel phones or into Android, and then sometime after that we publish a really great paper in SIGGRAPH or other kinds of places like that. And I think that's not a bad model. It does enable the broader community to learn about the research, to build on top of it. It perhaps sacrifices some economic value versus if we kept it secret. On the other hand, it gives nice attributional credit to who came up with some of these ideas, both individually and also organizationally. And there's good reasons for doing that. And I think similarly with open sourcing, we often open source things that we think are important, things like TensorFlow or JAX or our recent open model release from yesterday. Gemma 3 is a incredibly capable model. It's better than the DeepSeek version 3 model, but it runs on 1 GPU instead of 30 or something. So we think the community will benefit from those sorts of things, and being open about it is the way to go.
Thanks a lot for educating us. I just want to say I'm happy you mentioned computational photography. One of the team members of that team is Mauricio Del Bracio, that was one of the organizers. And if you haven't seen, he's probably one of the few people of KHIPU that had their product highlighted during the Super Bowl commercials, which is the highest. And I called
during a panel.
I called Mauricio right away. I say, you just show up on the Super Bowl and say, and my daughter wanted to play exactly at that moment, so I miss it. But it's well recorded, and thanks for that's an outstanding group, and there are some members here from that group as well. I wanna, and everybody's welcome to answer. We have Google, we have Microsoft, Apple indirectly, INRIA, those are big institutions. But you mentioned, you came to Google DeepMind from a startup, and there is some startup, and you rightfully so mentioned that we all wish there were more startups here. But it's different, the relationship between large institutions that we can afford taking risks in our research and fund fellowships. Anybody wants to give a comment about what you think or what should be the value or the position of startups working with academia? They need to be way more focused than large companies because they're successful. So anybody that wants to give a comment on the value and what startups can benefit and how academia can benefit from startups. I can ask volunteers, but yeah.
Sorry. Yeah, I always want to talk, sorry. I am gonna repeat myself. I think startups are closer to the problems. Probably they have a more one-on-one relation with their clients or with some of the clients, and and they get to know clients more individually because they are smaller. They get to know the small things, the detail, and the devil is in the details, as we have been seeing with these large language models, which perform very well in average, but then all that is not average is not so good, and we have to devote a lot of effort for all the not edge cases, but usual cases for everyday people. We are not in the average. We are not an average. Individual people, cultures are not averages, are particular cases that have particular needs, and I think startups are very well suited to capture that and have the flexibility and the speed to adapt to that and to cater to that. And I want to take something that you just said, Jeff. It's true that big players put ideas there that the rest of the ecosystem builds upon. And it's great. I mean, I am a linguist. I was very happy for transformers and how they capture things that we had been thinking about for many years, and I'm super happy. But I have also seen how that imposes on startups that have to, or smaller firms or firms that are catering to very particular needs, and that maybe should devote a big part of their resources to model these particular needs, but then somehow have, there is an expectation everywhere in the clients, in the conferences, to devote resources to these ideas, to language models, to big things, and not to things that have a bigger impact on their actual products. And just short. Sorry, I know I talk. And I have been thinking what we can do about that. I mean, not me particularly, but the prestige players in that. And I was thinking maybe dignifying again baselines. We are scientists. Baselines are a fundamental part of our work. In many scenarios, a baseline, and especially in agents, many of the agents work well within a baseline. But many people are forgetting they could first try a logistic regression with your old embeddings, because it has no prestige anymore, but it should have the prestige of methodology, of sound methodology. I would like for our community to enable other players to get to play by allowing them to, by telling them what they do is worthy, because sometimes it's very good to know that a logistic regression is below, but not so far below something much more expensive, and even negative results as well. No? So, yeah, sorry.
Thank you. I'm going to ask a question to all of us, and I'm going to give the answer to my own question, because I also want to open to the audience, and we have a trick of how to ask questions from the audience. But let's say that we go to sleep today, which we all need, and we wake up in 10 years. And what will you love for academia and industry to have solved with machine learning, that you wake up and say, I'm so happy to read that this is very well solved or significantly advanced? For me, is access to healthcare, which is non-existent for most of the people that are not privileged like us. Nayad, what do you think should be, in 10 years, I wish machine learning have solved or make significant?
Climate change.
Great. Yeah?
Can I expand that? Or?
Yes, no, please. No,
Or
absolutely, no, yes. Mine was obvious. I don't have to expand, but yours.
This is quite obvious also.
Yeah.
Because, I mean, in a way, I mean, it's a significant trade-off between using technology so much and the burden and the impact that the main technology has in climate change. But all the way around, I mean, it's very important, to use AI and all these technologies to understand, right? What is climate change? What is the relationship with, the biodiversity, the ocean, so on. I mean, this is a key area that I want to push. And I think in that respect, I see also that the relationship between the public institutions, the academia, but also the industry has a very important and key role.
Thank you.
If you don't mind, I'll go next. This is a great question. I think I've actually been a co-author on a paper with 8 other authors called Shaping AI to improve the lives of billions of people recently. And it's a bit of a position paper about what we as a community should be thinking about, and also not to take the position that AI will develop in a vacuum. We have actually agency in terms of AI researchers, practitioners, policymakers, and the general public about what problems we want to see tackled and what sort of important societal issues can actually be advanced by AI. And I'll mention just a few from the paper, but there's a bunch there. One of the things we did is we laid out 18 different sort of challenge and milestone things we think are really important for the community to tackle. One of them was like a universal health assistant, to your point. I think there's tremendous benefit if we could figure out how to use all past medical decisions to inform all future medical decisions. That would just be amazing for humanity. And we have some of the tools. I think federated learning would be one key piece. I think the ability to have multimodal models that take into account data that is available to the healthcare systems today, but also data that is maybe outside what the healthcare system normally looks at. I think an individualized educational tutor would be amazing. Like, could we get something that teaches people anything they want in any learning style that is most appropriate for that person, knows what you know, knows what you don't know. And one of the most important, maybe meta things that I think we could do is really build something that enables science to progress faster. So something that is a automatic hypothesis generator and can test those hypotheses in automated ways and can propose new hypotheses, maybe in collaboration with a human scientist in the loop to help steer it, or maybe in some areas where it just automatically makes new discoveries. If we could do 100 years of science in 10 years, that would be amazing, because if you think back 100 years, all the things that have come before, if we could accelerate that, it would be amazing for the world. And I think there's a potential of doing that.
You have your homework for tomorrow. The admittance to tomorrow's session will be a question from that paper. And
I like all those. Let me add a couple more that so one that I would add is energy. I think one of the root causes of problems in the world is access to energy. Access to energy would allow us to have better technologies to, preserve our environment. Access to energy will lead to, I think, more resources for everyone, and it will improve healthcare. It will just help us all. And I'm talking things like Google DeepMind's been doing amazing work on trying to do research on fusion, and if I were to wake up and that's been solved, I'd be like, wow, amazing. I know quantum computation, all that will be amazing too, but for me, something that puts people first, puts humans first, that's what I would love to see when I wake up in 10 years. And with that, also safety, alignment. We don't yet know how to develop AI safely. And so I would love to see some progress along those lines. And I would like to see we working with AIs, in positive ways. And then in the discovery, I think the same thing that Jeff said, but maybe I would love to see that one discovery that no one knows right now, and that the AI made it, because the AI will be way more clever than us at making new discoveries. Something that would wow me. That would be cool.
thank you. We're going to get the last and start thinking questions, because you might be randomly selected to ask one. But first of all, the 10 years, I made a mistake, will be 100 years of progress. If you're right, we will wake up in 10 years and we will see 100 years of progress, potentially. It would be nice. So last but not least.
I think I'm very enthusiastic about what you said about human first. I would love that machine learning could help us to develop solutions that are not one size fits all, but that can fit to everyone in their singularity and safely, with respecting what one is, respecting your culture, your idiosyncrasies. We are getting better at that as people, I think. I think we are now able to respect others more. I would like technology to do that better as well, and I think it has that potential. And I would love that without it being vigilant, of course, with security, with safety. But that would be so cool.
Thank you so much. We only have a few minutes for questions. Is there anybody in the audience that has a birthday today? Anybody that had a birthday this week that we didn't celebrate? I saw 2 hands, so you have priority to ask questions. If you want, can we go to you first? Those are, and we might only get to those 2, but I think, first of all, happy birthday to both of you.
Thank you. This is the second time my birthday is being celebrated in KHIPU, so. Okay, well, I was listening to all of you. I was thinking that it could be nice if AI can also be able to help us to diminish or punish, in a way, fake news. So maybe that will also help us to understand much better each other, because that will improve communication between us. Do you think that that will be something that AI can do in the future?
This is for me? Yeah, okay. I can start. This is actually one of the topics we addressed in our paper. because misinformation is actually one of the, I think, clear downsides of AI models is they can very quickly generate very personalized misinformation or misinformation at mass scale. I think there are actually some signs that it can be used in positive ways in sort of online social networks and discourse. There's actually 3 different interesting studies. So one showed that when you have someone who believes in conspiracy theories actually talk to a language model about that sort of conspiracy, they can actually end up with a nice pre and post scoring thing, believing less in the false conspiracies. There's also evidence that a language model can be a good kind of moderator of online discourse, where they sort of say, oh, it seems like you're expressing a point very in a negative tone. Perhaps you could use a more positive tone and encourage a better dialogue. And there's a third one that I can't remember at the moment. But I think these are kind of early signs that these sorts of models can actually sort of help us all as the world populace communicate better and be perhaps less polarized, which I think is something that we could all appreciate in the world right now, and have better dialogue, better ways of meeting your neighbor, your virtual neighbor. I think are ones that we should really focus on, and that's actually one of the sort of moonshotty things that we proposed in the paper, is how can we as a community build those tools that enable that sort of experience.
Thank you. We have a second person that had a birthday. If you didn't get to ask questions, because this is going to be the last one, don't blame me. It's your birthday. This was completely a random selection, so because there is almost equal probability to be born.
Don't feel pigeonholed.
Yeah. So the last question goes to the happy birthday second person.
I wanted to thank the panelists. It was a very inspiring conversation. It's part of the reason why I joined this field, and I imagine most of the people here too. When I'm talking to others outside of the field, I try to transmit this passion and optimism about what AI might bring, but I usually hear back concerns. Concerns about what will happen to jobs, and concerns like what the other question was about. What are your thoughts about that? I'm still super optimistic about what's going to happen, but how do you think we should tackle the problems?
I mean, I don't want to answer again, but we actually talked about that in the paper, so. The paper is called Shaping AI's Impact for Billions of People or something. What? There's a 30-page version and soon an 8-page version.
Oh, okay.
And there's also a 1-page Economist op-ed by Dave Patterson.
And I think it's a great question. I want to be respectful to the next panel.
Oh.
But no, to me. But this will be, there is an evening event for some, there is a day event tomorrow. I hope this only encourages you. I just want to say that first, it has been my honor, thanks for the committee to organizing this. All your moonshots, I can actually almost write a theorem why the partnership will be needed to accomplish. Industry cannot do it alone. Academia cannot do it alone. Nonprofits cannot do it alone. These are good ideas that we need to work on them together. If there is more than one, you can pick the one that you're most passionate. This is part of the beauty of this field. You can pick what you're passionate and just make maybe in 10 years, we wake up and we say, wow, this is a much better planet than it was 10 years ago when I went to sleep. Thank you. There's going to be 5 KHIPUs in the next 10 years, so we are going to do baby steps revolutions together. Thank you. Pablo, do we have a break or we just go to the next one? I don't. So don't leave. No break. Thank you. There is waters here.
Hello, does it work? Can you hear me? No, it's not working. Okay. Okay, yeah. Okay, so we have our last panel for today, which is going to be about startups. I think it's a really nice continuation from the discussion we were having before. And I'm going to introduce only the moderator, and then I think the moderator will introduce the rest of the speakers. It's the first time I think we are going to be discussing, well, we had a panel on startups at some point in previous KHIPU, one of the parallel sessions. But here we have invited startup founders and also people that relate in different ways with startups. And Nicolas is one of them. He's the co-founder and CTO of BrainLogic.AI, the creators of Sapia, an agent that solves real-world tasks for its 3 million users in Latin America. Before going crazy and dropping everything to startup, Nicolas was director of engineering at Etsy and leads teams at Google. He got his PhD at University of Illinois, specializing in computer vision. And he will be moderating this panel. So Nico, this is yours.
Thank you very much, and thanks to the organizers for this amazing event. I've tried to help a little bit in the past, but it's my first time here, and I'm super excited. So we'll try to do something slightly different here and have something that's more interactive. So I'm hoping that the audience will participate in this. Maybe we can start with that. I want everybody to answer this question by raising your hands. How many of you are super excited about an idea that you just can't stop thinking about, that you think might be something big? Okay, okay, keep them raised. How many of you are seriously considering dropping what you're doing to pursue that full time? Okay. Great. So for this, exactly for this reason, we put together this amazing panel, and I'm gonna quickly introduce them, and then we're gonna ask some questions, and I'm gonna introduce each of the panelists in more detail. But the idea is that we're gonna spend a lot of time answering questions from the audience, so hopefully we'll have enough time for that. So we have Agustin from Anyone.AI. We have Andrea from Viviana. We have Diego from Mistral, and we have Laura from Excel.AI. I think when we were preparing this panel, one of the questions that a lot of people wanted to ask is, what makes an idea great? What makes an idea good enough to start something up? And I think that your story with Yana is great. Maybe you can talk a little bit about that and also see if you can answer the question.
Thank you. So I believe the key is working on an idea that you're personally passionate about. And how do you know that you're passionate about something? I think the easiest way is just thinking about something that really pisses you off, something that hurts you on a very deep and personal level. Why? Because being a founder is one of the hardest things that you will ever do, not to be discouraging to the people who raise their hands, but it is one of the hardest things that you will ever do. And I do believe 95% of the success of a founder comes down to keep showing up. And if you're not passionate about what you're building, you will probably give up. In my case, I built Yana, which is an emotional AI companion. I built Yana because I struggled with depression for 14 years. And I desperately needed something that could help me survive my episodes. So I decided to build it. And it was originally only meant for myself. Then I realized there were more people in the world who could use something like the thing that I was building, so I decided to build a company. And it is a very long journey. I don't have enough time, unfortunately, to share all the things that have happened, but it really comes down to I had to start over again 3 different times with 3 different developers until I realized the most practical thing I could do was just do it myself. I built the prototype, validated the idea with few people, got my first angel investor, and hired a very small team, ended up launching the app when the quarantine was announced. And it started growing slowly by word of mouth. Today we have over 16 million downloads. We've dominated probably every country in Latin America. We're now expanding to North America and Europe. But like the truth is that when we hear stories like the ones that we're going to share here about our startups, we often forget that it is a journey filled with a lot of rejection. A lot of people is going to say that they don't believe in what you're building. People are like, nobody's gonna want to join your team. Nobody's gonna to use your product. Nobody wants to pay for your product at first. Nobody believes in you. And in those times, what you're gonna stick to is not the idea, is the problem. So you really need to be passionate about the thing that you're building. And if you do, you're gonna keep showing up, and those are the founders who win, I think.
Great answer. And I clearly suck at this. I forgot to introduce her. So here it is. Andrea is the CEO and founder of Viviana. Viviana comes from the acronym You're Not Alone. And her app is the most downloaded virtual emotional AI companion in Spanish with millions of users in Latin America. And Viviana has been expanding, as you mentioned, globally. So it works now in English, Portuguese, and French. And it's growing very strongly in North America and Europe. So thank you. And you mentioned this thing about the importance of perseverance, grit, and sticking to your ideas. And no matter what happens, keep showing up. And I love that. And I hope that we're not depressing you, but like startups have that, but also there are some of the most exciting stuff that you can be working on. And I think that's a good segue to Agustin. And I am going to introduce him. He's the co-founder and CEO of Anyone.AI, which is an educational technology company focused on training software developers to close the AI talent gap in Latin America. Before that, he co-founded and led to a successful exit, Deep Vision AI, a company specializing in applied computer vision, where they partner with companies like NVIDIA and Intel and work with many Fortune 500 customers. He holds a computer engineering degree from the University of Córdoba and was a researcher at INRIA in France before dropping out of his PhD to start his first company. Great to have you here. Edison used to say that genius is 1% inspiration and 99% perspiration. So you were working your PhD, you decided to drop out and start up a company. Tell us a little bit more about that.
Yeah, thank you, Nico. Great to be here. Thank you also to the organizers for having us. Yeah, so basically I was, I got my degree in Argentina. I'm from Córdoba. And right after I got I'm a computer engineer, I went to the south of France at INRIA. I was going to do a PhD like probably many of you are now. But that was 2013, which was a year where, the year after AlexNet came out. And, by looking at that, and I'm a very curious person, so I always had also the idea to try something in the industry. So by looking at what was out there, it was MetaMind, Clarify. Probably you remember about these companies, but there were nothing else. It was just a new technology with a lot of potential, and even in Latam, right? Like still very few startups. So it was to me a great opportunity. So yeah, I decided to transition out from my PhD, and we started a company in which we were initially trying to discover use cases. Like nobody knew what to do with that technology at the beginning, and yeah, very quickly we started building a team. We had to hire people from the university. There were no talent out there also building products for AI back in the time. And by going to places like this one here, we started connecting with companies like NVIDIA, Intel, AWS, Dell Technologies at the end, and we were majority majority of the work, we've been doing with them was optimizing, these models to run on the different platforms. But because of that, they were all the time bringing us customers. Long story short, we sold the company in 2020 to private equity, and yeah, that's basically the experience that I had from being a PhD student to founding a company and then selling it.
But it couldn't be that bad if you sold your company and then immediately started up another company.
There are two versions. One, I like to suffer, like Andrea said. Startups are hard, and no, really, what happens typically when you sell a company, in my case, it becomes really big very quickly. Like they put like 3 companies together. So everything I was enjoying doing back in the days at Division, I couldn't do anymore. So I was in a place where I wanted to continue to build stuff and apply AI and learn, and that was basically the foundation to run now this new company. And basically the transition was like I had a few ideas, but I think one thing we did well in the previous company was building that 30 people team, in which we have even one person who won ImageNet, who is from Latam, and people that we train to be good at deploying models, building products, and really that's what this new company is about. That is, we train software developers and sometimes people from the academia that wants to transition to the industry, to basically be ready for what companies are looking for. And really quickly, what we do is we have a highly intensive program in which we put squads of people to work on industry problems with the objective that they are ready for the industry, and then we help them connect to companies, get hired. And that's basically what this new company is about. And I think it's for me it's a great move forward in a way that this can impact a lot of people compared to what we were doing before. So and that's what startups is really about, making an impact, right?
Great. And I think we have another amazing story that is along those lines of getting out of your comfort zone and trying something different, and that's Diego. Diego de las Casas is an artificial intelligence engineer who joined the founding team at Mistral in August 2023. Before that, Diego was a research engineer at DeepMind for 6 years. He holds a master's degree in computer science and a bachelor's degree in psychology from the Universidade Federal de Minas Gerais, and was a researcher there. So you had a pretty good job, and you decided to, hey, I'm gonna leave this and I'm gonna join a new startup. Mistral is not any startup, but how do you go about making a decision like that?
I think it was definitely a hard decision, but it was also kind of a calculated risk. It was not like a crazy decision or something, because Mistral, like, it seemed to have lots of potential to me. But I think it was I felt the moment was right. Partly because I think that right now we have this big, very wide cone of possibilities for AI. It's basically, I don't think anything is set in stone right now. So it's nice to have the opportunity of building something from the ground up and see where it leads you and be part of this nascent industry. And obviously, you can do that in a big in big tech, but I thought it would be more interesting to be in a startup environment where I had more influence on all the decisions and everything. Also, it was a good personal moment for me in the sense that I think it's good, at least for me, it's important to when you're joining the job market, it's good to be where you're working with people that you admire, because then you learn a lot. But then at some point, you want to go and do something different, something new. So I thought this was the moment for me. So yeah, I think these two things, like the moment was right in these two aspects.
Great. And Last, we have Laura. Laura has an amazing story, and she's an AI researcher and entrepreneur, but also she's an investor. And she's dedicated to advancing AI and deep technology innovation in emerging markets. She, as founder of Axel Impact Ventures, she's advising and investing in startups that are driving transformative change in AI across Latin America and beyond. So you wear two hats. You are a founder, actually more than two hats, but founder and investor. So as the only investor here, I think another question that's very common, people that are starting up is, what is it that I need to look for in an investor? And what does an investor look for in a founder? I've heard that people equate the relationship between founders and investors as a marriage, both in the good and the bad sense. So how true is that?
Yes, thank you. And I want to say, first of all, thanks to all my other panelists as well for being here, and of course to the organizers of KHIPU for the invitation to join, and all of the audience for attending, especially the last talk of the day. I'm sure everyone is tired and appreciate the attention. So for those that are interested in starting a startup and want to seek venture capital investment, really you have to first ask yourself, is this the correct decision for you to go with this company? A lot of people don't understand the fact that becoming revenue positive, first and foremost, on your own is actually going to be way more valuable than ever seeking venture capital investment. We hear all the hype nowadays in the market about such and such a company raised, so many millions of dollars, especially AI companies right now that are raising a lot of money. But if you can actually make money yourself, you are going to withstand the market so much longer than the hundreds of AI startups that are going to fail and then will be worth nothing in the next 2 or 3 years, unfortunately. So that's first and foremost. Can you make money on your own before ever seeking venture capital? And part of the reason why this is also valuable is because VCs are looking for companies that they know are going to be profitable, especially when the market is tough. And so a lot of countries right now in Latin America and also in other parts of the world, including the US, are dealing with issues around hyperinflation, are dealing with issues around the stock market crashing. So in these times when money can be kind of lean or harder to come by, VCs want to invest in companies that are already making a profit. So they're gonna look to see that you actually do have a large share of the market, that you have user base, and that this user base is paying for your product. It's not like back in the old days where you could just gain a lot of users for free and all of a sudden you have a multi-million-dollar company. That's no longer the case anymore. So you have to take that into consideration. The other things they're going to look for when you're just starting out is obviously things like, what does your founding team look like? What type of experience do they have? Are these the right people to solve this problem? So just having experience in artificial intelligence is great if you're going to innovate and publish research, right? But having experience in AI doesn't mean you're necessarily going to be able to solve that problem. As was mentioned earlier, you have to be very passionate about the problem that you're solving, not just the technology you're using to solve the problem. So if you're an expert in artificial intelligence, machine learning, that is wonderful. That doesn't mean you're going to create a very successful company. And at the end of the day, VCs want to know that you're going to, of course, be profitable and make money, because they also have to be reliant and hold to their shareholders that are people that are invested in them. So you can think of venture capitalists just like a startup, like a small business. We're not talking about, of course, the Sequoias and the BlackRocks of the world that are major VC firms. Most VC firms are very, very small, and many nowadays are just emerging managers. And so just like you, they have to go out and seek funding from limited partners, from high net worth individuals, from corporations, from pension funds. And so they have to be held accountable to all of those people to return their money. And how do they return their money? Well, they return their money if the startups that they invest in also return money to them. So this is a very strong relationship, a very strong partnership, as was mentioned. So that relationship, that marriage, as it was described, is one that you also want to know that you're going into with a very open mind and a large understanding about who the VC fund is that you are partnering with and what their interests are. So when you're first looking for a venture capital fund that you're considering getting investment from, you want to make sure that their thesis aligns with your company. So for example, if you're starting an e-commerce company using AI, you wouldn't want to go to a venture capitalist that only invests in SaaS products or only invests in, deep tech companies, right? Because in that case, you're not going to align to their thesis. So it's going to be a waste of time both for you and for them if you approach them for an investment. Similarly, you want to make sure that that VC fund isn't just going to give you money, but they're going to add value to your company in other ways, right? They're not just there to be a large pocketbook. They're there to open up connections for you, to help you and advise you with things like potentially marketing, with making other connections to more investors later on for your larger rounds, to help you, for example, if you have a legal issue that you want to solve, maybe they have connections with the government, maybe they have connections, let's say, if you're solving a problem for medical applications, maybe they have connections in hospitals that they can help get you access to data or other partnerships there. So you want to look for a venture capitalist and a firm, essentially, that will also help you build your business for the long term and isn't just going to be a short-term solution to giving you money. I hope that was a good explanation.
Really good answer. I have lots of follow-ups, but we have about 10 minutes left, and I do want to make this a two-way. There were lots of people at the beginning that raised your hands. I'm sure you have questions, so I would rather let you ask those questions and see if this amazing panel can answer those.
Thank you. So I'm interested on your thought process when you have the idea. So you found a problem and you have the idea for a solution. How is the process of turning that idea into a product? So how do we find a business model inside the mission that we are pursuing? Thank you.
Anyone want to take this first? Yeah? Oh, me? Yeah. Okay, so having been an operator as well as an investor, it's really important to think about who your customers are, right? So the problem that you're trying to solve has people who are affected by that problem. So those can be end user customers, like everyday people. They could be a business, for example, might be the problem that you're solving for. As I mentioned earlier, it could be a hospital, right? So depending on who that audience is, that's going to mold your business model in a lot of ways. So there's obviously business to business solutions, and there's business to consumer solutions, and there's also hybrid models potentially that you can develop for. And you have to think about who your competitors are as well within that space. So what are other companies similar to yours doing to solve that problem, and what are they charging in order to provide a service or provide a platform as part of their company? So that's one way that you can do your market research to better understand how to build your business model. And then you can obviously do some A/B testing as well, right? You can start talking to potential customers and say, what would you be willing to pay for this product or this service? That's another way to better understand, okay, does this actually have any potential value that can be added to the market, or is this something that maybe no one will pay for, right? And as was mentioned earlier, you might hear a lot that no one will pay for your product, especially when it's a very nascent idea, when it's something that you don't really know what you're doing yet. But if it's a real problem that needs to be solved, oftentimes you will find someone that's willing to pay for it and will say, I would give someone $1 million if they could solve that problem, right? And that's when you know you really have a problem that may be worth solving from a financial perspective. Does anyone else want to take this?
Just really quickly, I would advise like go talk to customers and learn, and go talk to customers, learn. It's like a machine learning problem. And you know, really the important thing is solving something that your customer is looking for. Actually, going back to what I did when I told my story about INRIA, that's an efficient way to do it, because it's based on a technology. You go find a problem, and typically it's the other way around. You need to find a problem, and then hopefully and very likely AI will solve it, right? So, but the most important thing is you go out, talk to 100 customers, get back with feedback, and iterate. And the faster you iterate, the better off you're going to be.
One very small thing that I want to add, that is a mistake that I did. I mentioned I started 3 times before I just built it myself, and that's what I should have done from the beginning. Try to build a minimal viable product of this product that you want to build. Think of the easiest way to validate your idea that doesn't take a lot of work, money, anything, something that you can build in a day or 2. I mean, you have AI now. I started in 2017. We didn't have ChatGPT back then. Now you have a lot of tools that you can create whatever it is that you want to build in under a day, and then go out and talk to your customers. But don't think a lot about this perfect product that you want to craft. Just validate the most simple and the most important factor of the whole product that you want to do. Because there are some founders that say like, no, but it needs 10 different features for it to work. Just validate the most important ones and talk to your customers and build upon that. Yeah.
That was a great answer. Thanks. Any questions?
Hi, thank you so much for this conversation and the panel. It is very interesting. Laura said something about the venture capitals, like they provide suggestions and they opinions. And how do you handle the relationship between having your company and the venture capitals that are making suggestions or changes of directions or meeting new people? How is that relationship? I am wondering. Thank you.
Sure, thank you for your question. This is actually very important to understand as a new entrepreneur. You want to have a relationship with your venture capitalist that is something like an advisor. And so the best structure for this would be for, if they're an early investor and you know that they're going to be very strategic for you, you could offer them a board seat to your company in exchange for their investment. But you have to ensure, one, that they're actually valuable enough in the advice that they're going to give you, in the network that they're going to provide for you, to be worthy of that board seat, because you only have so many board seats to go around. And then also that what you're getting in exchange is obviously going to be something that you can actually use. And then also what kind of powers come with that board seat, if they're going to be able to actually vote, as far as the changes that are going to be made within your company, or if you would prefer to have them as something as more of an advisor that you can ask for questions, but then make the decision on your own, essentially what happens within the company. There are a lot of cases now, especially with things like venture studios, where the venture studio actually has a larger ownership percentage in say in how the company is developed, what decisions are made, and they essentially are like founders with you in building that company. And in that case, because they have that much ownership share, you actually have to treat them like a founder, and they're going to go through vesting with you and everything as well. So you want to make sure not to have a relationship with a venture capitalist who is too imposing if you're not interested in having them be super imposing about your company, right? This is the problem you want to solve, that you're passionate about. This is your baby, right? So you really have to hold that space to be the owner of that company. And if you allow for a venture capitalist to come in, essentially, and take over, then you're really not the right person to solve that problem, for one. And two, this isn't really the relationship that's going to be good for you long term.
A lot of people don't understand when they're first starting out that VCs, if they get a spot on your board, they can eventually actually even vote you out of the company. They can replace you as a CEO. And after you're putting in years and years of hard work, developing this thing, trying to solve this problem, to all of a sudden be kicked out of the company, it could be very devastating. So you have to be very careful with these relationships. As I stated earlier, it's like a marriage. It's a huge long-term commitment, often because venture capitalists won't receive a return on that investment until about 10 or so years after the investment. So the only way that the VC earns money back is if you sell the company, so you can get acquired, you can sell it, you can go IPO, become public on the stock market. That's the only way that the venture capitalist gets money back, the return on their investment. So in the meantime, you have to have that person, like a founder in your company, like a member of your board, or like an advisor for many, many years to come. So make sure you really like that relationship. Very good question. Thank you.
Thank you. And one thing, it might not be clear, VCs are not the only source of funding. There are smaller investors called angels. Those are usually former entrepreneurs that now are investing in other companies. And in general, I found that other founders are always happy to help, and they're open to listening to your ideas and give you feedback, and they might become investors in the future. And there's also F and F, friends and family, and some people call them friends and fools. But these are people that know you, and they're investing in you because they know that you're amazing. So there's multiple sources, and yeah, you should explore the options.
Can I add to that point as well? So additional sources of funding, of course, would also include accelerator programs. So they will sometimes offer you the opportunity to participate, sometimes for no equity at all, and they will invest in your company, which is a really amazing opportunity if you do get to do that as well. This is a really great way to iterate on the business model, on the marketing, on different aspects of the company, especially if you come from a more technical background and you don't really understand the business side. You can get so much knowledge and experience from participating in an accelerator. If you need time to build the technology and do the research about how to solve the problem, do think about traditional grants. Like we've invested in companies as well that went through 20 years of research and development relying on grants before they decided, okay, I have something that's good enough to turn into a product and to start a company with. So, don't look bad on grants just because, they're primarily associated with doing traditional research. Like they're also used in building businesses, and they're a great way to figure out, is this the correct solution before you actually launch the company itself.
Thank you very much. Do we have time for one more question? Okay, one more question.
Hi, thank you for the panel. It's really good. I have a follow-up question with that. So when you have a startup, in general, you start applying for equity-free funding, so that you can work on the MVP, for example, and you start validating as early as possible your hypothesis. When do you choose to jump for that extra investment that requires part of your equity? Is there something that you could answer related with that? Thanks.
Yeah, thanks for the question. I would say there's no one, reason to decide to take venture capital. I think a lot of companies take venture capital because, one, they want to scale. They've found potentially a new market that they want to open up to. They want to bring on more employees. They want to hire. Maybe they need access to more compute power, for example, if they're an AI company, and they don't have a traditional means to generate the revenue to be able to provide for those things on their own. These are all great reasons to potentially take venture capital. But again, you want to be very careful that it is actually the right decision for you to do that at that time, and that there isn't maybe a lower cost solution for you in the meantime before you have to make that choice, because you're giving up a lot in exchange for that investment. You're giving up ownership stake, you're giving up autonomy, and now you are essentially held to these other people and other opinions, all these other stakeholders that are going to have a say in your company and how you make decisions moving forward. So yeah, maybe some of the other panelists can talk about why they decided to take venture capital for their particular companies and instances as well.
I was going to say, like, like for that jump, I completely agree. Like, you don't know, people shut up. I had no idea what I was getting into. I think it's like, I'm a father of 3 girls. It's amazing. It's the best thing that happened to me. But it can be painful at times. And I think starting up is something like that. You never know when you're ready to become a parent. And it's the same thing with startups. The only way to really know is to like go and do it.
Leap of faith.
Yeah. It is. It's exactly that. And but just like being a parent, it's amazing. So I'm super excited. I'm very glad I made this choice, and I'm sure that all the panelists also agree. Well, thank you, everyone. It's been an amazing event. I want to thank this amazing panel. It was great to have you here. Thank you, everyone, for the questions. And I guess we can call it a day.
Thank you a lot for this amazing panel. And people, before you leave, so remember tomorrow we are starting at 10, so you can sleep a little bit more. And it's not going to be here, okay? It's going to be at Seina, sorry, and Seina was before, which is close to the Hotel Fundador, right? So Seina, great. See you tomorrow.